So using the workout classes that we just implemented, let's now finally implement the feature of creating a new workout from our user interface. And to start, let's take a look at our flowchart here. And so basically, this here is the action that we're interested in now. So when the user submits a new workout. And so we already added this new workout method here as an event handler function for that event. And so what we want to happen now is to basically render the workout on the map, render the workout on the list, and then this part here we're going to leave for later. So this one is the high-level overview of what needs to happen, but actually there's a lot more things involved than just these immediate actions that we see on the user interface. So actually we're going to leave the rendering here for the next video, because as I just said, there's actually a lot of other stuff that we have to do. All right. So as you see, we are back here at looking at the flowchart, because now we are back to being interested what we actually need to implement and not how to implement it, right? So the architecture here, again, is about how we implement it. And so it contains all of these different methods and these low-level details, while the flowchart here is really more of a high-level overview of what we want to implement. And so for now, we don't need the architecture anymore because we already put everything into the code that we had here. Now, if you're really curious and want to spoil the experience, basically until the end of the section, then you can already take a look at the final architecture here, but I'm not going to do that. So I just want to now keep building the rest of the application as we go. Okay, but anyway, since this is so high level here, let's actually go to the working demo application and see what exactly happens. So let's reload here. And so let's click just somewhere. And then you see, as we already know, the form opens. Then we can input some data here. And then our application needs to get this data. It needs to check if the data actually makes sense. And then we need to create a new object for this workout and render it right here and also on the map, of course. And then finally, after all that, the form is also hidden. So everything I just said is going to happen whenever we hit enter here. So you see, of course, the marker was created. It was rendered here. All the input data had to be checked and a new running object was created. So for example, if we add another one, but without any data, then we are going to get this alert. Or the same if we input any data that doesn't make much sense. For example, a negative number for the cadence, which is of course impossible. And so again, we get this error here. So input validation is an important part of creating any application that works with user inputs. And so let's now actually work on the function that is responsible for doing all of this. And for starters, I will basically document everything that we need to do here using comments. So first, we need to get data from the form. Then we need to check if data is valid. Then if it's running, so if the activity running, then create running object. And if the activity is cycling, then of course, create a cycling object. Then add the new object to the workout array. And so, yeah, instead of activity, let's actually call it workout here. Then we want to render workout on map as a marker. And finally, we want to render the new workout on the list. And finally, also, we want to then hide the form and clear the input fields. So you see, there's going to be a lot of work. Let's put this one for now, at least, here, even though it's not going to really work like this. But okay, so with this, we now have all the steps lined out. And so let's get started. And we're going to start by getting the data from the form and starting with the type. And type is already stored at the variable input type. So that's all the way up here. Let's bring that down actually. And we could even add these elements here basically as fields also inside of the application. But in this case, I prefer not to do that, because then every time that we wanted to reference one of these elements, then we would always have to use like this.input distance or duration and so on and so forth. And I just don't really like that. But anyway, let's now take the values of input type, distance, duration, cadence, and elevation. And these two here are not that straightforward, but let's see that in a minute. So input type dot value. And so input type is actually a select element, but still we get the value using the value property. Let me just show that to you. And so, yeah, here it is. And so each option has this value. And so for running, the value is running with the lowercase r, and for cycling, the same. Okay, and so again, the value will be whatever of these two is selected, and then we get this value here. And so that will be important in a minute. But anyway, let's now take the distance. So that's input distance dot value. And remember that this always comes as strings. And so let's convert that immediately to a number. And then the duration, let's do the same here. Input duration dot value. Now about the cadence and the elevation gain, we actually don't want to get them here right in the beginning, but the cadence we only want to get if it is a running workout, and the elevation gain we only want to get if it is a cycling workout, because that will then make it easier for us to validate the data. But more about that in a second. So for now, let's actually check what kind of workout we are dealing with. And so all we have to do is to check the type. And if it's running, then we want to get the cadence. So let's call that cadence as well and convert input cadence dot value to a number. But if we are dealing with cycling, then we want the elevation gain. So let's call this one elevation, and here it's also called input elevation. Now, okay, and so now let's check if the data is valid. And so we will now do that inside of each of these if statements. Now you might have noticed that I actually created two separate if statements here instead of an if-else statement. And that's just something that you will see more and more in modern JavaScript. So the if-else is not really that much used anymore. And I think that actually it looks a lot cleaner like this. So to simply have two if statements. So anyway, let's now check if the data is valid. And what does it mean for the data to be valid? Well, first of all, each of them should be a number, right? And so let's do that. And here again, we will actually use a guard clause. So again, what a guard clause means is that we will basically check for the opposite of what we are originally interested in. And if that opposite is true, then we simply return the function immediately. And so once again, this is a trait of more modern JavaScript. So kind of a trend that you will see in modern JavaScript. But anyway, let me show you what I mean here. So if the distance is not a number, and remember that for that, we use number.isFinite. So if the distance here is not a number, then we want to return immediately. So we want to return, And then we can also do some other code here. So let's create an alert. So inputs have to be positive numbers. So for now we checked for numbers, but we didn't yet check for positive. But let's leave that for a second. So we should already be able to test out if this if here is going to work. So let's just see if our map appears here. Let's try to reload here. And for some reason, sometimes this takes a really long time. So sometimes while I was developing this application, I waited up to like 2 or 3 minutes. And I don't know why that happens, but yeah, I hope that never happens for you. But in case you see long waiting times, that might be normal. All right. But now here it is. And so let's input some invalid distance. So like just any letter. And then we get inputs have to be positive numbers. So that is already working. And now we just need to do the same with the other inputs. So we want the same for the distance. So number dot is finite. So actually for duration. And then the same thing for number dot is finite cadence. Okay. Now this is actually not correct because we don't want the end, but instead we want or. So this one here should happen whenever one of these three here is not a number and not when all of them are invalid numbers, right? And so that's exactly what or means. So if this one is an invalid number or this one, then we can get this alert. And so the reason why we did this checking here inside of this if block is because if we did the same out here, then we would also want to check for the elevation, right? But as we know already, only one of the cadence and elevation can be defined at the same time. They cannot both be defined at the same time. And so performing this check would then be a little bit more difficult. So now we can go ahead and do the same thing down here, so in the cycling part, but let's actually refactor this code here already and basically create a small function which takes a number of arguments and will then validate if all of them are numbers or not. Okay? So basically we want it to work like this, but we want to write this in a more clear and more beautiful, so to say, way. All right. So let's create a very simple helper function here. And let me call it valid inputs. So a very simple arrow function. And this can take an arbitrary number of inputs. And remember that when we use REST parameters like this, then we get an array. So inputs is an array, and we now want to loop over this array and basically check if all of them are positive. Now there's actually already a predefined method in JavaScript that is very helpful for that. So remember that we have a nice little method called every. And so let's use it here, and then I will quickly explain what it does. So the current input, and then number dot is finite the current input. So basically this will loop over the array, and in each of them it will check whether the number is finite or not. And then in the end, the every method will only return true if this value here was true for all of them. So for all elements in the array. But if only one of these values here was not finite, so if the result here was false for one of the elements of the array, then every will return false. And so that will then be the return value of this arrow function, right? And so then here we can replace all of this. And let's actually just comment it out. We can now say if not valid inputs, and then pass in the three that we're interested in. So distance, duration, and cadence. And again, here we are inverting the condition, right? So if all of these are numbers, then this here will become true, right? But whenever this is not true, then that's the case where we want to return from the function and show this alert window. All right. So let's copy this and do the same here for the elevation like this. And here I will get rid of the comments. And so this is the first check. But in fact, we also want to test if the numbers are positive, because otherwise they don't make much sense. So let's reload here again. So right now, if I put a letter in any of these, then it's not going to work, right? But if I put in a negative number of steps, then this is perfectly acceptable, and we already get the marker here printed to the map. But in fact, we don't want this to be acceptable. So negative values should not be allowed for any of the three, but in the cycling, it should be allowed for the elevation gain. So here we can, of course, have a negative number, which happens when we go basically down a mountain, right? So that's simple as well. All we have to do is to check if these three values here are greater than 0, and the same for these two, but not for the elevation, okay? And so actually, to make this really cool, I will create another small helper function like this one. And it might be a good habit for you as well to get used to these small helper functions. So they're especially nice in these situations for testing complex conditions. So instead of writing all of this and plus checking now for positive numbers, we can simply export that into one or two functions, which then do the job for us. So here I'm going to create a function called allPositive, and this one is going to be almost the same as the previous one. So it takes in an arbitrary amount of inputs, and then we will only return true if all of them are greater than 0. And so here the every method is very useful again. So input, and then here we need some condition that returns true or false. And so that's input greater than 0. And so let's now use that here. And so we want basically if all of the inputs are not valid, or if there is basically any number that is not positive. So if not all positive, distance, duration, and cadence. All right. So in this case, we then want to get this alert. And now here, let's do the same for the cycling. But here we are only interested in distance and duration, because again, the elevation might very well be negative. So this is a little bit complex validation, but that's no problem at all. That's why I spent some time here on this validation without any problem. Now it would have been a little bit easier if we didn't have these different values of elevation and cadence for the two different workouts, but we do have it, and yeah, so we have to solve that problem. And so I think it works really nice like this. Let me just check it out here one more time now with these negative values. So if we have a negative distance, then now indeed we get the alert 2, except for cycling. So let's remove that one, and 2, 2, and here -2, but that still works. And so clearly our validation logic here is just fine. Great. So next up, let's see what we have to do. So actually we still have to finish these ones. So if the workout is running, then create a running object, and otherwise create a cycling object. All right. And then afterwards, push that object to the workout array. so add it to the array. And for that, we're going to use the push method as always. So let's start with this one here, right after this guard clause. All right. And so here, let's say workout should be a new running. And now let's see what we need for running. Or actually, we can probably just hover this. And indeed, here we have the coordinates, distance, duration, and cadence. All right. So where do we get the coordinates from? Well, we already know from the marker that they are right here. So in this .map event .latitude longitude. So we know this because we already used this data before to render a marker on the map. So let's get this one and paste it here as the first argument. But actually, this here is now going to be an object. So we know that because here we used the structuring to get the latitude and longitude out of that object. But up here we said, so in the class definition, that indeed we want an array, right? So let's simply get this code from here to up there. So here, and so basically create the latitude and longitude variables here based on this object. And so then here we can define an array with that data. So lat and long. So we already have our array of the coordinates just as expected. And then all we need is distance, duration, and cadence. And then we can take this dot activities, and I think we didn't even create that one yet. So that's up here. And now again, we could do it right here like this. So basically the more classical way. So this dot workouts would be an empty array. But again, in this project, I chose to already use the class fields specification. And so this will become part of standard JavaScript very soon. And so therefore, I can create a class field like this, and I can even make it private, just like the other two. But this time, I actually already initialized it here to a new empty array. And so now we can take that. So here in new workout, we can say this dot workouts dot push this new workout. Now we are going to do basically the exact same thing down here. And so this here is something that always needs to happen. So in both cases, and so let's not repeat that and instead put it down here. But then we have the problem that this workout variable is defined here in this block scope, right? And so because of the scope chain, as we already know, this workout variable will then not be available outside of this block, right? But we want it outside of the block, so right here. And so therefore, we put it right here outside. So let workout, and then here we simply redefine that. And then let's simply take this and put it here again, but this time, of course, with a cycling, and then still the coordinates, distance, duration, but here the elevation. All right. The next step here is to actually render the workout on the map. All right. But before we do that, let's actually take a quick look at the console and see our workout there. And so with that, we can already check if all of this that we have up here is already working, right? Okay, so let's wait for the map. And now let's click here and add a running. So 5 and 25 with 170. And indeed, here we get our running object. So it has the coordinates. And so this worked. And of course, it has all the other data as well. This ID is now corrected, as you see. And also the pace is calculated here based on this input data, right? And so indeed, the most complicated part of adding a new workout is already completed. So that's beautiful. Let's just try the same with cycling. Let's say 10 kilometers in 10 minutes with 30 meters. No, and I didn't even click anywhere on the map. Okay. And so that clearly means that we are still missing a step, which is to hide the form. But anyway, it simply took the coordinates from earlier, and then it added all the correct data here as well. So indeed, it is now a cycling object, while before it was a running object. Let's just do that again here, but this time with clicking, so that I can show you something. All right, so it still says workout, and we're gonna fix that in the next video. But for now, what I want is the cycling actually to have this orange border. So just like this one. All right, so orange is for cycling and green for running. And so let's quickly do that. So in our CSS, I think I showed you earlier that we have running pop-up and cycling pop-up. And these two values here are essentially simply the value of the input type. So this one here. And so here we can simply do a template literal and then plug in the type here. And now actually let's also export this here to its own method to make this add workout method here a little bit cleaner. All right, so let's add down here render workout marker. Let's grab this code here. And so now all we need to do is to call this dot render workout marker. And here we need to pass in the workout object, because otherwise it's not going to work. I mean, right now we don't even need the workout yet, but later we will. So we want to display some kind of data about the workout, and so let's pass it in. So workout there, and here let's actually call it workout as well. And so here, instead of displaying this, let's simply display workout.distance. Okay, just for now, just so we are actually using the workout here in this method. Okay, you see that we are also using the this keyword in this method, but actually that's no problem in this case, because here we are actually calling this one here as a method of the this keyword. And besides that, we are also calling it ourselves. So it's not a callback function of any other function in JavaScript. And so therefore, the this keyword in this method here will still be the current object. And so no need to using bind in this case. And so finally, the last step is to actually render the workout on the list. And this one I'm going to leave for the next lecture, because this one is going to take a little bit of time in order to format all the HTML correctly. So let's give this one a save. And so besides that, this one is basically complete. And so let's quickly check it out one more time just to see the cycling pop-up. So let's see right there, cycling 10, 10, 10, values don't matter. Oh, and here we do actually have an error, which says that latitude is not defined. And so indeed, here it is not defined. So instead, these coordinates should of course come from the workout itself. And so that itself is already a reason enough to pass in the workout argument here into this function. So now it becomes very important for the first time to have some data in the actual workout object, because here we do need that in order to tell JavaScript or actually in order to tell Leaflet where to display this marker. Okay, so it's the data that's coming directly from the workout. And so now this should work, or maybe it shouldn't. So I'm looking at this variable here, and right now the type is of course also no longer defined, right? So we get the type here from this one, but of course this type variable is not going to be available right here. So how do we fix that? Well, ideally we should get the information whether the current workout is of running or of cycling right from the workout object. And actually that's a pretty good idea. And so let's add that value to the cycling and to the running. However, it doesn't make much sense to always pass that in. So we already know that running is always going to be running and cycling is always going to be cycling. And so we can simply add basically that type right here. And so let's do that. So again, we are defining a field here. So cycling. And so this value type will now be a property that's going to be available on all the instances. Okay, so again, this would be the same thing as doing this dot type equals cycling like this. Okay, and now the same for running like this. All right, and so now we can use that here, and we will actually also need that in some other places. And so this is indeed a good thing to have. So workout dot type, and so now this will whether be running or cycling. So let's test that now with cycling. So cycling and we get another error. Okay, so it failed to execute append child on node for some reason, but let's go back to that in a second. For now, I just want to see if actually the type is there, and indeed it is. So that's great already. Now let's just go back and see why this error here is happening. Well, there's no append child method anywhere here. Let's just set this here to something else. But that's probably not the problem anyway. So probably I shouldn't have changed anything, because now the error message here will be gone, and then I cannot read the stack trace there, which is what we call to that list of errors. Oh, but now it actually worked. All right, so the problem there was that we were actually probably passing in some value that was not a string, and so therefore, for some reason, Leaflet created some problem there. But anyway, we will take care of this string here in the next video. For now, I just want to create just a running one here. And so this time it turned out to be green. And so indeed, here the type is now running. All right, so this was a very long video. And so let's finish it here. And as I already said, in the next one, we will then finally render the workout also here on this sidebar. So let's now render new workouts in the sidebar of our user interface. And so what I mean with rendering is to basically create a list item like this for each workout. All right. So each workout here contains this like short description containing the type of the workout and then the date. And actually that's also exactly what we get here in the pop-up. And then of course we have all the relevant data of the workout in case. And so let's now go back and do that. And here we are still in the new workout method. And so down here is where we're going to render the workout. However, just like before, we are actually going to create a new method, which is going to be called render workout. And here I'm seeing that I forgot the underscore, like this. And so now let's create render workout. And so this function will also take in an object of a workout. All right. And so here, all we have to do now is to call this method. So render workout, and then pass in the workout. And so with this, we delegated this functionality to this method. And so let's now start working on it. And so what we're going to do here is basically some DOM manipulation. So we're going to create some markup, so basically some HTML, and then we will insert that into the DOM whenever there is a new workout. And so let's actually get the code right here from the HTML, and I already have it here commented out. So let's actually go up a little bit more. So you see that we actually have a UL, which stands for unordered list, called workout. Then in there, the first child is actually a form. Okay, and only after that, we then start adding these list items with the class of workout. Now the first one here is a workout for running, and then the second one is a workout for cycling. All right. So let's basically take what both of them have in common, which is basically this first part here, which is the distance in kilometers and also the duration. So these are the same, but then on running, here we have the pace in minutes per kilometer, while here we have kilometers per hour, which is the speed. And here, of course, we have the elevation gain, which has this emoji here, while here we have the steps per minute. And so let's start by taking the HTML here that is common to both workouts, and then after that we will implement this remaining part of both running and cycling. So I'm copying it, and so then here let's create const HTML, and then as always we are going to use a template literal for this, because they are really amazing. They're really actually perfect for doing this kind of stuff. Okay, so this indentation looks about right. Now, of course, it would work just the same as it was before, but this then looks a bit nicer because it follows the natural structure of HTML. Okay, and now all we have to do is to replace everything here with the real data. And let's start with the easy parts. So this one here is, of course, the distance. And so that's at workout.distance. And then down here we have workout duration. .duration. Then up here we actually also have the ID. And so here we once again have this custom data attribute, which in this case I called data ID. And remember that we use data properties like this one to usually build a bridge between the user interface and the data that we have in our application. And so in a future video, this one here will become very important. But for now, let's simply add the ID here, just like before. So workout.id. Then next up, here we need to specify whether the workout is a running or a cycling workout, because it's this class here that will then give the list item that green or that orange border. So remember that is stored at workout.name. Then here we have this emoji here, which is for running, but for cycling we have this other one. So this guy on a bicycle. And I hope that you can see these emojis just as well as I can here in the video, because I know that I think on some systems this doesn't really work, but in that case that's of course no problem. It doesn't really matter if you can see the emoji or not. But anyway, what I'm going to do here is to use the ternary operator to check whether the runner here should be displayed or the cycler. So that's easy. Workout.name, and then we just need to test if it is running. So if it is, then we want basically this to be the output, and otherwise this cycler. And here I need to close that, and that's actually it. So one more time, the ternary operator is super important. So as you see, we are still using the fundamentals that we learned right in the very, very first section. So I said back then that they were important, and indeed they were. Now finally, here we have basically this description of the workout, and it is composed of the workout name essentially, and then also the date, but nicely formatted. And the way that we're going to generate this description is by adding a new method on the workout, which will then create a description like this one immediately when the workout gets actually generated. Okay, so as I was just saying, here in the workout, I will create set description. And so this is where we now need this array that I gave you in the beginning with this month. So I didn't feel like writing it all out, and so here it is. And by the way, I have this comment here, which is something that we can use to tell Prettier, so that Prettier extension that we are using to format our code. So this comment here we can use whenever we want to tell Prettier to ignore the next line. So let me see what happens if I take this out. So then you see I have everything here line by line, and I don't like that. And so this is much nicer in this case. Okay. But anyway, let's now set the description. So this dot description. So the description will be based on the name of the activity. And actually, I don't mean name, I mean type here. And I believe that down there I used name instead of type. So let's check that. And yeah, so for some reason I used name. Hopefully you didn't get too confused by that. So of course that is workout.type and not .name. So it's the type that can be either running or cycling. All right. And so that's what we will use now here to create the description. So a new template literal. And then here we actually want to make this type here uppercase. So the first letter. And so we can take this dot type, the first character, and then to uppercase. And so this is nothing new. We have done this many times before. And then simply the rest of this type. So slice starting from position 1. So that is the type of the activity in uppercase on. And so now we want basically the month and also the day. So we know already that we have the date of the workout in this dot date, and then we can use get month on that. And so remember that this will be here a number between 0 and 11. And so that's very nice for a zero-based array, because we can now essentially use this number here to retrieve any value out of our month array. So if getMonth returns 0, then month at position 0 is going to be January. And the same is of course true for all the other months. So this one here will give us the month, and then all we need is the day. And so this dot date dot get date. And that should be it. So now whenever a new object is created, then automatically the description should be set. And so here we now need to do, of course, this dot set description. All right. And in fact, it should not be here, but it should be down here in each of the child classes. So why is that, you might be asking? Well, that's because that's the class that contains the type that we need for this calculation. Okay, so we need to cut that from here and actually calculate it in each of these. And of course, this will work perfectly fine because through the scope chain, this constructor method will get access to all the methods of the parent class. And so of course, that includes this one here. And so then as the method is executed here, it will also get access to the type. And so this is the reason why we can use the type here, even though it is not defined in this class, but only in the child class. So again, we could not call this method on a workout object because that doesn't have a type. But that's no problem anyway, because we never actually create new workout objects. All right, but with all that being said, let's now come back here and use this here. So workout.description. So that's the part that is common to both. Now let's get the rest of it, so all of this, but this one is only for running. So let's copy it. And now here, after this part, or actually here, we can now say if workout.type equals running, then we want to add something to the HTML. So HTML plus equal, and then this code right here. So give it a save. Then here, let's fix the indentation, or actually it's good like this. Well, actually it isn't. So I'm just using multiple cursors, and yep, that's better. Just do the same thing here. Okay. And so now here, of course, we need to change it to a let variable, because otherwise we will not be able to add anything to that string. And so here, let's now write workout.pace, and then down here, so that's workout.cadence. Now this value here is actually calculated by JavaScript. And so the result of this calculation might be some very weird number. And so let's simply round that to 1 decimal place. So 2 fixed, and with just 1 decimal place. Okay. And now just copying this part. So if it's cycling, then we want to get just this part. So again, this is the common part. This is the one that is different. So again, add on to the already existing HTML string. And then each time the indentation is a bit different. Don't have any idea why that is. But now it is correct. And here, this is probably the speed. And then here, it is the elevation gain. So that's, I guess, just called elevation, but I'm not sure. Let's just go back there. So yeah, it's called elevation gain here. We could have just called it elevation because that's how it's called in other parts of the application. But never mind, let's just leave it like this for now. And here, this speed is also calculated by JavaScript. So let's round this one as well. And with this, we actually have the HTML generated. Now, all we need to do is to insert that HTML into our DOM. So where will we inject this HTML? Well, let's take a look here at the parent element, and that is workouts. However, as I mentioned before, the first child of the workouts is actually this form, and only the second element should then become the first activity. And therefore, we cannot simply attach the new workout element to this UL element, because we could either insert it as a first child or as a last child, but we don't want any of those options. So instead, we will insert it close to this form, but basically insert it as a sibling element. All right. So again, I will take the form, and then that is where I'm going to call the InsertAdjacentHTML method. So form.InsertAdjacentHTML. And then here, remember, I have to choose between 4 strings. And so that's these 4 here. And so the one I'm going to choose is after end, because this one will basically add the new element as a sibling element at the end of the form. So we discussed these strings before already, so you can always go back there if necessary. Okay. And with this, I think we should be complete. We already called it up here, right? And so let's now actually try it. So let's just reload here manually. Okay. And now let's just add a simple running. And now we get a problem. So 2 uppercase is not a function. And indeed, it isn't. So it has to be uppercase with the C uppercase. So let's see now. And again, just putting any numbers here. And there it is. So here is our very first workout rendered to the user interface. So that's beautiful, really cool. Let's now try this with cycling as well. And yeah, it does appear here, and also it appears before the one that we had previously. And so that is the effect of choosing the after end string in the InsertAdjacentHTML method. All right, so that's amazing, but what we need to do next is to then actually hide this form whenever a new input here happens, right? And so let's go do that now. And so we need to go back here to our, well, where is that? Here in the new workout. So here we want to hide the form. And so let's create yet another method, which is going to be called hideForm. So I can already copy or actually cut this one here and call the method before I've written it. So that's no problem. So hide map will be the name of this method. And now let's actually create that. And of course, it's not hide map, it's hide form. So let's do it here right after show form. So that makes sense, right? So hide form. So the first thing that we need to do is to empty the inputs. And then we need to add this hidden class back on. All right, so that's add. But as we will see in a second, this is not yet going to be enough. But let's actually see what I mean here. So did you see this animation here that happened in the beginning? Well, we will need to undo that here in a second. So you see that this one here basically did slide up a little bit, right? But that's not what we want. So here in this version of the app, let's see what happens. So as the form appears, everything slides down here. And now watch what happens as I hit enter. So you saw that? Basically, it looked as if that form was replaced with this new activity here. And so to do that, it's not enough to simply add back the hidden class here, because that will then also trigger the animation. So instead, we need to hide the form immediately first. So form.style.display. So we immediately need to set the display to none. But then we will actually have to put it back after the animation had finished. So let's take a look here at the form style actually, so I can show you what I mean. Okay, so this is the transition that I mean, and it is because of this one that the hidden class has that animation of sliding. So that's this transform here. All right. So this animation happens over 1 second, and the original value of the display property is grid. And so what we will do now is to basically, after 1 second, set this display back to grid. So that's kind of a dirty trick here, but in order to build the layout like this is what we have to do. And it's also a good time to bring back our setTimeout function. And remember that all that setTimeout does is to call a certain callback function after a certain time. So let's use a simple arrow function here to make it really simple. So form.style.display should be set to grid, and this should happen after 1 second. So 1000 milliseconds. And so, yeah, let's see now. All right, so again, you saw that animation happening there. But now let's see if we get our desired result. And yes, there it is. So indeed, we did now immediately hide the form, and then after 1 second, we brought back the original display property. And so all that's really left to do is to basically add the same description that we have here to this pop-up. And we will also add a nice emoji, so this running guy for running, and then cycling, as you see here, for the cycling workouts. Okay, and this code we can actually get from here. So from render workout, we already have this. So where is the marker? Here it is. So here is where we set the content. And so again, a template literal. All right, so this is how we set the emoji, and then all we need now is the description of the workout. Dot description, and that should be it. All right, so that works beautifully. And now just for cycling. And yes. So here's the cycling emoji, here's the description, and so this now works exactly as it does in our demo. Great. So we are almost finished actually with our application. So let's take a look at our flowchart here. And so what we're missing now is to move the map to the workout location whenever we click on one of the workouts that we just created. And so that's going to be the topic of the next video. In this lecture, we're going to implement a feature that will basically move the map to the position of the workout that was clicked in the sidebar. So the feature that I mean is this one. So when I click one of these, then as I said, the map will move to the position of that workout. And so this is a very nice touch to the user interface. And so let's now do that. And let's say that we're starting with a blank page like this. So the initial state of our application. And so of course, right now, there are no workouts on which we could click. And so in this case, where should we actually attach the event handler to? So this is the situation that I actually had mentioned already earlier. So again, the situation in which we don't have the element on which we actually want to attach the event listener because it hasn't been created yet. And so what we have to do here is one more time, basically event delegation. So what we're going to do is to add the event handler to the parent element. And so in our HTML, we can see that that is this workouts element here. So basically the element with the class of workouts. And so let's see here in the code which one that is. All right, so it's called container workouts. So let's add an event listener to that element there. And remember, one more time, we do that in the constructor so that the event listener is added right in the beginning. So container workouts dot add event listener on click. And then we're going to create a method called move to pop up just like this. So let's copy it and then add it here at the end. Now these methods that we have here, they're not really ordered in any particular way. So I'm just adding them as I go here. Now, anyway, here we are going to need the event because now we will have to match the object or actually the element that we're actually looking for. So what I will do here is to create the workout element. And basically all that I'm going to do is to look at e.target. So that's the element that is actually clicked. And then I will look for the closest workout parent. So closest, which is again, essentially the opposite of a query selector. And so the element that I'm looking for is the one with the class workout. So like this, wherever the click happens here in the element, so no matter if it's in one of these divs or these spans, it doesn't matter, all of it will then basically end up in this li element with the workout class. Because from the element that is clicked, we will move up to this exact element here using the closest method. All right, so once again, closest is a real lifesaver here. It is really, really helpful. And so now let's start by logging this element to the console. All right. So let's wait for it. As always, any values here work. So of course, we first need to have something here. And now as I click it, let's see what happens. And indeed, we get the entire element here. And that works no matter if I click out here or on this emoji or really anywhere. So the closest method takes care of really then selecting this entire element. Now, why is that actually so important? Well, it's because it is right there where I have this ID. And it is this ID that I will now use to actually find the workout in the workouts array. And so once again, we put this here because with this, we can then basically build a bridge between the user interface and the data that we have actually in our application. So in this case, our data in the workouts array. Because if we didn't have this ID here stored in the user interface, then how would we know which is the objects in the workouts array that we need to scroll to? And so we need this ID here so that we can now read it and basically then select the element out of the workouts array using this ID. Now let's just happen when we click outside here in the same container. So you see that this here is still a container outside. And so when we click this now, we of course get null because there is no closest parent with the workout class. All right. And so we will actually have to basically ignore that. And so this is the next step. So if basically there is no workout element, then simply return. And so again, this is a guard clause here. So of course we could have done also if there is a workout element and then the if block, but this is a bit nicer. And so now it's time to actually get the workout data out of the workouts array. So workout is equal this dot workouts, and actually that's like this. And now how do you think we will find this workout? Well, that's right. Just like in the Bankist application that we built before, we are going to use the find method to, well, essentially find an element of the array. So let's create our callback function here. And so each element in the workouts array, I will simply call work. And then I want the one which has work.id equal to that ID that I just showed you before in the DOM. And so that's workout element dot dataset dot ID. So this is, again, nothing new at this point. We used this technique a couple of times before, but this is yet another really great use case of it. And so let's take a look now. If we are able to actually get the correct one. So any random data here works just fine. Then I'm going to click it. And now we get this same error that we already had before. And we actually could have predicted this already, couldn't we? Because remember that this method here is called by the addEventListener method. And so therefore the this keyword in here is not what we want it to be. So let's move up there. So to the place where we add the event listener. So right here. And so just like before, we need to bind the this keyword to actually make it correct. Right? So I already explained before why that is necessary. So let's just try again. Now I'm clicking it. And yeah, here it is actually. So you see that this one has exactly the same ID. Let's just add another one here. And now we get this one here. But again, as I click this one, of course, we still find the correct workout from the array. And so now we can basically take the coordinates from this element and then move the map to that position. So in Leaflet, there is actually a method to do exactly that. And the method is available on all map objects. So we can take our map object that we already have, which is this one, and then we can call the setView method. And I really encourage you to go check out the documentation of this one, but I'm not going to do that right now. So anyway, the setView method needs as a first argument the coordinates. And so that's at the workout dot coords. Then the second one is the zoom level. And the zoom level we actually have already used before somewhere. So I think where we first loaded the map, so right here. And so it would be a bad practice to simply repeat the same number here. And so instead, I will create another field here. So basically another object property here. So that's going to be called map zoom level, let's say. And I will set it to 13. So let's copy this one. So here we need this dot. And now then here the same thing down here. So this dot map zoom level. And finally, we can pass in an object of options as always. Then here we can set animate to true. And then we can also set the duration basically of this animation by saying pan should be equal to yet another object, which should have the duration of 1. So this is all a little bit confusing. But again, if you want, you can read the documentation of Leaflet and then find out why exactly it works this way. So let me give it a save here now. And then let's go back here. So we can get almost rid of the console here. Okay, and add another one here just to make this a bit more fun. And so now let me actually click here And yeah, beautiful, it works. And I click on this one, and of course it then moves to that one. And of course, if I added even more, then that would just work all the same. Okay, and now just to finish this, I want to just add a very small touch here. And that will be to simply count the clicks that happen on each of the workouts. Now, I will not display that number anywhere or something like that. This is just to show you something basically. So essentially it is to make the public interface of these classes here a little bit more complete. Because right now we are actually not calling any of the methods outside of the classes themselves, right? So we are not really using any public interface here on any of these objects. And so I want to just change that just so you can see how that would work. So basically here on all the workouts, let's add a property called clicks. And we will start with 0 clicks. And then we will also have a method which will be called click. And all it will do is to increase the number of clicks. All right, so very simple, but now every object gets this method. And so in each of the workouts, we can now increase that number of clicks. And so that's very simple. All we have to do now is to take the object that we already have, which is the workout, and then using that public interface. So that's just workout.click. And that's actually it. But let's just test this. And also, actually, this will be helpful to show you something else in the next video. All right. And so as I keep clicking here, the number of clicks should actually increase. But for some reason, we get this error here. So let's see what's happening in line 289. So that's right here, telling us that the workout.click does not exist. So why is that? Well, let's take a look at the object here actually. And so in particular at the prototype. And so here, of course, click does not exist, but here it actually is. So indeed, here is the click method, and so the workout should have access to this method. So that is exactly what we learned in the previous section about the prototype chain and about how all of this actually works behind the scenes. So hopefully you remember that. But now I'm actually not sure why this isn't working. Let's go back here and bring back or fake workouts here basically. So these ones, so we can play around with them in the console. So you see that both of them have the clicks set to 0. And so let's use run1.click like this. And then as we look at run 1 again, then the clicks is still at 0. So something is clearly also wrong there. Okay, so here this needs to be clicks, but I'm not sure if that was the actual error. Okay, so now the clicks increased to 2 here. So let's now check adding something here and then clicking it. Okay, and you see that it moved there. Let's click again. Oh, and now it's actually working. So now the clicks indeed increased to 1. So great, that works just fine. And again, this was just a way of showing you that we can, of course, then interact with each of the objects using their public interface. And in this case, we use that using the click method here. So that's it for this lecture. In the next video, we will then fix the fact that when we reload the page, everything is gone. And so actually we want data to persist. And so that is the missing piece in our application, and we will fix it in the next lecture. Let's now use the localStorage API in order to make the workout data persist across multiple page reloads. And let's start with a look at our flowchart so that we can see exactly what we have to implement. So basically the idea is that whenever a new workout is added, then all the workouts will be added to local storage. And so local storage is basically a place in the browser where we can store data that will stay there even after we close the page. So basically the data is basically linked to the URL on which we are using the application. So again, whenever there is a new workout, we will take the entire workouts array and store it in local storage. And then whenever the page loads, so up here in this event, then we will load all the workouts from the local storage and render them on the map and also on the list. So just like we do it when a user submits a new workout. And so like this, when you reload the page, it will then appear as if all the workouts you had previously are still in the same place. And hopefully this makes sense. And so let's now get started. And we will start with this part here. So storing all the workouts in local storage. And remember, that happens whenever the user creates a new workout. And so we have to get started in the new workout method. So down here, we need to add yet another point. So set local storage to all workouts. And here I'm actually going to create yet another method so that we can keep this method here basically nice and clean. So as you see, this new workout method here is basically a bit of a method that does delegation. So we do some stuff here, of course, but then once we're done creating the actual objects, then down here we delegate all kinds of functionality to other methods, like these ones. And now I will also create set local storage. So here I'm of course calling it already, but now I will create it afterwards. So set local storage, and once again, let's add it here at the end. And this one doesn't need any parameters because we will simply get the workouts from the workout property. And so this is how we use the localStorage API. And I say API because local storage is once again an API that the browser provides for us and that we can use. So localStorage.set item, and then we have to give it a name, so workouts, and then the second argument needs to be a string that we want to store and which will be associated with this key here. So basically local storage is a simple key value store, and so we need a key, which is this one here, and we need a simple value which must also be a string. But we can convert an object to a string by doing this. So JSON.stringify. So this is another new one. All right, but we can use this method here to convert any object in JavaScript to a string. And so what we want to convert is this .workouts like this. And that's actually it already. With this, we are setting all the workouts to local storage. Now, I just want to mention that local storage is a very simple API. And so it is only advised to use for small amounts of data. All right. That's because local storage is blocking. And for now, you don't know what blocking actually means, but it is something that's very bad, and we will learn why that is actually in the next section. But for now, what matters here is that you shouldn't use local storage to store large amounts of data, because that will surely slow down your application. But anyway, let's already test this out, because we actually have a way of seeing this data in the browser. So let's add something here. Okay. So everything worked fine. So now let's go here to this application tab. And then here on the left side, you have this local storage tab. All right. And if we click this arrow here and then here, well, then actually it should be here already. Well, let's see if we have everything correctly set up. So we have set local storage, then set item, and here everything looks correct. And here, I believe we are also correctly calling it set local storage. So this should work. So let's simply try it again here. Okay. And now you saw it appearing here, right? So we have the key of workout and then the value. And the value is basically now this string here. So actually here it looks like an object because apparently JavaScript somehow then converts it back to an object, but actually it is stored as a string here in this workouts key. So you see that we have this single workout that we currently have, but of course if we add another one, then now we got this bigger string here. And so it now contains these two objects. And so like this, the local storage always is going to be updated. So it's up to date according to the data that we have in our application. Great. And now all we have to do is to then actually show the data back here on the list and the map once we reload the page. So let me actually show that to you, because here in the application, as you see, the local storage is still there. And so now we will make use of this by then displaying that data back in our application. So remember, when we want to do that, it is right here in the constructor, right? Because this is where we have all the code that is executed right when the application loads. So let's add that here. And I'm going to start with some comments here. Handlers. Then get users position. And then get data from local storage. And so again, I will now call a method that I'm going to create later. So get local storage. And so let's now go ahead and create this method down here in the end. And so now here we do the opposite. So local storage dot get item. And now we simply have to pass in the key. So basically the identifier of our local storage item, because we could set multiple items. So we could set everything of our application. So for example, if we wanted, we could store everything that's in the application in local storage. We would just have to define one key for each of them. And then we could use that key to basically retrieve it back. All right, so let's now store this data. And so here we can then see it for the first time. So now as the page loads, it should display this data to us in the console. And well, it's nowhere to be found. Let's reload here maybe again. So something must be wrong. Oh, and it's called workouts. And here you go. All right. So you see that indeed it is this big string. And so now we want to convert this string back to the objects. And so basically we need to use the opposite of JSON.stringify, which is JSON.parse. So let's try that again. And now indeed we get an array with some real objects in there. All right. Now there's still a problem with this, but more about that a little bit later. Because all the relevant data that we need for now is actually in there. So now let's do something with that data. And the first thing that we should actually do is to check if there is actually some data. So when there is nothing in local storage, then of course the data will be like undefined. So in that case, we don't want to do anything. So let's use another guard clause here and say if there's no data, then simply return. But anyway, let's keep going. And so what we want to do with this data, which is basically our array of workouts, is to restore our workouts array. So we can say this dot workouts should be equal to the data that we just read. So keep in mind that this method here is going to be executed right in the very beginning. And so at that point, the workouts array is always going to be empty. But if we already had some data in the local storage, then we will simply set that workouts array to the data that we had before. And so essentially, we are restoring the data here across multiple reloads of the page. Okay, and so now let's take all these workouts and render them in the list. So this dot workouts, and so we want to do something for each of the workouts. And so we loop over this array, but we don't want to create a new array. And so for each is perfect for this. And now I'm going to call each of them work. And so now I can do this dot render workout, the current workout. And so now it becomes really, really helpful that we have all the logic of rendering a workout in the sidebar here nicely inside of this method, right? Because imagine that we had all this code here inside of this method here. So the new workout method, right? So if we did all of that here, then now we would have to copy that code or we would have to refactor it. But instead, you can start to get into the habit of exporting functionality into its own methods or its own functions. And so then it is very easy to reuse them, such as we are doing now with render workout. Right? So here all we do is to call render workout that we already had written before. So let's now test this. And right now we should already get the two workouts there. And indeed, here they are. So these are the two ones that we had created previously. And so we see that they did indeed now persist across loads. Now we also need to add them here on the map. And so for that, we are going to use our render workout marker method that we also already have. And let's start by actually putting it here, just so I can show you that it's actually not going to work. But then it becomes easier to explain why it doesn't work. So let's see. And so here we get cannot read property add layer of undefined. So indeed, we get an error when we try to add this first workout also to the map. So let's go back and think why that is. Well, once again, remember that this method here is executed right at the beginning. So right after the page loaded. And so we are trying to add this marker to the map right at the beginning. However, at this point, the map has actually not yet been loaded. And so essentially, we are trying to add a marker, let's say where that is. So we are trying to add this marker to the map, which is this one here, which isn't yet defined at this point. And so once again, this is a first glimpse into the nature of asynchronous JavaScript, which we will talk about in the next section. But what matters here is that you grasp this idea that the map is not yet created right at the beginning when the application is first loaded, right? It takes some time. So first, the position of the user needs to be get using geolocation. So this one here. And then after that, the map has also to be loaded. So there's a lot of stuff that has to happen before we can actually render any markers on the map. So instead of trying to render the markers right at the very beginning, we should only do that once the map has been loaded. And so we can put that logic right here in this method of load map. Okay, so here at the very end, basically. So let's get the code from down here. So I will get all of this, but I will then only keep this part. All right. So let's copy this. And so here we will not render the markers. So only the workouts on the sidebar list. And then it is here. So yeah, right here in load map, this is where we will then render the markers, because at this point, the map is of course already available. And so with this, it should be working. Okay, but make sure that you really understand why we have to call this method here and not right in the beginning. So let's see what happens now. And we didn't get any error. And yeah, so now we have the two markers right where I had put them previously. And now let's just add another one right here. All right. And now if I reload the page, then indeed, there is the marker. And this one, and of course, all the other ones as well. Beautiful. So this is great. And our application is now essentially finished. I just want to show you one problem that we have now. And that has to do with local storage. So remember that when I click here on one of these workouts, it will move the map to the workout. And so that's going to be fine. But what also happens is that this clicks property is going to be increased by using the click method that is inherited from the workout class. But watch what happens now as I try to do that. And so we get workout.click is not a function. So why do you think that is? Well, let's try to take a look at the objects that we get back from local storage. So that's this one here. And I know that right now we have a ton of console.logs here, so we should get rid of them at some point. But anyway, for now, let's take a look at the objects that we basically have right now. And so this is currently also the data that is in this .workouts, right? Now, if we take a look at this, then here everything works okay. But now if we take a look at the prototype chain, you see that now it's no longer an object of the type of running, and also not of the type of workout, right? So the entire prototype chain that we had before is gone. So contrast that to one of these objects. So again, the data is fine, but here we actually have the prototype with calc pace, and then that has the click and these set description methods in the workout prototype, right? So the problem here is that basically when we converted our objects to a string and then back from the string to objects, we lost the prototype chain. And so these new objects here that we recovered from the local storage are now just regular objects. They are now no longer objects that were created by the running or by the cycling class. And so therefore, they will not be able to inherit any of their methods. And so in the end, that's the reason why workout.click is now not a function anymore. So again, because the object now no longer has it in its prototype. So you see that this is just the regular methods that are available on any object. All right. So this can be a big problem when you work with local storage and object-oriented programming like we are doing here. Now to fix this problem, we could go ahead and restore the objects right here. So in our get local storage, we could now loop over this data here and then restore the objects by creating a new object using the class based on the data that is coming here from local storage. But that's a little bit of work, and so we're not going to do that here. And so instead, what I will do is to simply disable the functionality of counting the clicks. So remember that when I first introduced this method here, I told you that one of the reasons for it is that I also wanted to show you something in the next lecture. And so that's exactly here what I wanted to show you. So basically, that objects coming from local storage will not inherit all the methods that they did before. All right. And so with that, we are basically done. Let's just get rid of some of these console.logs here, because it's not really a good practice to have them in final code. So we can have maybe one while we're developing, but then at some point it simply clutters like our entire console workout. And so that's not helpful. And here again. And you see that here we still have all of these workouts, of course. Now, actually, to finish, I want to create a quick and easy way to delete all of these workouts at once, at least from local storage. And so let's go back here and basically add a method to the public interface of this class for the first time. So this class is a little bit unusual because right now we don't have any public method. So there's no public interface, but now we will create a reset method here, which we can then use out here or even in the console. And so actually that's what we will do. So using it in the console. So what I want to do in this one here is to basically remove this workouts item from local storage. And so besides setting and getting items, we can also remove items based on the key. All right. And with this, we removed our workouts from the local storage. And now we can then reload the page programmatically. And so then the application will look completely empty. And we can do this with location.reload. And location is basically a big object that contains a lot of methods and properties in the browser. And so one of the methods is the ability to reload the page. So let's try that now. And as I said, I will do that in the console. So let's go actually back to our code just to see where we can use it. So we are creating the app object and then storing it in app, right? And so we have access to this variable here, of course, in the console. So let's take a look at that actually. And you see that indeed, here we have these private fields. And then we have all of these methods here in the prototype. And so one of them is, of course, reset. And so let's do that. So reset. And yeah, it worked. So our application is back to being empty now so that we can add some more realistic data if we wanted to. For example, like this. Or maybe we went cycling right here, which is a really nice location. And here, let's say we took 2 hours and gained 500 meters. All right. And now, of course, everything is back to working here because we got rid of that click method. We still have some loggings here to the console, but never mind. That's not a problem. All right. But what matters here is that our application is now feature complete. We implemented everything from our flowchart. All right. So everything is done here. And so at this point, the final architecture of our application looks like this. So I have all of the methods here that we implemented in the app class and also for workout running and cycling. Now, I'm not going to go over this here now, but it's a good idea for you to actually check it out to get a really good idea of how the different methods call each other in our application. So these arrows that you see here are basically methods calling other methods. All right, and that's it. That's our application. I hope that you liked it and that you had as much fun as I had building it. So this was a really great experience. And now, before we actually finish the section, let's have one more final lecture where I will give you some suggestions of how to improve this application even more. So let's go there right now. Welcome to the last video of the section. So we finished the Mapty project, but to finish this section, I just wanted to quickly address some additional features that we could have implemented in this application. And basically, I'm going to leave them for you as challenges if you'd like to spend some more time on this project. And the first couple of features that you could implement would be the ability to edit any workout or to delete a workout, or also to delete all the workouts right from the user interface. So this is something that you can do in most web applications, and so therefore you could also add that ability here. We didn't implement this together in this application because I just wanted to keep things more simple here and not to create a super huge application that would take ages to build. Now, next up, you could add the ability to sort workouts by a certain field, for example, by distance or by duration. And this one would be probably a little bit tricky to implement, but you can take inspiration from the Bankist application, where I believe we did something like this. Now, another thing that you could do is to actually rebuild the running and cycling objects that are coming from local storage. So basically, you could fix that problem that we run into by the end of the last lecture, where the objects coming from local storage were now regular objects and no longer running and cycling objects. So this would be a nice challenge for you to do and to basically fix that error. Another nice touch that you could use to this application is to create more realistic error messages and confirmation messages. So we just used a simple alert window to display an error message when the input data was not valid, right? But that's kind of ugly and not really real world like. And so therefore you could implement more realistic messages, and maybe you could even have them fade out after some time. So that would be a nice use case of some of the things that we already learned before. Okay, so these are the more easier ones. Let's take a look at a couple of hard ones. So first, you could add the ability to position the map so that it shows all the workouts. So let's say that you went to a different country and did some workouts there, and so your workouts are all over the map, and so therefore it would be nice to have a button which shows all the workouts on the map at once. However, to solve this problem, you would probably have to do a lot of Googling about the leaflet library and dig deep into the documentation. Because, of course, this functionality would depend entirely on the leaflet library, right? Okay, but still, this would be actually nice to see. But let's see another one, which would probably be even harder, which is the ability to draw lines and shapes instead of simply having a point for each workout. So this would be a real challenge, and maybe it wouldn't be such a good idea to actually try this one out, but still, I wanted to just leave this here as a potential improvement to this application. So when you go on a run, of course, the run is not just on a point, but it's more like on a line or maybe like a circular shape or something like that. And so it would be nice to have that instead of just a point. And finally, I have two more challenges to improve this project that you could only implement after the next section, but let me still show them here. So you could geocode location from the coordinates. So you could use a third-party API to plug in the coordinates, and that would then give you back the real location. So for example, you could then call the run a run in Faro, Portugal, because the third-party web API would give you that location data. So a description of the location, not just the raw coordinates. And then besides that, you could also use a third-party API to display the weather for the workout time and place. But again, these two you can maybe tackle after the end of the next section if you feel like improving this project even more. All right, so it would be really great to see some of these features actually implemented by you. And if you do one of them or even more, then make sure to share your results in the course Q&A or even on Twitter. And there you can use one of the hashtags that I mentioned earlier. But anyway, that's it for this video and for this section and for this project. So once again, congratulations for reaching the end of this project, and even more for sticking with this course all the way up to this point. What an amazing achievement. Really, I cannot overstate this. And I'm really happy for you and for all your progress. And now just keep going, because the next section is actually one of the most important ones in the whole course. So I hope to see you there very soon. Let's now continue learning important JavaScript features. And one topic that we haven't touched yet is asynchronous JavaScript. So the goal of asynchronous JavaScript is basically to deal with long-running tasks that basically run in the background. And the most common use case of asynchronous JavaScript is to fetch data from remote servers in so-called AJAX calls. And so that's what we will do in this section, while learning everything there is to learn about promises, the fetch function, async await, and error handling. So this is yet another really exciting section, and so let's get started. Let's start this section by understanding what asynchronous JavaScript actually is, and also learn about the most popular use cases of asynchronous JavaScript, which is basically to make so-called AJAX calls to APIs. Now, to understand what asynchronous JavaScript code actually is, we first need to understand what synchronous code is. So basically the opposite of asynchronous. So most of the code that we've been writing so far in the course has been synchronous code. And synchronous simply means that the code is executed line by line in the exact order of execution that we defined in our code, just like in this small example. So as the first line of code is reached in the execution, it is simply executed in the execution thread. Now don't worry about this execution thread, it's not important here, it's just to make a point of synchronous versus asynchronous code, as you will see in the next slide. All you need to know is that the execution thread is part of the execution context, which does actually execute the code in the computer's processor. But anyway, then the next line of code is executed, and then the next one, all in sequence. So each line of code always waits for the previous line to finish execution. Now, this can create problems when one line of code takes a long time to run. For example, in this current line of code, we have an alert statement which creates this alert window. Now, as we've experienced in the past, this alert window will block the code execution, right? So nothing will happen on the page until we click that OK button. And only then the code can continue executing. And so the alert statement is a perfect example of a long-running operation which blocks execution of the code. So again, only after we click OK, the window disappears and the next line can run. So this is hopefully a nice illustration of the problem with synchronous code. Now, most of the time, synchronous code is fine and makes perfect sense, But imagine that execution would have to wait, for example, for a 5-second timer to finish. That would just be terrible, right? Because meanwhile, nothing on the page would work during these 5 seconds. And so that's where asynchronous code comes into play. So this example contains the 5-second timer that I just mentioned. And if you want, you can pause the video here for a minute and analyze this code before we move on. Now, anyway, the first line of code is still synchronous here, and we also move to the second line in a synchronous way. But here we encounter the setTimeout function, which will basically start a timer in an asynchronous way. So this means that the timer will essentially run in the background without preventing the main code from executing. We also register a callback function, which will not be executed now, but only after the timer has finished running. And we have actually already done this many times before in practice, right? Now, this callback function that I just mentioned is asynchronous JavaScript. And it is asynchronous because it's only going to be executed after a task that is running in the background finishes execution. And in this case, that is the timer. So this callback that we just talked about is registered, and then we immediately move on to the next line. So the main code is not being blocked, and execution does not wait for the asynchronous timer to finish its work. And that's the big difference between synchronous and asynchronous code. So previously, we had to wait for the user to click on the alert window to continue execution. And again, that's because alert is blocking synchronous code. But now, with this timer, the callback is actually asynchronous. And so it's only going to be executed after the timer has finished. And so therefore, we say that it's non-blocking, because in the meantime, the rest of the code can keep running normally. Now, when the timer finally finishes after 5 seconds, the callback function will finally be executed as well. So you see that this callback runs after all the other code, even though in the code it doesn't appear at the end. And so basically, an action was deferred into the future here in order to make the code non-blocking. And actually, we already saw this behavior happening before when we first learned about timers. We just didn't know that this is called asynchronous and non-blocking code. So in summary, asynchronous programming is all about coordinating the behavior of our program over a certain period of time. And this is essential to understand. So asynchronous literally means not occurring at the same time. And so that's what asynchronous programming is all about. All right. Now, as we saw in this example, we need a callback function to implement this asynchronous behavior, right? However, that does not mean that callback functions automatically make code asynchronous. That is just not the case, okay? For example, the arrayMap method accepts a callback function as well, but that doesn't make the code asynchronous. Only certain functions, such as setTimeout, work in an asynchronous way. We just have to know which ones do and which ones don't. Okay? But please understand this very important fact that callback functions alone do not make code asynchronous. That's essential to keep in mind. But anyway, in order to really understand this, let's see another example. So this example is about loading an image. So the first 2 lines run in a synchronous way, one after the other. Now in the second line, we set the source attribute of the image that we selected in the first line. And this operation is actually asynchronous. So setting the source attribute of any image is essentially loading an image in the background while the rest of the code can keep running. And this makes sense, right? Imagine that it's a huge image. We wouldn't want our entire code to wait for the image to load. And that's why setting the source attribute was implemented in JavaScript in an asynchronous way. Now, once the image has finished loading, a load event will automatically be emitted by JavaScript. And so we can then listen for that event in order to act on it. Listening for the load event is exactly what we do here in the next line as well. So here we use addEventListener and register a callback function for the load event. So just like in the previous example, we provide a callback function that will be executed once the image has been loaded and not right away. Because again, all this code is non-blocking. So instead of blocking, execution moves on right to the next line immediately. Then once the image is completely loaded, it's displayed on the web page and the load event is emitted. And since we're listening for that event, our callback function is finally executed. So once more, we deferred an action into the future, making the code asynchronous and non-blocking. All right, and so now at this point, I believe that you have a pretty good understanding of asynchronous code. There is just one more important thing that I need to mention, which is the fact that event listeners alone do not make code asynchronous, just like callback functions alone do also not make code asynchronous. For example, an event listener listening for a click on a button is not doing any work in the background. It's simply waiting for a click to happen, but it's not doing anything. And so there's no asynchronous behavior involved at all. Now, what makes this code example asynchronous is simply the fact that the image is loading asynchronously in the background, but not the fact that we are listening for the load event to happen. So what matters is the asynchronous behavior of a task, like running a timer or loading an image. And there are more examples of asynchronous behavior in JavaScript, like the Geolocation API that we used before, or AJAX calls. And AJAX calls are probably the most important use case of asynchronous JavaScript. And so let's see what AJAX is all about. So AJAX stands for Asynchronous JavaScript and XML, and basically it allows us to communicate with remote web servers in an asynchronous way. Now in practice, we make AJAX calls in our code in order to request some data from a web server dynamically, so without reloading the page, so that we can use that data in our application dynamically. For example, right in the next video, we're going to make AJAX calls to request data about countries. And we can then use that data about countries to build a small application that shows us information about the country that we're currently in. And the possibilities and use cases are endless, but more about that in the next slide. For now, let's quickly understand how AJAX works. So let's say that we have our JavaScript application running in the browser, which is also called the client, and we want the application to get some data from a web server. And let's say the data about countries that I was talking about earlier. So with AJAX, we can do an HTTP request to the server which has this data. And the server will then set back a response containing that data that we requested. And this back and forth between client and server all happens asynchronously in the background, just the way we learned before. And there can even be different types of requests, like GET requests to receive data or POST requests to send data to a server. But there is a whole lecture about this a bit later to really show you how it all works in detail. Now, when we're asking a server to send us some data, this server usually contains a web API. And this API is the one that has the data that we're asking for. So an API is something pretty important, and so let's now see what an API and web APIs actually are. So first of all, API stands for Application Programming Interface. Now, in general terms and on a very high level of abstraction, an API is basically a piece of software that can be used by another piece of software in order to basically allow applications to talk to each other and exchange information. And that's true not only for web development and JavaScript, but for programming in general. Now, in JavaScript and web development, there are countless types of APIs, like the DOM API or the geolocation API that we have been using. So these are called APIs because they are a self-contained piece of software that allow other pieces of software to interact with them. For example, our map-t application that we built in the previous section. Also, we can always implement a small and simple API in a class where we make some methods available as a public interface. Remember? So again, objects made from a class can be seen as self-contained, encapsulated pieces of software that other pieces of software can interact with. And so that fits the definition of API, right? But now let's talk about the important type of API that we are actually interested in when we use AJAX. And that are APIs that I like to call online APIs. So an online API is essentially an application running on a web server which receives requests for data, then retrieves this data from some database and then sends it back to the client. So just as we saw in the last slide, right? Now, when building applications in practice, we simply call these online APIs API. And many people will also call these APIs web APIs, or again, just simply API. So the term online API is actually a term that I came up with myself, because the term web API is actually also used for other things. Now, of course, we can build our own online APIs, but that requires back-end development. So development with servers and databases and all that. And this is something really interesting that you can learn after this course. And I actually have a course on Node.js myself that you can check out if you're interested. But anyway, for now, we are interested in using third-party APIs. So APIs that other developers make available for us, most of the times for free. So let's now imagine that you're building a traveling application and you have a database with different destinations and tours that you're offering. So on your own server, you could build your own API that can receive requests from your front-end application in JavaScript and send back the results. So that would be your own API hosted on your own server. But that alone would probably not be enough to build a complete application. And so you could also use some third-party APIs. And there are really APIs for everything. So in our example travel application, you could use an API to get weather data in your destinations, data about the destination countries themselves, data about flights, about currency conversion, and you could even use APIs to send emails or text messages or embed Google Maps into your applications. So as you see, the possibilities are really endless with APIs. And we can even say that APIs is what made the modern web, as you know it, possible in the first place. So using APIs in JavaScript is super popular and everyone does it all the time. And so that's why I'm explaining you all these details. Okay, but now just to finish, let's quickly talk about API data formats. So AJAX stands for Asynchronous JavaScript and XML. Remember? So the X there stands for XML. And XML is a data format which used to be widely used to transmit data on the web. However, these days, basically no API uses XML data anymore. The term AJAX is just an old name that got very popular back in the day, and so it's still used today, even though we don't use XML anymore. So instead, most APIs these days use the JSON data format. So JSON is the most popular data format today because it's basically just a JavaScript object, but converted to a string. And so therefore, it's very easy to send across the web and also to use in JavaScript once the data arrives. All right, so now that we know what asynchronous JavaScript is and also what AJAX and APIs are, let's finally use all this in practice and make our very first AJAX call in the next video. So now that we know about AJAX and APIs, let's actually make our first API call. So in this lecture, we're going to build a nice UI component such as this one here, which contains data about a certain country. And this data about the countries is actually going to come from a third-party online API. So just as we learned it in the last video. So here we have this first card for Portugal, and then another card for the USA. And of course, this would work for any country in the world. And this is actually really exciting stuff to me. So I think it feels really magical and next level to be able to do this. So to kind of magically get this kind of data from the internet and then work with it in any application that we're building. And so let's now start working on this. And as always, I already have my starter files up here in VS Code. And I also already started the live server. And so that's what I have here open. And so now let's get to work. Now in JavaScript, there are actually multiple ways of doing AJAX calls, but we're going to start with the most old school one. And that's called the XMLHttpRequest function. So we can do new XMLHttpRequest. So just this one here. So we call this function, and then all we need to do for now is to store the result in a new variable. So let's call this one request. And so that's the first step of using the XMLHttpRequest way of doing AJAX calls. Now again, as I mentioned, this is the old school way of doing AJAX in JavaScript, but I'm still showing it to you for two reasons. So first, I want you to know that XMLHttpRequest exists because you might actually need it in the future. And second, I want to show you how AJAX calls used to be handled with events and callback functions. And so only after that, we should move on to a more modern way of handling asynchronous JavaScript, which is going to be a feature called promises. But anyway, next we need the URL to which we will make the AJAX call. So we can now say request, so that object that we created here, .open, and then here first we need to pass in the type of request. And remember that the type of HTTP request to get data is simply called get. And second, we need a string containing the URL to which the AJAX call should actually be made. So let me now show you the API that I selected for this project and also how we can use it so that you can actually understand how you could do something similar yourself. So on GitHub, there is this huge repository, as you can see here, which is called public APIs. And so if you just Google for that, I'm sure that you will find it. And here is a list of a ton of public and free APIs that you can use. So we have all these different categories here. And so there's really an API for everything. So just as I said in the last video. And the one that we are going to use is called REST countries. So it's this one here. All right. So we see here that, well, this is a big table. So we see that the API we are going to use needs no authentication. I think it uses HTTPS, and I'm not sure about CORS. And this one here is important. So any API that you use here should always have CORS set to yes, or maybe to unknown. All right. And CORS stands for Cross-Origin Resource Sharing. And without CORS, we cannot access a third-party API from our own code. And so going back here, well, now it's gone. Here it is. So you see it doesn't need authentication and it uses HTTPS. So this is a good one. And so let's click it, which will take us basically to the documentation page. And now here I'm simply looking for a so-called API endpoint. And so the endpoint is essentially just another name for the URL that we need. So here we have the first URL, and this one is basically for all countries. So if we wanted to get a list of all the countries from this API, we could make an AJAX call to this URL here. Okay, but that's not what we want. Instead, I want to search the API by country name. And so therefore, this here is the URL that I'm going to use. So let's copy it. And I hope that you followed these steps here. And if not, you can of course simply paste it here. All right. And I will start with Portugal, but you can of course use your own country. So with this, we basically open the request, and now next we need to also send it. So you see there are a lot of steps involved when using this way of doing an AJAX call. Okay, and so this will now send off the request to this URL here. Now in order to get the result, we couldn't simply do maybe something like this. So set some variable simply to this result here. And the reason why we cannot do this is because the result is simply not there yet, right? So this AJAX call that we just send off here is being done in the background while the rest of the code keeps running. And so this is the asynchronous non-blocking behavior that we talked about in the last lecture. So let's get rid of this. And instead, what we need to do is to register a callback on the request object for the load event. So request, and then again our old friend add event listener, and here on the request we will wait for the load event. So again, here we basically send off the request, and so that request then fetches the data in the background, and then once that is done, it will emit the load event. And so using this event listener, we are waiting for that event. And so as soon as the data arrives, this callback function here will be called. Now, let's then actually log the result to the console. So the this keyword inside of this function is the request, right? So we could also do request, but let's just use the this keyword. And then the response is in the property response text. And again, this property here is of course only going to be set once the data has actually arrived, right? So if we tried to set it out here, then that wouldn't work, of course. So we can still try that just to see request.response text. And so that would be exactly the same as this one. And well, already we have our first data here. So that's great. And as you see, this is the result of our very first AJAX call. So great job, this already worked. And you see that this kind of looks like a bunch of data about Portugal indeed. Now we just need to convert this here to an actual JavaScript object, because what we have here right now is JSON. So remember that JSON is basically just a big string of text. And so what we need to do here is to then convert that. We already did that before, actually. So that's JSON.parse this.response text. So let's then take a look at the data. And by the way, as you see here, of course, the result of request.response text out here is nothing, right? So let's get rid of it. And so indeed, here we have this object with all this data about Portugal. So we have the capital, which is Lisbon. We have the flag even. So basically a link to the image of the flag. And indeed, this is where we're going to get this flag here from. And then all kinds of other stuff, like the location, the population, region, and so on and so forth. Now you see that this is actually an array containing one object. And so let's quickly destructure that like this. So remember, that would be the same thing as doing this, right? But of course, destructuring is a lot more beautiful. And so now we got immediately the object here. Great. And now we can actually build that card component. And so let's copy the HTML here from this comment. So open the index.html file, get the HTML from there, and then we can create a template literal that we then have to fill up. Here I'm of course missing the name, and as always I'm calling it HTML. And so now all we have to do is to replace this data. So let's open it to see what we actually have. So here we are actually starting with the image. So we need a source, and of course that source can be any URL. It doesn't have to be a local image that we have on our computer. And so the one we will use is this one here. And so that is at data.flag. Next up, this is where the actual name of the country goes. So so down here is the name. Then here I also want the region. So that would be Europe in this case. And so this is the one. So that's data.region. And then finally, we also want some information about the population, language, and currency. And all of that is present here in this data. So that's at data.population. And so this here is basically 10 million. So we don't want to display this entire number. So let's just round it to 10.3 or 10.4 million. So the way we can do that is to convert this first to a number. So as always, I'm just using plus for that. Then divide it by 1,000,000. So yeah, that's 1,000,000. And then let's round this value finally. So this is a number, and so on a number we can call toFixed with 1 decimal place. Next up, language. So I'm doing this pretty fast because here we are basically just practicing what we already know, right? So again, this one is for languages, and so let's see. So languages is basically an array. Oh, now I clicked, and so now it's gone. So let me just put something else here for now, because this was causing the error. So let's see. In languages, we have multiple here, as you see. And so what we want is simply the first element of the languages and then the name. And the same is actually going to happen with the currencies. So we also have an array of the currencies, and then we want the name of the first one. So again, we want data.languages, the first element, and from there we want to take the name, and the same with the currencies. Currencies. All right, and that should be it. And now all we have to do is to then actually insert this HTML into our page. So I actually already have it here selected, but just to make it complete, let me show it to you. So we have this countries element here, and so that's what I call the countries container. And so here we want country.insert adjacent HTML before end, and then the HTML that we just created. Now finally, we also need to set the style of this container to opacity 1. So let me show you that one also in the code. So I set the opacity of the countries container here to 0. And so now we set it to 1 so that we can then see a nice animation, which is going to be triggered by this transition. Okay. First, let's give us some space so we can then actually see it. And so, as I just said, we need to say countries container dot style dot opacity and set it to 1. And now as I save it, the data should appear, and it does. So that's amazing, right? And it looks just like here in our demo. So that's fantastic. I really love it when it works just like this. So getting data from some third-party API really feels like magic to me. Now let's actually reuse the same code here to create an element like this for multiple countries. And so what I'm going to do is to put all of this into a function. Let's call it getCountryData. And so this one will take a string as an input of a country. Okay, so the curly brace down here. And then here, instead of hard coding Portugal, we will use that country that we get as an input. All right, country. And now down here, we can then call this function getCountryData Portugal. So let's see. And yep, that worked just the same. And now let's try another one. So let's try the United States of America, just like I had it in my demo. And here we go. So now we have data about 2 countries. And by calling these functions here twice, we will basically have 2 AJAX calls happening at the same time. So in parallel, so to say. And if we reload this page here a couple of times, then they might appear in a different order. And the reason for that is basically that the data arrives at a slightly different time each time that we're loading the page. And so, in fact, this really shows the non-blocking behavior in action. So as we call getCountryData here with Portugal for the very first time, it sends off this request, and then JavaScript moves on in the code right away. And so it goes right here to this next line. And this, of course, fires off another AJAX call immediately, way before the data of Portugal has actually arrived. So again, we will have 2 AJAX calls happening at the same time. And so whatever one arrives first will then fire the load event first. And so if the first one is the AJAX call for the USA, well, then the first element that's going to be printed here will, of course, be the one from the USA. And only after that, the data for Portugal arrives. And then this callback function here is called with the data of Portugal. And of course, the same would be true no matter how other requests we would fire off here. Let's say Germany here. And so now we actually got the data in the same order, but so now it's actually completely different. And so this confirms what I just explained before. Now, if we actually wanted these requests to be made in a specific, like predefined order, then we would basically have to chain the requests, which means to make the second request only after the first request has finished. And that's actually what we're going to do in the next lecture, so that I can show you something that we developers call callback hell. If you want to go really deep and really understand how requests and responses work on the web, then this video is for you. So this is basically a high-level overview of how the web actually works behind the scenes in regard to requests and responses. Now, this knowledge is not required though for moving on in the course, and that's why I marked this video as optional. So you can safely skip it if you want to move on more quickly, but if you're interested, then just keep watching. So this is the diagram that we already saw when we first talked about AJAX calls. So just to recap, whenever we try to access a web server, the browser, which is the client, sends a request to the server, and the server will then send back a response. And that response contains the data or the web page that we requested. And that's right, this process works the exact same way, no matter if we're accessing an entire web page or just some data from a web API. And this whole process actually has a name, and it's called the request response model, or also the client-server architecture. But anyway, let's now dive a bit deeper into this. So let's use the example of the URL that we actually accessed in the last video to get our country data. Now, every URL gets an HTTP or HTTPS, which is for the protocol that will be used on this connection. And we're going to talk about this a bit later in the video. Then we have the domain name, which is restcountries.eu in this case. And also, after a slash, we have the so-called resource that we want to access. And in this case, that's /rest/v2, and so on. Now, this domain name restcountries.eu is actually not the real address of the server that we're trying to access. It's really just a nice name that is easy for us to memorize. But what this means is that we need a way of kind of converting the domain name to the real address of the server. And that happens through a so-called DNS. So DNS stands for Domain Name Server, and domain name servers are a special kind of server. So they are basically like the phone books of the internet. So the first step that happens when we access any web server is that the browser makes a request to a DNS, and this special server will then simply match the web address of the URL to the server's real IP address. All right? And actually, this all happens through your internet service provider, but the complete details don't really matter here. What you need to retain from this first part is that the domain is not the real address, and that a DNS will convert the domain to the real IP address. And then, after the real IP address has been sent back to the browser, we can finally call it. So this is how the real address looks like. So it still has the protocol, but then comes the IP address and also the port that we access on the server. And this port number is really just to identify a specific service that's running on a server. So you can think of it like a sub-address. Okay. This port number has nothing to do with the /rest/v2 resource that we want to access. So that resource will actually be sent over in the HTTP request, as we will see in a moment. Okay, and that actually wraps up the first step. So once we have the real IP address, a TCP socket connection is established between the browser and the server. And so they are now finally connected. And this connection is typically kept alive for the entire time that it takes to transfer all files of the website or all data. Now, what are TCP and IP? Well, TCP is the Transmission Control Protocol, and IP is the Internet Protocol. And together, they are communication protocols that define exactly how data travels across the web. They are basically the Internet's fundamental control system, because, again, they are the ones who set the rules about how data moves on the Internet. And don't worry if that sounds confusing, we are actually going to learn a bit more about TCP/IP a bit later in this video. But anyway, now it's time to finally make our request. And the request that we make is an HTTP request, where HTTP stands for Hypertext Transfer Protocol. So after TCP/IP, HTTP is another communication protocol. And by the way, a communication protocol is simply a system of rules that allows two or more parties to communicate. Now, in the case of HTTP, it's just a protocol that allows clients and web servers to communicate. And that works by sending request and response messages from client to server and back. Now, a request message will look something like this. The beginning of the message is the most important part, called the start line, and this one contains the HTTP method that is used in the request, then the request target, and the HTTP version. So about the HTTP methods, there are many available, but the most important ones are GET for simply requesting data, POST for sending data, and PUT and PATCH to basically modify data. So you see that an HTTP request to a server is not only for getting data, but we can also send data. All right. Now about the request target, this is where the server is told that we want to access the REST/v2/alpha resource in this case. Remember that? So we had this in the URL before, and now it is simply sent as the target in the HTTP request. And so then the server can figure out what to do with it. Now, if this target was empty, so if it was just a slash, basically, then we would be accessing the website's root, which is just restcountries.eu in this example. Then the next part of the request are the request headers, which is just some information that we sent about the request itself. There are tons of standard different headers, like what browser is used to make the request, at what time, the user's language, and many, many more. Now finally, in the case we're sending data to the server, there will also be a request body. And that body will contain the data that we're sending, for example, coming from an HTML form. So that is the HTTP request, and I hope that it makes sense to you. Now, of course, it's not us developers who manually write these HTTP requests, but it's still helpful and valuable that you understand what an HTTP request and also a response look like. Also, I want to mention that there's also HTTPS, as you probably know. And the main difference between HTTP and HTTPS is that HTTPS is encrypted using TLS or SSL, which are yet some more protocols, but I'm not going to bore you with these. But besides that, the logic behind HTTP requests and responses still applies to HTTPS. All right, so our request is formed, and now it hits the server, which will then be working on it until it has our data or web page ready to send back. And once it's ready, it will send it back using, as you can guess, an HTTP response. And the HTTP response message actually looks quite similar to the request. So also with a start line, headers, and a body. Now in this case, the start line has, besides the version, also a status code and a message. And these are used to let the client know whether the request has been successful or failed. For example, 200 means OK. And the status code that everyone knows is 404, which means page not found. So that is where this 404 code that everyone already knew comes from. Okay? Then the response headers are information about the response itself. So just like before, and there are a ton available, and we can also make up our own, actually. And finally, the last part of the response is, again, the body, which is present in most responses. And this body usually contains the JSON data coming back from an API or the HTML of the web page that we requested, or something like that. So we talked in great detail about the most important parts here, which are the HTTP request and the response. But in our imaginary example, we only just did one request to restcountries.eu and got one response back, right? And that's how it's going to work when all we do is to access an API. However, if it's a web page that we're accessing, then there will be many more requests and responses. And that's because when we do the first request, all we get back is just the initial HTML file. That HTML file will then get scanned by the browser for all the assets that it needs in order to build the entire web page, like JavaScript, CSS files, image files, or other assets. And then for each different file, there will be a new HTTP request made to the server. So basically, this entire back and forth between client and server happens for every single file that is included in the web page. However, there can be multiple requests and responses happening at the same time. But the amount is still limited because otherwise the connection would start to slow down. But anyway, when all the files have finally arrived, then the web page can be rendered in the browser according to the HTML, CSS, and JavaScript specifications that you already know. Now, as a final piece of the puzzle, let's talk again about TCP/IP and figure out how this request and response data is actually sent across the web. Okay? So we said before that TCP and IP are the communication protocols that define how data travels across the web. Now, I'm not going to go into a lot of detail here, but here is what you need to know. So first, the job of TCP is to break the requests and responses down into thousands of small chunks called packets before they are sent. Once these small packets arrive at their final destination, TCP will reassemble all the packets into the original request or response. And this is necessary so that each packet can take a different route through the internet. Because this way, the message arrives at the destination as quick as possible, which would not be possible if we sent the entire data simply as a big chunk. So that would be like trying to go through dense traffic with like the biggest bus that you can imagine. So probably not a good idea. Now, as a second part, the job of the IP protocol is to actually send and route these packets through the internet. So it ensures that they arrive at the destination they should go using IP addresses on each packet. Okay, and that's it. That's a broad overview of what really happens behind the scenes of the web. And I hope that you found this information useful and also interesting and not all too confusing. But anyway, now let's go back to our JavaScript and AJAX calls. So in the last lecture, we did a simple AJAX call to fetch data from a countries API. So we created a function for that, and as we called the function multiple times, multiple AJAX calls were made at the same time. So they were basically running in parallel, and we could not control which one finished first. Remember that? However, in this lecture, let's create a sequence of AJAX calls so that the second one runs only after the first one has finished. And here's what we're going to do. So in the countries data here, there is some property of the bordering countries. So you see, this one here has the code ESP, which stands for Spain. And so that's because Spain is a bordering country of Portugal. And so what we will do now is after the first AJAX call is completed, we will get this border, and then based on this code, we will also render the neighboring country right here besides the original country. And so in this case, the second AJAX call really depends on the first one, because the data about neighboring countries is of course a result of the first call. So without the first call, we wouldn't even know which data to fetch in the second call. And so what we need to implement is a sequence of AJAX call. So here I already copied the function from the last lecture, which is still up here. And so let's call this one here now get country and neighbor. Okay, so again, we get the country as an input. And then here we do the first AJAX call. And then once the load event is fired, when the data arrives, we then handle that data. And so everything that we have here is still the same. Now, we will do this part here another time. So basically, once the neighboring country arrives, we also will want to render this one. And so let's export this functionality into its own function so that we don't have to copy it later. And this also makes this function a little bit cleaner. So render country is going to be a function which simply takes in some data. And so like this, we don't have to change the variable names in here. Okay. And so now here, let's then actually call that function. So render country with data. And now we get this error here because, of course, this function no longer exists. So get country and neighbor. So as I save this now, this should look the same as before. And so indeed it does. Okay, but now here, let's actually get the neighbor country. So let's write that. Get neighbor country. And here, actually, let's also do some comments now. So render country 1, let's say. And here I will say AJAX call country 1. So the neighbor country will then be country 2. So the neighbor is going to be data.borders, I believe. So let's just check that here again. And so this is actually an array. And so we will simply render the first element. So in the case of Portugal, there is just one border, but in other countries like Germany, there's like 10 borders or something. So let's just destructure here, basically just take the first element. But of course, there are also countries which have no neighbors at all. So islands, basically. And so for these cases, let's simply make sure that we don't run into any mistakes. And so in that case, we simply return immediately. But of course, if the neighbor does exist, then now we can do the second AJAX call. And so let's copy all of this. And so here, AJAX call 2. And now here, of course, we don't want to use the country, but we want to use the neighbor. But there is one particularity about that, because here the border, so this one here, this country, actually doesn't come with the name of the country, but with this code. Okay? But using our API, we can actually also search by the code. So right here we have that. So right now we are using the name, but as I said, we can also search for the code. And so all we have to change is basically here from name to alpha. So that's alpha here, and then here, the neighbor. All right. Okay. And so now, just like before, we have to then listen for the load event on this new request. And let's call this request 2, because of course we can't do that on the same request that we did here in the beginning. So request 2, add event listener, load, and then our callback function. And so you're starting to see now that the second AJAX call, in the way we are setting it up here, is really dependent on the first one. So that's because basically we are firing off the second AJAX call here in the callback function of the first one, right? So basically inside of this callback function, we are now adding a new event listener for the new request. And so here we now have one callback inside of the other one. All right. And so we will talk about that once we have this code working. But for now, let's actually take a look at the result here. And so that's going to be request, or actually just a this keyword. So this dot response text. So let's see. And indeed, now we got data about Spain. And no matter how many times we reload the page, it will now always appear after Portugal. All right, because there's no way that this AJAX call here can be made before the one on Portugal. Okay, and so now, well, let's just do the same as we did here. So we don't need this. Let's say data2 should be JSON.parse, and then this. And of course, we need to also destructure it then, logging it to the console. But now we get some error here. So let's just take a look at the result itself without any destructuring. Oh, and so now it works. And the reason for that is that the response of this API is actually no longer an array when we search for the code. So here we have this alpha, remember, and so this time we are searching for country codes and not for country names. And so the country codes are unique, and so therefore they can always just be one result. And so that's the reason why no array is returned. And probably it says here so in the documentation. Well, it doesn't say so, but if we would have just simply inspected the response here, then we would have understood that as well. But anyway, now it worked, and so let's now render this country here as well. So data2, and now let's wait, and there it is. Great. Now actually I created a special class here for the neighboring country so that it appears a little bit smaller. And so when it is the neighbor, we want to attach some class here to the country. And so let's pass that class in. So let's say class name, and by default we set it to nothing. So here we will just add it to the string like this. And now when it is a neighbor, we can just pass in neighbor like this. Give it a save, and yeah, so that looks a bit nicer. We get the information that this is a neighbor country. And so now let's try this, for example, for the USA as well. But now I just want to do one at a time. So here we should probably get Mexico or Canada. And indeed, here it is. Here is Canada, the neighboring country of the US. And so one more time, this second AJAX call would not have been possible without the first one. Because otherwise, how would we know that the second country here needed to be Canada? Okay, so again, we have one AJAX call here that depends on another one. And so what we have here is one callback function inside of another one. So you see, here we attach the first callback function, and then inside of that, we have yet another one. So in other words, here we have nested callbacks. But now imagine that we wanted to do more requests in sequence, like the neighbor of the neighbor of the neighbor, and like 10 times over. So in that case, we would end up with callbacks inside of callbacks, like 10 times. And actually, for that kind of structure and for that kind of behavior, we have a special name. And that special name is callback hell. So basically, callback hell is when we have a lot of nested callbacks in order to execute asynchronous tasks in sequence. And in fact, this happens for all asynchronous tasks which are handled by callbacks, and not just AJAX calls. So, for example, let's say we have a setTimeout function, and then here we want to log something to the console, like 1 second passed, but then also we want to start another timeout. Let's just set 1000 here. So let's copy this one here. And so, as I just said, let's say that here we wanted to start a new timer after the first timer has finished. So here we can say 2 seconds passed, and we can even add another one. So never mind about what just happened in the console. And here, why not add yet another one? All right. And so now they should appear like 1, 2, 3, 4. And so here too, of course, we have callback hell. And in fact, callback hell is pretty easy to identify by this triangular shape that is formed here. You see that? And also the same is starting to appear here. Right? So if we had more callbacks in here, then we would start to see a lot more indentation here. And then this triangular shape would also appear there. Now, the problem with callback hell is that it makes our code look very messy. But even more important, it makes our code hard to maintain and very difficult to understand and to reason about. And code that is hard to understand and difficult to reason about will have more bugs and is just worse code. So this is a great rule that you should always remember and keep in mind. So again, the rule is that code that's hard to understand is basically bad code because it will have more bugs. Because the harder it is to understand code and to reason about the code, the more difficult it will be to add new features and to add more functionality to the application. But anyway, given all these problems with callback hell, we of course need a way to solve callback hell. And fortunately for us, since ES6, there is actually a way of escaping callback hell by using something called promises. And so let's now take the next step in our journey of asynchronous JavaScript, which is to learn all about promises. In the last video, we got a glimpse into callback hell, and it was not pretty. So in this lecture, let's learn about a modern JavaScript feature called promises so that we can escape callback hell. However, before we learn about promises, we should actually see one. And so let's now replace the old XMLHttpRequest function with the modern way of making AJAX calls. And that is by using the fetch API. So let me go up here to our first function, and I will just copy all of this just to see how it used to work and how we can do it now. Okay, so this is how we used to do it, and now all we need to do is to call fetch, and then with our URL, so let's just grab that part and then specify Portugal, and that's actually it. All we have to do now is to store the result into a variable, and let's still call it request here. Now there are actually some more options that we can specify here in the fetch function if we'd like, but to make a simple GET request like this one, all we really need is to pass in the URL, and that's it. So for more complex AJAX calls, the fetch function can take in like an object of options as well. But again, for now, we don't need that. But anyway, let's now give it a save. And well, we should also log the request to the console to see what happens. And so you see that the fetch function immediately returned a promise here. So as soon as we started the request, we stored the result of that into the request variable. And then as we logged it, we immediately got the promise here. So let's do that again. And again, right away, we got something called promise. And here it says pending. So if we open that up, then here it says fulfilled. And we also have like a value here, but I'm not going to go into full detail just yet. So what matters here is that now we actually have a promise. And so this promise is right now stored in this request variable. But now, what exactly is a promise and what can we do with it? Well, let's find out. So, the formal definition of a promise is that it's an object that is used basically as a placeholder for the future result of an asynchronous operation. And if that sounds weird to you, we can also say that a promise is like a container for an asynchronously delivered value. Or even less formal, let's say that a promise is a container for a future value. So there you go. That's the most distilled down definition of what a promise is. So a container or a placeholder for a future value. And a perfect example of a future value is the response coming from an AJAX call. So when we start the AJAX call, there is no value yet, but we know that there will be some value in the future. And so we can use a promise to handle this future value. And don't worry, this will really make sense once we go back to code. But to understand this concept even better, I like to use the analogy of a lottery ticket. So a promise is just like a lottery ticket. So when I buy a lottery ticket, essentially I buy the promise that I will receive some amount of money in the future if I guess the correct outcome, right? So I buy the ticket now with the prospect of winning money in the future, and the lottery draw, which determines if I get the money or not, happens asynchronously. So of course, I don't have to drop everything and keep waiting until the lottery draw happens, right? Now, in case I did get the correct outcome, then I will receive my money, because I have my lottery ticket, which is the promise that I bought. Now, what's the big advantage of using promises? Well, there are two of them actually. First, by using promises, we no longer need to rely on events and callback functions to handle asynchronous results. Events and callback functions can sometimes cause unpredictable results, and so this is a big win already. But even better, with promises, we can chain promises for a sequence of asynchronous operations instead of nesting like we did in the last video. And with this, we can finally escape callback hell, which was our initial goal all along. And by the way, promises are an ES6 feature, so they became available in JavaScript in 2015. And so by now, they are widely used by everyone. Now, since promises work with asynchronous operations, they are time sensitive, so they change over time, and so promises can be in different states. And this is what we call the life cycle of a promise. So in the very beginning, we say that the promise is pending. And so this is before any value resulting from the asynchronous task is available. Now, during this time, the asynchronous task is still doing its work in the background. Then, when the task finally finishes, we say that the promise is settled. And there are two different types of settled promises, and that's fulfilled promises and rejected promises. So, a fulfilled promise is a promise that has successfully resulted in a value just as we expected. For example, when we use a promise to fetch data from an API, a fulfilled promise successfully got that data, and it's now available to being used. On the other hand, a rejected promise means that there has been an error during the asynchronous task. In the example of fetching data from an API, an error would be, for example, when the user is offline and can't connect to the API server. Now, going back to the analogy of our lottery ticket, the lottery draw is basically the asynchronous task which determines the result. Then, once the result is available, the ticket would be settled. Then, if we guessed the correct outcome, the lottery ticket would be fulfilled and we get our money. However, if we guessed wrong, then the ticket basically gets rejected and all we did was waste our money. Now, these different states are very important to understand because when we use promises in our code, we will be able to handle these different states in order to do something as a result of either a successful promise or a rejected one. Another important thing about promises is that a promise is only settled once, and so from there, the state will remain unchanged forever. So the promise was either fulfilled or rejected, but it's impossible to change that state. Now, these different states that I showed you here are relevant and useful when we use a promise to get a result, which is called to consume a promise. So we consume a promise when we already have a promise. For example, the promise that was returned from the fetch function right at the beginning of this video. Remember? But in order for a promise to exist in the first place, it must first be built. So it must be created. In the case of the fetch API, it's the fetch function that builds the promise and returns it for us to consume. So in this case, we don't have to build the promise ourselves in order to consume it. Now, most of the time, we will actually just consume promises, which is also the easier and more useful part. And so that's what we will do in the next couple of videos. But sometimes we also need to build a promise and not just consume it. And of course, we will also learn how to do that a bit later. All right. And so now let's actually start using promises in the next video. In this lecture, we will learn how to consume a promise. And in this case, we will consume the promise that was returned by the fetch function. So let's now implement the getCountryData function from the very first lecture, but of course this one using a promise. So getCountryData, and so again, here we pass in a country, and then here we will want this fetch function, and here again with the country then. So making this a template, literal again, and then country. And as we already know, calling the fetch function like this will then immediately return a promise, so as soon as we start the request. And in the beginning, this promise is of course still pending, because the asynchronous task of getting the data is still running in the background. So just as we learned in the last lecture. Now, of course, at a certain point, the promise will then be settled, and either in a fulfilled or in a rejected state. But for now, let's assume success. So assume that the promise will be fulfilled and that we have a value available to work with. And so to handle this fulfilled state, we can use the then method that is available on all promises. So just like this. So again, this here will return a promise, and on all promises, we can call the then method. Now into the then method, we need to pass a callback function that we want to be executed as soon as the promise is actually fulfilled. So as soon as the result is available. So a function, and then this function will actually receive one argument once it's called by JavaScript. And that argument is the resulting value of the fulfilled promise. So let me call it response here, because this is the response of an AJAX call in this case. All right, and that's it. So this is how we actually handle a fulfilled promise. But now let's actually do something with the response here. And as always, I will start by logging it to the console. But of course, we also need to call this function here. All right. And so here we now get the response indeed. And even the type of this object is actually called response. Let's just get rid of this here for a second. So we have a cleaner output here. All right. And so here indeed we have a couple of things about the response itself. For example, here the status code or the headers. And so if you watch the lecture about how the web actually works behind the scenes, then this kind of data here will be familiar to you. But anyway, what we're actually interested in is the data itself. And so that data is in the response body here. So let's click here just to see. And as we see, the body is basically this readable stream. All right. And so actually, we cannot yet really look at the data here. So in order to be able to actually read this data from the body, we need to call the JSON method on the response. Okay, so JSON is a method that is available on all responses of the fetch method. So what I mean is this. So response.json. So again, the JSON method here is a method that is available on all the response objects that is coming from the fetch function. So all of the resolved values. And indeed, this response here is in fact a resolved value. And so therefore, it does have the JSON method attached to it. Now the problem here is that this JSON function itself is actually also an asynchronous function. And so what that means is that it will also return a new promise. And that's all a bit confusing, and I really don't know why it was implemented like this, but this is just how it works. So anyway, what we need to do now here is to actually return this promise from here. Okay, because remember, this here will be a new promise. Okay, and so now we need to handle that promise as well. All right, and so the way we do that is to then call another then right here. So we need another callback function. This time let's call it data. And for now, let's log it here to the console. And let's give it a save just to see if it worked. And yeah, here it is. So here we are back to having the same data that we already had before, but this time using a promise, or actually two promises. So let's recap what happened here. And the first part here, I think, is pretty straightforward, which is this fetch function here returning a promise. And then we handle that promise using the then method, right? But then to actually read the data from the response, we need to call the JSON method on that response object. Now this itself will also return a promise. And so if we then return that promise from this method, then basically all of this becomes a new promise itself. And so since this is a promise, we can then again call the then method on that. And so then again, we have a callback. And this time we get access to the data because the resolved value of this promise here is going to be the data itself. So basically the data that we're looking for, which is then this one here, right? And so now all we have to do is render country of data 0. Okay. And so here it is. So we just did the same thing as before, but using promises. And if we didn't have all of these console.logs here, we could actually simplify this a lot. So let me just copy it so that we get to keep this version as well. But then we can create a highly simplified version as well. So getting rid of this console.log and this one here. And then we can transform these here to arrow functions. And so this is going to work because this one will now implicitly return this result here. So this promise. And so then on that promise, we can call another then method. All I'm doing here is to simplify the code that we already had before. And you see that indeed it still works. So what do you think looks cleaner and nicer? Is it this code here using fetch and promises, or is it this function that we wrote right in the beginning with all of this weird stuff that we have going on here, and with this event and listening for the event, and even worse here with all these nested callbacks? So I hope that you agree that this here is actually a lot nicer. But beside being nicer, the code is also easier to read and to reason about. And as I mentioned before, that in itself is very important. So it's very easy to understand that this fetches something, and then we get a response, which will be transformed to JSON, and then we take that data and render the country to the DOM. Okay, so this almost reads like English sentences, and that's very helpful to understand the code now and also in the future. Now, just to finish, you might be thinking, well, we're still using callbacks here, right? And that is actually true. So promises do not get rid of callbacks, but they do in fact get rid of callback hell. So even if this doesn't look like a big change for now, it will look like a change after we add the functionality of loading the neighbor country like we did in the previous lecture. And so actually, let's go do that now in the next lecture. Let's now learn how to chain promises in order to also render the neighboring country of the initial country that we give to the function. And actually, we already have a small chain of promises because of this JSON function. And so here, these two dens called in sequence are basically already a small chain. But anyway, in this lecture, we will now take chaining to a new level and actually chain together two sequential AJAX calls. So just like before, we first get data about the country, and so that's the part that we already have here. But then we also want to get the data about the neighboring country. And so again, the second AJAX call depends on the data from the first call, and so they need to be done in sequence. So let's simply modify what we already have here. And so the second AJAX call basically needs to happen here in this den handler. So as soon as we get the data, then we need to get the neighbor country and do the AJAX call for that one as well. So let's get the neighbor, and we already know that it is at data 0 at borders, and then also the first one. And just like before, let's say if there is no neighbor, then return immediately. And actually this is not going to work, but never mind about this for now. So we will talk about error handling actually in the next video. Now here there is some kind of problem. We're missing the closing parenthesis here. All right. But now there is no error. And so let's do the second AJAX call. And let me just get the URL from up here. So that's this one. Okay. And so we use again fetch and then the URL. So let's call it country 2 and here country 1. All right. Now for now, this is not going to do anything because what we need to do now is to actually return this new promise. Because then when we do that, we will be able to chain a new den method on the result of this den method. All right. So that's a bit similar to what we did here with the JSON method, which remember also returned a promise. And so we return all of that promise here, and then we can chain a new den method onto that as well. Now in the last lecture, I actually oversimplified how things really work. So actually, the den method always returns a promise, no matter if we actually return anything or not. But if we do return a value, then that value will become the fulfillment value of the returned promise. So let me actually show that to you. So instead of returning this for now, let me just return 23. And so then when I chain a new den method here, let's say data, and then let's alert that data. And let's see. And then indeed we get 23. And so again, that happens because whatever we return from this promise here will become the fulfilled value of the promise. Okay? So again, this here returns a promise, and so we can handle it using the then method. And the fulfilled value, so the success value basically of the promise, will be the value that we return from this then method, right? And so that is this 23 here. And so therefore, in the next then method, then the data here will be 23. And of course, this here must be 23, otherwise we cannot see that in effect. But yeah, so it is 23 because this value is 23. So again, this data that we receive here as an input to this function is the fulfilled value of the promise that we're handling. And so again, that's this value 23 that we are returning from this then method here. Okay, but anyway, of course, the same is true for promises. And so by doing this, so by returning this promise here, then the fulfilled value of the next then method will be the fulfilled value of this previous promise. So of this one. Okay, so I know that sounds confusing, but what you need to understand is that basically this then method here returns a new promise, and here we can then one more time handle the success value of that promise. So one more time, I'm calling this one now a response, because here we are dealing with the fulfilled value of a fetch promise. And so that is a response. And so therefore I like to call it like that. And so here, one more time, we need to call the JSON method. And that is pretty annoying, but that's just how we have to do it. And so here again, the fulfilled value of the promise will become that body. So the data that is stored in the body. And then we can again handle that. So data like this, and then render country with data. And then here again, we pass in that CSS class for the neighbor. Okay, and that should already be it. And indeed, here we go. And if we try something else, let's say Germany, let's see what country we get. And it's Austria. Okay, but anyway, let's just put it back to this one here. And yeah, that's actually it already. So as you can see, promises really allow us to handle these complex asynchronous operations with as many steps as we want. So right now we have 4 steps here even, but of course we could extend this as much as we want. So even if we wanted the neighbor of the neighbor of the neighbor, like 10 countries, we could easily do this by chaining all these promises one after another, and all without the callback hell. So here, instead of the callback hell, we have what we call a flat chain of promises. And this one is, again, very easy to understand and to read. So as a conclusion to this video and the previous one, promises really are an incredibly powerful and elegant solution to handle asynchronous code. Now, just to finish, I want to show you a pretty common mistake that many beginners make, which is to basically chain this then method directly onto a new nested promise. So, as we know, this one immediately returns a promise, and so many beginners basically do this instead. Let me show it to you here. So instead of returning the new promise, they then chain the then method right here. So right inside of this then method. Now this actually does still work, but then we are in fact back to callback hell. Because now indeed we have one callback function here defined inside of another one. So inside of this enclosing callback function. Okay? And so of course, that's exactly what we're trying to avoid. And so don't do this. So always return the promise and then handle it outside by simply continuing the chain like this. All right, but I hope that this was already pretty obvious anyway from all the explanations that I gave you throughout this lecture and the previous one. But anyway, let's now move on and actually handle errors, because that is also a pretty common scenario when we work with promises, and especially with AJAX calls. So until now, we have always assumed that everything went well with our AJAX calls, so we never handled any errors. However, an important part of web development is to actually handle errors, because it's very common that errors happen in web applications. And so in this lecture, let's talk about how to handle errors in promises. And to start, remember that a promise in which an error happened is a rejected promise. And so in this video, we're going to learn how to handle promise rejections. Now, actually, the only way in which the fetch promise rejects is when the user loses his internet connection. And so for now, that's going to be the only error that we will handle here. Now, to simulate losing the internet connection, we can go here to network, and then we can basically change the speed here to offline. However, when we then reload the page, then basically everything will disappear. And so that's not really what we want. We want to simulate that the page was first still loaded, but then as the user does the request without internet, then we want to see the error happening. And so let's set it back to online. And so now what we want to do is to basically only call this function here whenever the user clicks on a button. And so that will then make it easier for us to simulate losing the internet connection. So here in the HTML, we already have a button. So let's comment this one out. And then in the script, I believe, so I already have it here selected as this btn. And so all we will do now is btn.addEventListener, click, and then here function, and just like this. All right. So just to see what happens here. So indeed, that works just fine. But now watch what happens when we set ourselves offline. Let's go back to the console. And so now when we do the request, then we get these errors here. So first, this one here. But the one that's most important is that we now have an on-caught promise. And so, because we have failed to fetch. And so at this point, for the first time, the promise that's returned from the fetch function was actually rejected. And so let's now handle that rejection. Now there are two ways of handling rejections. And the first one is to pass a second callback function into the then method. So the first callback function here is always going to be called for the fulfilled promise, so for a successful one. But we can also pass in a second callback, which will be called when the promise was rejected. So let's do that. And this callback function will be called with an argument, which is basically the error itself. And so let's simply alert the error. All right. So let's try that. Oh, and now we are back to having no internet. So we first need to do everything normally. So load the page. Now we lose the connection. And now we do the request. And so now actually we handled the error by displaying this alert window. And the error that we saw previously down here is now gone. So now, in fact, we no longer have this uncaught error down here because we did actually catch the error right here. So handling the error is also called catching the error. And so again, that's the reason why this error that we had here before disappeared. So it said uncaught error, but again, now we are actually catching it here. And so with this, we are now handling the error that might occur in this promise here. Okay. Now in this case, there are then no more errors because basically the chain stops here when this error happens and when it's handled right here. But now what if there was actually no error in this fetch promise here? So basically, what if this fetch promise was actually fulfilled, but then the second one here was rejected? Well, then we would also have to catch an error here. So we would have to come here, get this function and paste it here, and also handle the error right here. However, that is a little bit annoying, and so in fact, there is a better way of basically handling all these errors globally just in one central place. So instead of all of these callback functions here, let's just delete them. Okay, so this is a lot nicer just having one callback in the den. And then instead, we can handle all the errors no matter where they appear in the chain right at the end of the chain by adding a catch method. And then here we can actually use the same callback function because the callback function here will also be called with the error object that occurred. And so then we can handle it in some way. All right. So again, this catch method here at the end of the chain will basically catch any errors that occur in any place in this whole promise chain, and no matter where that is. So errors basically propagate down the chain until they are caught. And only if they're not caught anywhere, then we get that uncaught error that we saw right in the beginning. All right, so let's now try this again, and we will have to put back the internet, reload the page, get back offline, and indeed, we get the same error now here. So the same alert window that we had before. Now instead of having that annoying alert window, let's just log the error to the console and create some string here. So error, and then let's just add some emojis so that we know exactly which errors were printed by ourselves. Well, let's add a couple of them here. And in fact, we can actually also style this one with console.error. Remember? I think I showed you this one at some point in the beginning of the course. But anyway, usually simply logging the error to the console is not enough in a real application with a real user interface. And so instead of just logging something to the console, let's also display an error message for the user to see. And so that's then a more real use case of this catch block. All right. So I'm adding a new block here. So we still want to, of course, log the error to the console. But besides that, let's actually now create a function that will also render some kind of error. Okay. So let's do that outside here. And I'm calling it render error. So this is a function and it can take in a message. Just call it like this. And just like the country elements, we want to attach this to country's container and then insert adjacent. And this time not HTML, but insert adjacent text. So this is a new one, but basically it does the same thing as insert adjacent HTML, but simply with text. So it doesn't create any new HTML elements. Okay, and then besides that, remember, we always have to set the opacity back to 1. So just as we did before in the render countries function, because otherwise this container is not even going to be visible. And actually, let's put this function right at the very top of the file together with the render country function. So just like this. Okay. So again, in both cases, in order to actually see the container, we set the opacity to 1. Okay. And so now here let's use that. Render, so not country, of course, error. Let's say something went wrong. Then here we can use our emoji again. Why not? And then here let's again print the error. And actually this error that is generated here is a real JavaScript object. So we can create errors in JavaScript with a constructor, for example, just like a map or a set. And any error in JavaScript that was created like this contains the message property. So we can use that here to basically only print the message of that error and not the whole object itself. And we will actually learn more about the built-in error object of JavaScript in the next video. Now to try this, we need to again get ourselves online. Then offline, check the console. And indeed, we get our custom error down here, visible by the emojis, and then our own message here for the user. Now it's not super pretty, but that's not the point here. And as you see, indeed, this here is simply the error.message, while down here we have the entire error. So that includes the type error, and even it includes this so-called stack trace. So it shows us exactly where the error comes from. All right, and so that's how we handle errors happening in promises in any then handler. So basically handling any promise rejection no matter where it happens in the chain. Now just to finish, there is one more quick method that I want to show you, and that is also available on all promises. So besides then and catch, there's also the finally method. So let's add a finally here. Finally, and then the callback function that we define here will always be called whatever happens with the promise. So no matter if the promise is fulfilled or rejected, this callback function that we define here is going to be called always. So that's the difference between the other two. So the then method is only called when the promise is fulfilled, while this one is only called while the promise is rejected. Now the finally method is not always useful, but sometimes it actually is. So we use this method for something that always needs to happen no matter the result of the promise. And one good example of that is to hide a loading spinner, like these rotating circles that you see everywhere in web applications when you load some data. So these applications show a spinner when an asynchronous operation starts and then hide it once the operation completes. And that happens no matter if the operation was successfully or not. And so for that, the finally method is perfect. And in our case, what we always need to do is to fade in the container. So basically, this part here always happens no matter what, right? So no matter if we render the country in the case of success, or if we render the error in case of an error, no matter what, we always need to do this. And so let's take this out of here. So I'm copying it here and deactivating this in both cases. And then let's put it here into the finally handler. Okay. And now we no longer need the offline. So let's just reload, put it here. And yeah, that works beautifully. Just notice that this actually works because catch itself also returns a promise. So that's the only way why this here can work. So of course, this only works on promises. And so, yeah, again, this can only work if catch itself also returns a promise. All right. Now let's try to simulate another error so that I can show you what we need to do next. So let's say that we're trying to search for a country that simply doesn't exist. And so our API is not going to find any result for that. Let's say just this. So let's see. And well, we get this weird error that we cannot read property flag of undefined in line 152. No, so basically it's coming from this place, but of course then in our stack trace we can see where exactly it's coming from. So it's coming from get country data. Well, in this case it's not that helpful, but sometimes inspecting this stack trace can be helpful indeed. So anyway, this error here is weird, and it doesn't really reflect the true error, which is simply that our API cannot find any country with this name. So the true error is of course not that we cannot read flag of undefined, but in fact it is that our API cannot find any country. And so that's reflected here with the status code of 404. However, as I said in the beginning, the fetch promise only rejects when there is no internet connection. But with a 404 error like this, which is not a real error, but well, it kind of is. But anyway, with this 404, the fetch promise will still get fulfilled. So there is no rejection, and so our catch handler cannot pick up on this error. It does pick up on this other error, so this one here, but that's not the one that we actually want to handle. In this case, we really want to tell the user that no country was found with this name. And so that is what we will do in the next lecture, so that this one doesn't become all too long. So in this lecture, we're going to fix the request 404 error that we saw happening in the last lecture. And so as we saw in the last video, the problem here is that during the fetch, there was a 404 error, which is because our API couldn't find any country with this name. But still, even though there was obviously a big problem with this request, the fetch function still did not reject in this case. And by the way, many people, and that includes myself, think that in this case, the promise should actually be rejected right away. But again, it just doesn't, and so we will have to do it manually. So to see what happens here, let's go back to this first then handler here, which gets access to the response immediately, so without even the data. So here I'm adding back a block, and let's take a look at the response here. And also, since we added back the block, we now need to return this explicitly. So again, for now, we are just taking a look at the response object here. And so here it is. And so right here, you can see that the OK property is set to false. And so the reason for that is, of course, the status code 404. Now, when the request goes well, and so that's what's going to happen when I click here. So then if we take a look at the response, OK is true, and that's because status is 200. And so 200 literally stands for OK. So we can now use the fact that this response has the OK property set to false to basically reject the promise ourselves manually. All right? So we can do that by creating a new error. So we can say if there is no response.ok, or in other words, if response.ok is false, then we write throw new error, and then here we can define an error message. So let's write a very logical message here, which is country not found. So this is the real error message that we want to see here, and of course not this one here with cannot read property of undefined. And here we can then also take the status code and display it as well. So this 404 in this case. Let's just wrap it here into parentheses. And okay. So this is something that we never did before. So let's analyze what happens here. So we create the new error by using, again, this constructor function basically. And then we pass in a message, which is going to be the error message. Then we use the throw keyword here, which will immediately terminate the current function, so just like return does it. Now, the effect of creating and throwing an error in any of these then methods is that the promise will immediately reject. So basically, the promise returned by this then handler here will be a rejected promise. And that rejection will then propagate all the way down to the catch handler, which we already have set up here. And so now if we would try to reload this, and actually let's do that. So now this error message that we created here, so that's country not found 404. So exactly this is exactly the rejection that we created here by creating this new error. All right. So again, any error that happens in any of the callback functions here, so in any then handler, will immediately terminate that then handler and will propagate down to the catch method here. And then in there, we handle that error. And so therefore, that's why we then see the error here displayed. So that error.message is exactly that message that we pass into the error here. And in fact, the same is true for any other error. So before we had this, the error that we saw was this one here. And that's because somewhere in the render country function, we are trying to read the flag from the data that we received. But the data that we received did not contain this flag. And so therefore it created this error, and then that error caused the rejection of the promise, which was then one more time handled down here. Okay? So again, any error will cause any promise to reject. But here we are simply creating our own error to basically reject the promise on purpose so that we can then handle that error down here in the chain, so in this catch method. All right, but now you might be wondering, why should we even bother handle all these errors? Isn't that just a bunch of work and a waste of time? Well, first, handling these errors is the only way in which we can actually display an error message like this on the screen for the user. But even more important, it's just a really bad practice to leave these rejected promises like hanging around without handling them. So don't do that. Always use catch, and if necessary, you can also use finally. Okay. And now, again, what if there was no error here in this promise? So if we got no problem in this one here, but then we got a problem in the second fetch. So let's say that we don't do this, and so we have a reasonable country, which is Portugal, when we click on the button. But then here, let's say that the neighbor is not this one, but this country code, which I'm sure does not exist. And so now there is going to be a rejection in this promise, right? So we get another error here. In this case, it's a 400 error, which means something else. But in any case, the error is not handled. So we now need to go ahead and copy this code here also into this then handler. Let's actually do that, even though we know it's a bad practice and we need to fix this later. Okay. And so now we get the error message that we want. So again, country not found, and this time with the code 400. But now, of course, we have all this duplicate code here. So we shouldn't have this here. And in fact, even all of this is kind of repetitive. It's really, if you think about it, the same code as this one. And so now I think that it's a good time to actually create ourselves a really nice helper function. And this helper function will wrap up the fetch, the error handling, and also the conversion to JSON. Because in my opinion, it's really a bit cumbersome to having to do all these steps all the time. So having the fetch and then having to convert that response to JSON and only then being able to handle it, right? So instead, we will basically encapsulate all of this here into one nice function. So let's do that. And I'm going to call it getJSON. So basically, because it gets data and it immediately converts it to JSON. Now, what do we need here as parameters? Well, for sure, we need the URL. And so for now, that's okay here. So let's get, or actually we can just write it. So what we want here is fetch, and then the URL that we pass into the function. And then on that, we want to call then, and then basically with all of this. So let's grab it here. And of course, we are missing the callback function itself here. So that should end somewhere here. And well, apparently it doesn't. Maybe like this. And yes, that's correct. All right. Now, in order to actually make this function here really generic, we do not want to hard code the error message, but instead we want to pass the message in. So let's say error message, and we can set a nice default value. So let's say something went wrong, which again is very generic. And so here inside of this, we then want the error message that we pass in and along with response.status. Okay, and now all we need to do is to return all of this. And so like this getJSON function will actually return a promise. And so this is then just like any other promise that we can call here in our chain and basically replace all of this. So just so we can keep this code, I'm going to copy it. And so you can then keep this code here basically as a reference for when you need to study it again. Okay, but again, I will now go ahead and take everything that we just nicely encapsulated into our getJSON function and simply replace this. So getJSON, and then the URL is this one. And the error message is country not found. All right. And so now we can take away all of this. So this is already in our getJSON function, and so we don't need this. All right. And now the same down here. Instead of fetch, we can get JSON, and then we don't need this then here. And again, the error message is country not found. Okay, and so let's get rid of this. All right, so let's check here. And indeed, we get, again, country not found with code 400 because of this one. So that's working great, but there's still one more thing that we need to do, which is to handle the fact that sometimes there might be no neighbor. So right now, what we're doing here when there is no neighbor is to simply return. But as I mentioned before, that doesn't really do anything. So let me just try here a country that has no neighbors. So let's say Australia, because that is an island. And so here again, we get cannot read property flag of undefined. And so that is happening because it is trying to render a country that doesn't exist. Okay, so again, it's because of this neighbor. And just to make sure, to illustrate my point here, you see that the neighbor is indeed undefined. And so what we want to do here is to simply, just like before, throw a new error that will then get caught down here in our catch handler. Right? So throw new error, no neighbor found. And that's a lot better. So now this is a real error message that actually makes sense to the user. Of course, this could be all a bit better, but this is just a demonstration anyway. But I think that it nicely demonstrates how we can create a real error message that does actually make sense. And again, that is super important for any user interface that you're building. Because in web applications like this very small one, errors will happen. That is just guaranteed, and so your application needs to be ready and needs to be prepared for that. All right, so let's now quickly recap here. And I think that the big takeaway from this lecture is that whenever we want to create some error that we want to handle down here in the catch handler, all we need to do is to throw and create a new error just like we did here. And of course, we can do that for multiple reasons. So in this case here, we did it simply because in the situation, no neighbor can be found. And so that is a good reason to display an error message on the user interface. And since we do that down here in our error handler, the best way of doing that is to indeed throw an error. And remember that this works because throwing an error inside of this callback function of this then method will immediately reject this promise. And so then that rejected promise will travel down the chain until it is eventually caught somewhere. So again, in this case, it is right here in this catch handler. So when working with real applications in the real world, really make sure to keep this technique in mind because it's really important. Welcome to the first coding challenge of this section, and also in a long time actually. And this one is going to be a big one, and so let's get started right away. And in this challenge, you're going to build a function where am I, which then displays a country on the page, but based only on the GPS coordinates that you provide to the function. All right? So instead of providing a real country name like Portugal, all you will provide is coordinates of any place on the world. And based on these coordinates, then a country will be rendered just like we have been doing. All right. And so for that, we are going to use a second API to basically geocode coordinates. And so here are your tasks. So again, create a function where am I, which takes as inputs the latitude and longitude. So coordinates, as you already know, and as always, we have some test data down below. Then the next step, once you got these coordinates, is to do reverse geocoding on these coordinates. And reverse geocoding means to convert coordinates to a meaningful location, for example, a city or a country name. And so the API that we're going to use for that is this one. So go to this URL geocode.xyz and then here click on API. And so down here you then have the format of the URL that you need to use in order to do reverse geocoding. All right, so the URL format is simply this one here, but instead of XML, you should use JSON. So that's exactly what we have here. All right. So to do this, you should use the fetch API, of course, and then also promises, just like we have been doing in the last couple of videos. However, do not use the getJSON function that we created previously. So that would be cheating because it would make this whole challenge too easy. Next, once you have the data, take a look at it, and then using the data, print a message like this here to the console. Then chain a catch method to the end of the promise and log any errors that might occur to the console. Then finally, there's one important thing about this API, which is that it only allows you to make 3 requests per second. So if you reload the page really fast, then you will get an error with the code 403. And this is an error with a request. So it's a little bit like the 404 error that we worked on before. Remember? So the fetch function does not reject the promise in this case, and so you basically have to do that manually. And so that is step 5. And so with that, you completed part 1. So part 1 is basically about reverse geocoding. And then in part 2, it's time to use the data that you get from step number 1 to render a country. And so take the relevant attribute from the geocoding API and plug it into the countries API that we have been using. And just like we have been doing, render the country and also catch any errors. And for this one, you can actually even copy the code, so there's no need to type the same code, at least if you're in a hurry. So if you want to write the same code again, of course, that's still great, because that will help your muscle memory to really internalize these concepts. Now, if for any reason, by the time you're watching this course, this API here is no longer working, then please just Google for another reverse geocoding API. So I'm sure there should be another one that you can use. Okay, but anyway, once you have all of this done, then you should test your function with these 3 test data coordinates. So hopefully you can complete this challenge and have some fun along the way. So I designed this one to one more time be fun for you. So go have some fun now, and I see you back here once you're ready. All right, so here I am back, and here goes my solution. So where am I is the function that we're going to create, and that you hopefully created yourself. And so if your code works perfectly, then there's actually not even a need to watch this video probably to the end. But anyway, let's now take this URL format and then do a fetch request to this URL. So fetch, here let's use a template string, because now here we need to plug in the latitude. And then here after the comma, we need the longitude. All right, then on this we call the then method, and here we get the response. Let's just call it res for now, and then immediately we return res.json, which, remember, will return a new promise, and it is this one which then will get the data, because the data is going to be the resolved value of this promise. Right, so that's nothing new. And so let's just take a look at the data here. All right. So let's reload here. Oh, and of course, I need to call this function indeed. So let's grab these coordinates, give it a save. And so now it actually already worked. All right. So let's open it and let's see what kind of stuff we have here. So we have the city, we have so basically the confidence that this data is correct, which is 90%, which is pretty good. So the country is Germany, and then here we have all kinds of stuff. But what matters is actually the country, at least for part 2, which is going to be to render the country. But for now, the task is to log to the console a string, you are in city and then country. So like in Berlin, Germany. Okay, so let's do that. So you are in, and then data.city, data.country, country like this. And all right. So we are in Berlin, Germany. Let's actually already do this with the other coordinates. So let's see what countries we are in. I actually have no idea. All right. So we get undefined, undefined. And so this is actually the problem that I was mentioning right at the beginning. So, so this one, where the API sorry. So where the API only allows 3 requests per second. And so now we got this error 4 or 3. And so indeed, it is exactly this one. All right. And so one more time, the fetch function is not correctly handling this error. So it is not rejecting the promise, even though this clearly is an error. And so, as you already know, we need to now manually do that. So here we need to now return. And just to make sure, let's take a look at the response. And this doesn't always happen, okay? And so in this case, it actually worked just fine. So one of these here is Cape Town, South Africa, and the other one is Mumbai in India. All right. So let's try to reload again very fast here. And so now we get that error again. Okay. So where is that response? So the one that's associated to 13.381. So that's this one. And so one more time you get that OK is false. So let's use that to our advantage. So if res.ok is false, then throw new error with the error message problem with geocoding. And again, let's actually include the status code here. All right. So here we are throwing a new error. And so we are rejecting this promise that's going to be returned here. But we are, as of now, not catching it anywhere. And so at this point, we would have an unhandled promise rejection. And actually, let me show that to you. So I need to save this a bit faster in order to create the error. So sometimes it's not that easy to catch it. Let's do it really fast here. All right. So now you get uncaught promise, basically. So the error message is already the one that we want, but it should not be uncaught, right? And so indeed, we need to catch any promise rejection. And so let's do that. And all I'm going to do in this case is simply log it to the console as an error. Simply the error dot message. And then I will again like add an emoji here, just so we know that it's our own message. Okay, something is missing here apparently. So here again, we get problem with geocoding. And so now we successfully handled the error and could now do something more meaningful with it if we had to. Like, again, displaying some kind of error message or logging this error in some error tracking application. Now, okay. So I think with this, we actually already completed part 1. So we did 4 and 5 in the opposite order, but that's okay. And so now it's time to use this data to render a country. And so this is essentially what we already did before. So I'm just going to come here and copy that. So let's see where that is. Well, it's even more up there. Or actually, it's not. So actually, I will just copy this part here of the error handling. Oh, and actually, I can get all of it. Okay. So let's paste that here then. Let's get rid of these comments. And of course, now here, we need to do a new fetch. So return fetch. And then, well, actually, I need to go back and get the country as well. So yeah, that's essentially this URL here. Okay. So let's save it. I'm not sure if it's going to work yet. And it doesn't. And that's of course because this country here doesn't exist. So the country that we need is stored in data.country. And so here we are now logging this string just like we were doing before. And then based on that country, we have our next fetch here, which we will then return. And then here we have that part where we handle the error if the country cannot be found. And finally, here then we render that country. But it is not going to be a neighbor. So let's get rid of this part. And up there, we called response simply res. So let's do the same here. And for now, let's test it only with one testing data. So let's see. And now we still get an error, cannot read property 0 of undefined. So where does that come from? And so this stack trace here is once again not really helpful. But I think that I still know the answer. And that is because here we actually needed to take the first element of the array. If I remember correctly. Well, now nothing happened. Oh, but I think I know why. And the reason for that is that previously we had this finally here. So we had this finally which set the country's container opacity back to 1. And as we did that, we removed this from here. So right here. So basically now we should set this back here so that we can be back to using it in the future. And so if I save this now, oh, beautiful. There you have it. And this is really amazing. So just using the GPS coordinates, we can now determine the country that we are in and then also display it along with a bunch of information about the country here on our page. And all thanks to the power of APIs and also asynchronous JavaScript. So let's now also test with these two. All right. But now here in one of them, we actually got an error with geocoding. And again, the reason for that is that we can only do 3 requests a second. And so sometimes this then doesn't really work. Oh, but now we actually got all 3. Now, this one here for India looks a bit weird. Right? So this one is India, but when we get the data for India, then apparently, because this country also has Indian in its name, this is then going to be the first country that is found. Right? So there's probably multiple countries for India. But yeah, that doesn't really matter here in this case. If you want, you can just use some other coordinates here. All right. But anyway, again, I hope you had some fun. And this was a great use case for how we can actually use multiple APIs in sequence to create a really amazing result like this one. So we learned what AJAX and APIs are. We used a bunch of asynchronous code already, and we learned all about promises. But what's missing is to finally understand how all of it really works behind the scenes of JavaScript. And so let's find out. And to start, let's quickly review the JavaScript runtime that we talked about way back in the course, just to make sure that the rest of this lecture will make sense to you. So a JavaScript runtime is basically a container which includes all the different pieces that are necessary to execute JavaScript code. Now, the heart of every JavaScript runtime is the engine. So this is where code is actually executed and where objects are stored in memory. So these two things happen in the call stack and in the heap. Now, what's important to note here is that JavaScript has only one thread of execution, and so it can only do one thing at a time. There is absolutely no multitasking happening in JavaScript itself. Now, other languages like Java can execute multiple pieces of code at the same time, but not JavaScript. But anyway, next we have the web APIs environment. These are some APIs provided to the engine, but which are actually not part of the JavaScript language itself. So that's things like the DOM, timers, the fetch API, the geolocation API, and so on and so forth. Next up, there is the callback queue. And this is a data structure that holds all the ready-to-be-executed callback functions that are attached to some event that has occurred. Finally, whenever the call stack is empty, the event loop takes callbacks from the callback queue and puts them in the call stack so that they can be executed. So the event loop is the essential piece that makes asynchronous behavior possible in JavaScript. It's the reason why we can have a non-blocking concurrency model in JavaScript. And a concurrency model is simply how a language handles multiple things happening at the same time. But now, how does this non-blocking concurrency actually work? And why is the event loop so important? Well, let's find out. And let's focus on the essential parts of the runtime here. So that's the call stack, the event loop, the web APIs, and the callback queue. So as you know by now, a JavaScript engine is built around the idea of a single thread. But if there's only one thread of execution in the engine, then how can asynchronous code be executed in a non-blocking way? Well, that's actually the big question that we're going to answer in this video. So essentially, you will learn how the JavaScript concurrency model really works behind the scenes using all the parts of the JavaScript runtime that you already know. And as always, we will do this by looking at a real code example. So let's walk through the code line by line, and I will keep updating the call stack as we go. However, you already know how the call stack works, and so it's best that you focus more on the code and on the web APIs and callback queue. Okay, but now let's start by selecting this image element, and then in the next line, we set the source attribute of that image to doc.jpg. And as we learned before, this will now start to load this image asynchronously in the background. But this time we can actually understand what that mysterious background actually is. So, as you already know, everything related to the DOM is not really part of JavaScript, but of the web APIs. And so it's in the web APIs environment where the asynchronous tasks related to the DOM will run. And in fact, the same is true for timers, AJAX calls, and really all other asynchronous tasks. So again, these asynchronous tasks will all run in the web APIs environment of the browser. Now, if the image would be loading in a synchronous way, it would be doing so right in the call stack, blocking the execution of the rest of the code. But as we already learned, that would be terrible. And that's why loading images in JavaScript is asynchronous. So it does not happen in the call stack, so not in the main thread of execution, but really in the web APIs environment, as I mentioned before. Now, if we want to do something after the image has finished loading, then we need to listen to the load event. And so that's exactly what we do in the next line of code. So here we attach an event listener to the load event of that image and pass in a callback function as always. In practice, this means to register this callback in the web APIs environment exactly where the image is loading. And the callback will stay there until the load event is emitted. So we're handling asynchronous behavior here with a callback, just as we learned before. But anyway, let's go back to the code. And so in the next line, we make an AJAX call using the fetch API. And as always, the asynchronous fetch operation will happen in the web APIs environment. And again, that's because otherwise we would be blocking the call stack and create a huge lag in our application. Finally, we use the then method on the promise returned by the fetch function. And this will also register a callback in the web API's environment so that we can react to the future resolved value of the promise. So this callback is associated with the promise that is fetching the data from the API. And that's going to be important later on. So with this, we have now executed all the top level code, so all the code that is not inside any callback function, in a synchronous way. We also have the image loading in the background and some data being fetched from an API. And so now it's time for this to get really interesting. Let's say the image has finished loading, and therefore the load event is emitted on that image. What happens next is that the callback for this event is put in the callback queue. And the callback queue is basically an ordered list of all the callback functions that are in line to be executed. And you can think of this callback queue like as a to-do list that you would write for yourself with all the tasks that you have to complete. So the callback queue is also a to-do list of a kind, but with tasks that the call stack will eventually have to complete. Now, in this example, there are no other callbacks in the queue yet, but there could be, of course. So if there were already other callbacks waiting in line, then this new callback would, of course, go straight to the end of the queue, and there it would sit patiently for its turn to finally run. And this actually has big implications. So imagine that you set a timer for 5 seconds. And so after 5 seconds, that timer's callback will be put on the callback queue, right? And let's say there were already other callbacks waiting, and let's also say that it took 1 second to run all of those callbacks. Then, in that case, your timer's callback would only run after 6 seconds and not after 5. So these 6 seconds are the 5 seconds that passed for the timer, plus the 1 second that it took to run all the other callbacks that were already waiting in line in front of your timer. So what this means is that the timer's duration that you define is not a guarantee. The only guarantee is that the timer's callback will not run before 5 seconds, but it might very well run after 5 seconds have passed. So it all depends on the state of the callback queue and also another queue that we're going to learn about in a second. Now, another thing that's important to mention here is that the callback queue also contains callbacks coming from DOM events like clicks or key presses or whatever. Now, we learned before that DOM events are not really asynchronous behavior, but they still use the callback queue to run their attached callbacks. So if a click happens on a button with an event listener, then what will happen is just like what I illustrated here with the asynchronous load event. But anyway, now it's time to finally learn about the event loop. So here is what the event loop does. It looks into the call stack and determines whether it's empty or not, except of course for the global context. Then if the stack is indeed empty, which means that there is currently no code being executed, then it will take the first callback from the callback queue and put it on the call stack to be executed. And this is called an event loop tick. So each time the event loop takes a callback from the callback queue, we say that there was an event loop tick. So as we can see here, the event loop has the extremely important task of doing coordination between the call stack and the callbacks in the callback queue. So the event loop is basically who decides exactly when each callback is executed. We can also say that the event loop does the orchestration of this entire JavaScript runtime. Another thing that becomes clear from this whole explanation is that the JavaScript language itself has actually no sense of time. That's because everything that is asynchronous does not happen in the engine. It's the runtime who manages all the asynchronous behavior, and it's the event loop who decides which code will be executed next. But the engine itself simply executes whatever code it is given. Okay, so this is of course a lot to take in, so let's try to recap what happened here. So the image started loading asynchronously in the Web API's environment and not in the call stack, right? We then used addEventListener to attach a callback function to the image load event. And this callback is basically our asynchronous code. It's code that we deferred into the future because we only want to execute it once the image has loaded. And in the meantime, the rest of the code kept running. Now, addEventListener did not put the callback directly in the callback queue. It simply registered the callback, which then kept waiting in the Web API's environment until the load event was fired off. Only then the environment put the callback in the queue. Then, while in the queue, the callback kept waiting for the event loop to pick it up and put it on the call stack. And this happened as soon as the callback was first in line and the call stack was empty. And that's it, actually. So all this happened so that the image did not have to load in the call stack, but in the background in a non-blocking way. So in a nutshell, the Web API's environment, the callback queue, and the event loop all together make it possible that asynchronous code can be executed in a non-blocking way, even with only one thread of execution in the engine. Wow, that was already a lot to understand, but we're not done yet, because we still have the fetch function getting data from the AJAX call in the background. And this is basically happening with a promise. Remember? Now, with promises, things work in a slightly different way, which is why I included this promise example as well. So let's say that the data has now finally arrived, and so the fetch is done. Now, callbacks related to promises, like this one that we registered with the promises then method, do actually not go into the callback queue. So again, this callback that we still have here, which is coming from a promise, will not be moved into the callback queue. Instead, callbacks of promises have a special queue for themselves, which is the so-called microtasks queue. Now, what is special about the microtasks queue is that it basically has priority over the callback queue. So at the end of an event loop tick, so after a callback has been taken from the callback queue, the event loop will check if there are any callbacks in the microtasks queue. And if there are, it will run all of them before it will run any more callbacks from the regular callback queue. And by the way, we call these callbacks from promises microtasks, and therefore the name microtasks queue. And there are actually other microtasks, but that's not relevant here. So going back to our example, currently we actually do have a microtask sitting in a microtasks queue. The call stack is also empty, and therefore the event loop will now take this callback and put it in the call stack, just like it does with callbacks from the callback queue. And it doesn't matter if the callback queue is empty or not. So this would have worked the exact same way, even if there were some callbacks in the callback queue. And again, that's because microtasks always have priority. In practice, this means that microtasks can basically cut in line before all other regular callbacks. Now, if one microtask adds a new microtask, then that new microtask is also executed before any callbacks from the callback queue. And this means that the microtasks queue can essentially starve the callback queue, because if we keep adding more and more microtasks, then callbacks in the callback queue can never execute. Now, this is usually never a problem, but I just wanted to mention this possibility here anyways. Who knows? Maybe this will be an interview question for you someday. And if so, you would now know the answer. But anyway, as you can hopefully see, the idea of running asynchronous code with regular callbacks and with microtasks coming from promises is very similar. The only difference is that they go into different queues and that the event loop gives microtasks priority over regular callbacks. Alright, and that's finally it. That's all you need to know about how asynchronous JavaScript really works behind the scenes. And I'm sure that this knowledge is going to be extremely helpful and valuable to you, because you're going to be way more confident writing asynchronous code now, and also you will ace any job interview question about asynchronous JavaScript. And actually, so many JavaScript developers don't know anything about this. So I'm sure that this knowledge will put you into the top 10% or even top 5% of JavaScript developers. And that's just amazing on itself, right? But anyway, let's now finish here and try out some of this stuff in practice so that you see for yourself that I didn't just make this stuff up. Let me now quickly show you some of the stuff that we just learned in practice. And so let's now build an extremely simple example. So I will start by simply logging test start to the console. Then afterwards, I will create a set timeout with something that will just also log something to the console only. So 0-second timer. And so that's because we will fire this timer after exactly 0 seconds. Okay, so basically this is a timer which should call this timer function exactly after 0 seconds. So what that means is that after 0 seconds, this callback will be put on the callback queue, right? Then next up, let's build a promise that resolves immediately. So this is something that we will learn in the next video actually. And so for now, just follow what I'm writing here. So promise.resolve basically allows us to build a promise, so to create a promise that is immediately resolved. So one that immediately has a success value. And so that fulfilled success value is going to be this one we passed in here. So resolved promise 1. And then we can handle that resolved promise. And so that response, we can then simply log it to the console. So just like in any other promise, we can handle it with the then method, and this callback function here will get called with the resolved value as an argument. And so in this case, the resolved value of that promise is this one here that we just specified. And now just to finish, let's just log another string, test, end. And so for now, that's actually it. So in what order do you think that these 4 messages that we have here will be logged to the console? And I want you to really think about this and maybe even pause the video and write it down. Well, let's think about this together before we actually check out the result. So the first 2 messages that are going to be printed should be pretty obvious. That's because we already know that any top-level code, so code outside of any callback, will run first. And so, of course, the first 2 logs will come from these 2 synchronous console.logs here. But now between the timer and the resolved promise here, it might be a little bit trickier. So both the timer and the promise will finish at the exact same time. So both right after 0 seconds. So the timer, because we told it to finish after 0 seconds, and the promise, because we told it to immediately become resolved, right? And so therefore, they will both finish at the exact same time. So which one do you think will be handled first? Or in other words, which of these two callbacks here will be executed first? Well, the timer appears first in the code, and so it kind of finished first, and so its callback will be put on the callback queue first. But does that mean that this callback here will be executed first? Well, actually no, it doesn't. And that's because of the microtasks queue. Remember? So the callback of the resolved promise here, so this one, will be put on the microtasks queue. And this microtasks queue, as you learned in the last video, has priority over the callback queue. And so after this whole code runs, we will have one callback in the callback queue and one in the microtasks queue. And therefore, the one from the microtasks queue should be executed first. And so therefore, the callback from the microtasks queue should be executed first. And so that's this one here. And therefore, the first message to appear of these two should be resolved promise 1. All right. So the order in which they should appear is this, then this, then this, and finally the timer. And so let's now finally confirm this. So I'm saving it. And indeed, that is exactly as expected. And so that's a relief actually. So what I told you in the last lecture is actually true. Now we proved it with code. Now remember that the implication of the fact that microtasks have priority over regular callbacks is that if one of the microtasks takes a long time to run, then the timer will actually be delayed and not run after the 0 seconds that we specified here, right? So instead, it will run a little bit later, just after the microtask is actually done with its work. And so to finish this lecture, let's actually simulate what I just said. So here I will create another promise that will immediately resolve. So let's just say resolved promise 2. And then again, we can handle it here. And then as always, we want to log the result to the console. But before we're doing that, we actually want this callback function to have a really heavy task, which should take a lot of time. And so let's simulate that this callback takes a long time to run by looping over a large number. So we can do the simulation simply with an old school for loop. So let's start with I at 0. And now I will loop all the way until one very large number, let's say this. And I will have to experiment a little bit. And for your computer, it might indeed be different. So if your computer is slower, maybe then you want a smaller number. And maybe it's faster than mine, and then maybe a smaller number will be enough, right? I'm not sure if I said it correctly. So if your computer is slower than mine, then you will need a larger number, right? And so again, this line of code here will simulate that the callback function takes a long time. So really just this microtask takes a long time, all right? It is not the asynchronous task itself. So the promise itself will still be resolved immediately, but then the microtask that it contains, so that it puts on the microtasks queue, that's the one that will take a long time. And so by doing that, I can show you that the callbacks in the callback queue, just like this one here, will indeed be delayed and not run after 0 seconds. So let's try this now. And you see, it took a long time here until this log appeared, right? So maybe we can have even a bigger number. And I hope that my computer is not going to explode with this one. So you see that the page is kind of loading here and it's taking a lot of time. And so actually now eventually it finished, but you see that now only after all this work, the 0 second timer message appeared on the screen. And so this is actual proof that these 0 seconds that we have here are not a guarantee, okay? And that is exactly what I wanted to show you. So this means that you cannot really do high precision things using JavaScript timers. So just keep that in mind whenever you are working with promises. So basically with microtasks and with timers at the same time. Okay, let's just remove this 0 here so that you don't explode your computer, but you still see that the effect is the same. All right, and that's actually enough for this video. I think I proved my point and demonstrated the things that we just learned in the previous lecture. And so now we're ready to go back to some more practical aspects of asynchronous JavaScript. And that will be to create promises from scratch in the next video. So at this point of the section, you know all about consuming promises, but we have never actually built our own promise. And so let's do that in this lecture. And let's go back to our lottery example from the slides and basically simulate a lottery using a promise here. And remember that in that example, a fulfilled promise means to win the lottery, while a rejected promise means to lose. So let's get to work, and we create a new promise using the promise constructor. So that's new promise like this. So just like many other built-in objects. And so what this means is that promises are essentially just a special kind of object in JavaScript. Now the promise constructor takes exactly one argument, and that is the so-called executor function. So we need to pass in a function here. And so again, this one is called executor. Now, as soon as the promise constructor runs, it will automatically execute this executor function that we pass in. And as it executes this function here, it will do so by passing in two other arguments. And those arguments are the resolve and the reject functions. So reject like this. So we will use them here in a second. But for now, let's actually build this executor function. And also, we should probably store the result, so this new promise, in some variable. So lottery promise. Okay, so all of this here will create a new promise that we're going to store into this variable. So it's just like, for example, the fetch function, which also creates a new promise. Now, this executor function that we specified here is the function which will contain the asynchronous behavior that we're trying to handle with the promise. So this executor function should eventually produce a result value. So the value that's basically going to be the future value of the promise. And so let's do exactly that right here in the executor function, and starting with a simplified version. Now, in our lottery example, let's say that we actually win in 50% of the cases and lose in the other 50%. So a very simplified example, just to make this a bit more fun. And so what I'm going to do is to simply generate a random number, which remember is going to be between 0 and 1. And so I can simply say, if this number here is greater or equal than 0.5, then I want to call the resolve function. And so now this is where this resolve function that was passed into the executor function comes into play. All right. So in this situation here, we say that we win the lottery. And so therefore, that means a fulfilled promise. And in order to set the promise as fulfilled, we use the resolve function. So basically calling the resolve function like this will mark this promise as a fulfilled promise, which we can also say a resolved promise. And that's the reason why this method here is called resolve. Now into the resolved function here, we pass the fulfilled value of the promise so that it can later be consumed with the then method, right? So of course, we are going to handle the result of this promise just like we handled any other promise with the then method. So again, whatever value we pass into the resolve function here is going to be the result of the promise that will be available in the then handler. And so in this case, let's simply pass in a string here, and let's use some emoji again to make it a bit more fun. And so now let's handle the opposite case. So where we basically want to mark this promise as rejected. And so as you can imagine, for that, we can call the reject function. Then into the reject function, we pass in the error message that we later want to be able in the catch handler. So in the catch method, right? So here, let's just say you lost your money and then just some poop emoji. All right, so give this a save here. So just to quickly recap before we consume this promise, here we created an executor function, which is going to be called by this promise constructor as soon as it runs. So basically immediately, right? Then the promise calls this function and passes in the resolve and the reject functions so that we can then use them to mark the promise as either resolved, so as fulfilled, or as rejected. And so you see that this promise is eventually going to move to either the fulfilled state or the rejected state. So we always need to make sure that the promise ends up in one of these two states. All right, and so now it's time to actually try this out by consuming this promise that we just built. So lottery promise is going to be a promise object at this point, and so then, as always, we can call the then method. And then, just like before, the then method needs a callback function that is going to be called with the resolved value of the promise. So let's call this res here. And then let's simply log it to the console. Okay, and of course, once again, this could be any name here, right? And now let's also catch any errors. And so here also, as always, we will simply log it to the console as an error. Now, okay, and so that's actually it already. So what do you think this res value here is going to be, or this error is going to be? Well, as I just explained before, the resolved value of the promise is going to be this one that we pass in here. And so therefore, the value that we're going to log in the case that the promise is successful is going to be exactly this string that we passed into the resolve function. And the same is true with the error. So the error here is going to be simply this one, because that's the string that we passed into the reject function. Okay, so let's see. And indeed, we get our error. So you lost your money. And so as we keep reloading, we should then see these different states according to this random number that was generated here. Great. So now we won. And so as we keep doing this, we can see the different states that the promise will take. So that's amazing. But however, right now, this is not really asynchronous yet, right? So let's actually simulate this lottery draw by adding a simple timer. And so this timer will then simulate the time that is passed between buying the lottery ticket and actually getting the result. So let's add a set timeout here. So with a simple callback function, and let's run it for 2 seconds. And here we will simply take this code and put it here. And then we can also immediately log something to the console, like lottery draw is happening. And then let's add like a crystal ball here. So that's exactly also what we had in the slides. All right. And now another thing that we can do is to, instead of passing just a string here, we can also create a new error object. So basically creating a real error. And so that's a little bit better. So just like this. And so with this, we made this whole promise here make a little bit more sense, because now by using this timer, we did actually encapsulate some asynchronous behavior into this promise. And so that's the whole point of promises in the first place, right? So let's give it a save to see what happens. So immediately we get this here, and then after 2 seconds, the promise was resolved. And so then here we handled that result and logged it to the console. Let's try again. And of course, again, this one comes immediately. And we win again. Let's see if we can lose. Apparently, we can only ever win. But here you go. So now we get the error message just like before. But we also now see that it's an error. And it also tells us where this error is coming from. So right at line 292. So that's right here. And so indeed, actually creating a new error object is actually a bit better. Great. So this is how we encapsulate any asynchronous behavior into a promise. So how we abstract it away in a very nice way, just like we did here, right? And then all we have to do is to consume that promise like this. And so this is a really nice and helpful pattern. Now, in practice, most of the time, all we actually do is to consume promises. And we usually only build promises to basically wrap old callback-based functions into promises. And this is a process that we call promisifying. So basically, promisifying means to convert callback-based asynchronous behavior to promise-based. All right? So let's see that in action a little bit. And so what we're going to do is to actually promisify the setTimeout function and create a wait function. Okay, so let's create a function called wait. And this function is going to take in a number of seconds. Okay, and so now inside of this function, we will actually create and return the promise. So usually that's always what we do. So creating a function and then from there returning a promise. And so this will then encapsulate the asynchronous operation even further. So essentially that's also what the fetch function does, right? So it's a function that returns a promise. And so that is exactly what we will do here with this wait function. So in a sense, this here is a more real world example. So promisifying setTimeout. So as I was saying, we are going to return a new promise. And then our executor function as always. And then resolve. And in this case, we actually don't even need the reject function. And that's because it's actually impossible for the timer to fail. And so therefore, we will never mark this promise as rejected. And so here we don't even need to specify that reject parameter. All right. So it's just like the array methods like map, which always receive 3 arguments, but most of the time we just use 1 or 2 of them, right? And so this is similar. But anyway, all we have to do now is to use setTimeout. And then here the callback function that we want to be called after a certain time is exactly the resolve function. So we can simply do this. And in this case, we're actually not even going to pass any resolved value into the resolve function because that's actually not mandatory. And so in the case of this timer, it's also not really necessary. And so in the case of a timer, it's also not really necessary to wait for some value, right? So in this case, all we want to do is to basically make our code wait. And so no resolved values are needed. Now here we want to run that timer for a certain amount of seconds. So we need to multiply that by 1,000. And so that's actually already it. Now we could improve this even further here, or just make it smaller by using arrow functions. And you can do that if you want to have some fun with that. But for now, I will simply now consume this promise. So let's call our wait function. All right. And so this will now create a promise that will wait for 2 seconds. And after these 2 seconds, it will resolve. And so we can then handle that. And then here in our callback function, remember, we are not going to receive any resolved value. So we just leave this empty. And then I will simply log, I waited for 2 seconds. And so here in this callback, we could now run any code that we wanted to be executed after 2 seconds, right? And then let's actually wait 1 more second. And so just like before, we now have to return a new promise here. So return, wait, and this time just 1 second. And so this is exactly what we did before when we wanted to chain 2 sequential AJAX calls using the fetch function, right? So in the result of the first fetch, we would create a new fetch and return it. And so that's what we're doing here. And so then therefore, all of this returns a new promise. And then we can one more time handle that. And let's just say again, I waited for 1 second. All right. So give it a save. So this one waited for 2 seconds and this one for 1 second. And of course, we also still get the result from the previous one. But for now, this is here what we are interested in. And so now with this, we have once again a nice chain of asynchronous behavior that happens nicely in a sequence, and all without the callback hell. So before, I actually showed you what happened when we had multiple timers. And so basically, we could do now this same thing like this. So let's just copy it here as a reference. And so this example here would be this. So 1 second passed. So let's just overwrite this one here. And then here we can simply duplicate this a couple of times. So 2 seconds passed, 3 seconds, and here 4 seconds passed. All right. And so that's going to be exactly the same result as we had here. Of course, here it's 4, but never mind, that doesn't really matter. What matters is that now we no longer have this ugly and difficult to understand callback hell, but instead we have this nice sequence of asynchronous behavior. Now finally, there is also actually a way to very easy create a fulfilled or a rejected promise immediately. And we had actually already done that in the previous lecture, but it's always good to know that we can do this. So let me show it to you again. So we can use promise.resolve. And so basically this is a static method on the promise constructor, right? And so here we can then pass in the resolved value. So just like we would pass the resolved value right here. Okay. So again, the difference is that this one here will resolve immediately. So here it doesn't matter. So just ABC, and then we can handle that. And so again, the values here don't matter. And then we can also do the same with reject. Let's just duplicate this here actually. So reject, and here the then is not necessary because there will be no resolved value anyway. And so we can just catch it like this. And so these two here should now appear at the very beginning. Well, actually they don't. So let's see. Oh, actually here they are. So here is ABC and then ABC. Here let's just create a new error. All right. And so indeed, here we got a lottery draw is happening, which comes from the previous promise. So right from here. And so that's because this is basically the first microtask ever. And so therefore, this first microtask needs to be executed first. And then after these, we have ABC, and then the problem that we created here in the end. All right, so this is how we build our own promises and how we promisify a very simple callback-based asynchronous behavior function, such as setTimeout. Let's now keep promisifying things, and this time around we're gonna promisify the geolocation API. And this is gonna be really cool because it will allow us to take the small app that we built in the last coding challenge to the next level. Now, we used the geolocation API before, and so let's start by reviewing how it works. So remember, we use navigator.geolocation.getCurrentPosition. And then this function here accepts two callbacks, where the first is for the success and the second one is for the error. So this first callback function actually gets access to the position object. So let's pass that in as an argument to this callback function. And then let's simply log that to the console. So this is our first callback. And now let's create the second callback with the error. So for example, in case that the user does not allow the page to get access to the current location. And so in that case, let's just log that error to the console, just as we did previously. And so now, just like before, in the map.t app, JavaScript asks us for permission here. And when we allow, then at some point when JavaScript actually figures out the location, then we get that data back. And so here it is. And so again, this is actually asynchronous behavior in exactly the way that we have been talking about. So the code is not blocked, which we can check here. So we have a console.log after the geolocation part here, and still this part here is logged first. And so this one happens first. And so that's because this function here basically offloaded its work to the background, so to the web API environment in the browser. And then immediately it moved on right here to the next line, right? So this is very clearly a callback-based API, right? So we have to pass in these different callbacks. And so this is another great opportunity to promisify a callback-based API to a promise-based API. So let's do that. And it's actually pretty simple. So let's create a function here, just like before with the wait function. So get position, and we don't need to pass anything into this one. And just like before, we are going to return a new promise, which we then can handle later on. So here we pass in the executor function, which gets access to the resolve function and the reject function, which remember we can use to mark the promise as either rejected or fulfilled. All right. So let's actually grab this code here and paste it here. And now all we need to change is basically what happens here in each of these callback functions. So remember that this one here is the success callback function. And so it receives the position. And so when we have success, we want to resolve the promise, right? So we want to mark it as fulfilled. And so therefore, we call the resolve function and we pass in that position object, because that is actually the fulfilled value that we want to get from this promise in case that it is successful, right? So that's the whole reason of using this function in the first place. It is to get access to the current position, and that is in this object. And so therefore, that's what we're going to pass into resolve, right? So in the last lecture, we just passed a simple string into resolve because that would then be the resolved value of the promise. So basically the future value of the promise. But in this case, it is this more meaningful object which we actually need outside of the promise here when we handle it. But anyway, here we do the same, but with reject. And so this is going to work just fine, but we can actually make this even simpler. Because if this function here automatically calls these callback functions here, and if it also automatically passes in the position, then we can simply do this. So let's copy it here, and I will comment this part. So we can simply do this. Resolve and reject. And that's it. So this is exactly the same as this one here. So before we specified the callback manually like this, but all we did was to take the position and pass it then into resolve. But here, that now happens automatically. So now resolve itself is the callback function, which will get called with the position, right? And so that's exactly what we do here, okay? And the same, of course, here with reject. And so now, let's actually try this out. So, get position, and then we want to handle the result. So again, this is exactly the same thing that we did previously with the fetch function, right? Or also with the wait function that we created in the last lecture. So let's now log this position to the console. And for now, we don't need the catch block. And so let's see. So it probably is now getting the position in the background. And yeah, so now we get it back. So the promise was marked as successful by the resolve function. And so therefore, then here, this callback was called in the then handler. And so the position was passed in. And here, finally, we logged it to the console. So, beautiful. This worked just fine. And so we just promisified the geolocation API to a promise-based API now. But now let's actually take it to the next level. So remember how in the last coding challenge, we built a function which received GPS coordinates as an input and then rendered the corresponding country. Well, now we actually got these coordinates via geolocation, and so we don't even have to pass in any coordinates into that function. So let me actually get that function from the coding challenge. So that's this one here. And so remember, here we passed in the latitude and longitude, and then based on that, we did reverse geocoding, which gave us the country that basically these coordinates belong to. And so then, based on that country, we could get all the data about the country and then display it here on our page. But now, since we have this getPosition function, we actually no longer need to even pass in these coordinates. And so now we're going to be able to build a function that will tell us where we are in the world simply based on the geolocation of our device. So how cool is that? So we no longer need this one. And now here, this time, we are going to start by getting the position. So get position. And then let's do something with the position. So we already know that the coordinates are here in this coords property. I just don't remember if they are an array or an object. So let's log that to the console here for starters. So console.log position.coords. All right. And so for now, we'll just leave it at that, and we will not yet connect it to this part here. Okay. So let's run this, but probably we're going to get an error when we run this. Oh, and actually we first need to set it up with the event handler. So remember, that's the button. And then add event listener. And of course, we could also immediately run the function, but I think that it's nice to call it only when we click that button. And here we actually can simply pass in that function now, so the where am I function, because we don't need to pass in any arguments. So if we click now, yeah, so here then we get an error that latitude is not defined, but what we were interested in anyway is here the latitude and the longitude of this coords object. And so let's now go ahead and destructure this object. So const latitude and longitude equals this. But now here we call them lat and lng. And so let's do this. So basically giving them new names. And next, all we need to do then is to chain the next promise. And so let's grab this code here and put it in here. And so just like before, we now simply create a new promise here, basically, and then return that. And so then we can handle it here in the next then handler. Okay? And so now we have an even longer chain, as you can see. This one here still comes from here. No need for that anymore. And so now let's see what happens. So latitude is not defined, but that's because I got this syntax here wrong. So in destructuring, the equal sign is actually to set a default value. So this is not what we want. We want to still destruct latitude, and then we want to say that we basically want to create a variable called lat. So based on that latitude variable. And here lng to fit this one and this one, right? So let's try again. And so this takes some time. So in the real world, we would have like some loading spinner, but it works, right? So we got now the country that I'm currently in, which is indeed Portugal. And all of that was simply done using geolocation. So again, we got the coordinates here. Then from those coordinates, we got the location, so the actual location with country. And so then from there, we got all the data about the country. And so now we have the ability of basically displaying the flag of a country simply based on geolocation on any device. Now just imagine that you would have to handle all of these asynchronous operations here using callback function. So that would like literally be hell. So therefore the name callback hell. But again, with this, we have a really nice flat chain of promises that's easy to handle and also easy to manage. All right. But anyway, with this, we saw that we can really promisify all kinds of asynchronous stuff in JavaScript. For example, we could also promisify the old XMLHttpRequest function that we used in the beginning to make AJAX calls. Or also, we could promisify the image loading example that we have seen a couple of times in our slides. And actually, that's exactly what we're going to do in the next coding challenge. Time for coding challenge number 2. And in this one, your goal is to basically recreate what I'm just going to show you here on the screen. So when I open the page, then there will be an image loading in the background, and as soon as that arrives, it is displayed. Then after 2 seconds, it disappears and another image starts loading in the background. It is then also displayed, and again after 2 seconds, it disappeared. And that's actually it. All right. So that's what I say right here. And so this time, the tasks are actually not going to be really descriptive. And so in this one, you should now pretend that you're actually working on your own. So at least a little bit. And in fact, this challenge is difficult on purpose. Okay, so this is not an easy one, but I hope that with some time and with some effort, and also with reviewing everything that we learned so far in this section, you can at least complete parts of this challenge. But anyway, let's now still take a look at your tasks here. So I want you to create a function called createImage, which receives as an input a variable called imagePath. So this is basically the path to an image that I will show you in a minute. Now this function should return a promise which creates a new image. So really a new image in the DOM, and for that you can use document.createElement with the image tag. And so this is how we learn to do it in the advanced DOM section, right? So you create that image and you set the source attribute to the provided image path that you received here. And as you already know, this setting the source path is an asynchronous operation. And so basically, your task in this part 1 is to promisifying all of that. So when the image is done loading, you should append that image to the DOM element that has the images class, and then resolve the promise. And the fulfilled value of the promise should be the image element itself. Okay? And in case there is an error while the image is being loaded, and so that is the error event that you need to listen for, so in that case, reject the promise. And again, if this part is too tricky for you, then you can always just start watching the solution, at least for this part. All right. And so after the first part of promisifying, the image loading comes, of course, consuming that promise. So after the image has loaded, I want you to pause the execution for 2 seconds using the wait function that we created previously. Then, after these 2 seconds have passed, I want you to hide the current image by setting display to none. Now then, you should load a second image. Now, in order to hide the current image, my hint here is that you use the image element that was returned by the createImage promise. So remember that the resolved value of the promise should be the actual image element itself. And so you can use that element to hide it. You will just need a global variable for that. But I hope that once you reach this part, you will notice that for yourself. Anyway, after the second image has loaded, so this part here in the step number 4, so after this has happened, I want you to pause execution again for 2 seconds. And then after these 2 seconds have passed, hide again the current image. So just to make sure you understood what exactly is needed, this is here what should happen. So the image is loading, then it's displaying, then it's hiding, and loading again. And so now it's hidden one more time. Now the images for doing this are here in this image folder. And so the path to these images is going to be image, so img/ and then img1.jpg and img2. Okay? And here to actually see this effect, go to the network tab and set your speed to fast 3G, because otherwise the images are going to load too fast for you to actually see any effect. All right. So again, don't stress if this becomes overwhelming and too difficult. So I designed this one on purpose to be a real challenge for you. And so if you need to watch parts of the solution, then don't worry about that at all. Okay? As always, what matters is that you actually try. But anyway, good luck for this one, and take all the time you need, and then I see you back here. Okay, welcome back. So I hope that you did at least part of it. And so let's start with the solution here. So create image, which should take in an image path. And then whenever we are promisifying something, we always return a new promise. And also the promise is always done in the same way, at least in the beginning. So we have the resolve function and the reject function, which are received by our executor function. Okay, now we are told to create a new image using document.createElement. And so we want to create an element of the type image, and so that's img. And then all we need to do is to set the source property of that to the image path that is received. Okay, and so then on that image, we can wait for the load event. And so let's see what was the task here. So when the image is done loading, append it to the DOM element with the images class and resolve the promise with the image element itself. All right, so let's out here select the element with the images class. So img container, let's say, dot query selector images. Let's just take a look here in the HTML. And so that's this element here, right? Okay. And so again, we should now append the image to that element. And so that's img container dot append, just again, like we learned in the advanced DOM section. So if you skipped that one, then maybe you needed this part of the solution. All right. But anyway, now we also want to resolve the promise, because this load event, of course, means that loading the image was successful. And so this is where we will then resolve the promise. So mark it as successful. And remember, the resolved value should be the image. And now we should also listen to the error event. Remember? And so in this case, we will then reject the promise with a new error, as always. And let's say image not found, because that is probably the most likely error. So here it actually says that we should test the error handler by passing a wrong image path. And so the error message here that makes sense is this one. Okay, and so this should actually complete part 1. And I know that I'm doing it quite fast here, but that's because we actually did many of the things here already before, but simply in a different context. But we already know what resolve and reject do, and so this, I think, should be understandable, right? But anyway, let's now handle the fulfilled, so the successful promise. And so that's this part here. And so remember that here we received the image as the resolved value. And now actually we don't need to really do anything here. So because the image is already being appended to the DOM up here. And so for now at least, we can just log something to the console, like image1 loaded. And then a bit later, we will actually worry about waiting these 2 seconds. So let's go here to our part. And of course, I need to actually pass in the path to the image. So as I said, that's image, and then VS Code is nice enough to give us that path. And indeed, here is the image already. So as I said, I will just set it here to fast 3G now. And so now you see it's taking some time, but eventually it will arrive. And so as it arrived after that, then we logged to the console image1 loaded. And so again, that happened because the promise was actually resolved. Let's also right away add the catch handler. And so here we just want to log the error, and let's format this nicely. So let's just change the name here. And now we get our error. So image not found. All right. And so now here we could do something more realistic, like giving the user a real error message or something here on the screen. But in this case, that's simply not necessary. So let's go back here and tackle step number 3, which is to pause the execution for 2 seconds using this wait function we created earlier. So let's grab that here. So this one. And I'm going to put it right here at the beginning. All right. And so now in here, we will wait for 2 seconds. And so this is going to return a promise. So this part here. And so let's now return that so that we can chain the next then handler on that. And wait doesn't have any resolved value, remember. And so we don't specify any argument or any parameter in this function. And now remember, here what we want to do is to then hide this first image. So this one. However, this image is only defined in this function, but not in this one. And so that's why I said previously that we are going to need a global variable to do that. So let's do current image. And then here, all we do is to set current image to the image. And then we can hide it right here. So that's current image dot style dot display set to none. And so this should load the image, and then after 2 seconds, it will hide it. So let's wait for it. 1, 2, and there we go. Great. So we have that working as well. And now load a second image. And yeah, that's actually it. So then we just have to pause execution again after 2 seconds and then hide the current image again. And so this one is now going to be simply the same. So where are we going to load the next image? Well, it's going to be right here, so that we can then chain the next then handler into our chain here. So we will return a new promise, which is the one that is returned by create image. And this time, so I'm missing the quotes. Okay. And then another then. And so here we are back to receiving an image. And now let's just do exactly the same. So we assign the current image to image so that in the next step we can then hide it. Then image2 loaded, and we wait 2 more seconds. And then in the next handler, we hide the current image again. And so let's see. So after the second image has loaded, pause execution for 2 seconds again. Check that we did. And then after 2 seconds have passed, hide the current image. So check again. So we did both. And so our code should be complete now. And so let's wait for it. 1, 2, and there it goes. So now the second one is loading in the background in 1, 2 seconds. And that's it. That's our very small mini application, which had the simple goal of showing you how we can promisify this logic here of setting the source attribute of an image basically asynchronously. So I hope that you managed to do this part here. So promisifying all that, and also then understanding the logic that I wanted to implement here. And if you did something a little bit different, then that's of course not a problem at all. Okay? So I keep saying it, but that's just because it's really true. So what I want is you to try and to practice, and the results will follow. If not today, then some other day. So now that you're super comfortable with consuming promises and also building promises, let's turn our attention back to actually consuming promises. That's because since ES 2017, there is now an even better and easier way to consume promises, which is called Async Await. So let me show you how it works. So we start by creating a special kind of function, which is an async function. So in this lecture, we will basically recreate the where am I function that we have been building. Where am I? And so function, but for now, we will pass in the country again to make it simple at the beginning. But as I was saying, we now need to make this a special kind of function, which is an async function. And we do this by simply adding async here in front of the function. And so this function is now an asynchronous function. So a function that will basically keep running in the background while performing the code that's inside of it. Then when this function is done, it automatically returns a promise. But more on that in the next video. For now, what's important is that inside an async function, we can have one or more await statements. So await, and then here we need a promise. And so we can use the promise returned from the fetch function. And so let's now use our API again to search for a country, basically. So let's see where we have some information about that. And here we go. So this is the URL that we have been using. So make sure you grab it somewhere from your code. And so here, let's now pass in this country again. All right. So again, this here will return a promise. And so in an async function like this one, we can use the await keyword to basically await for the result of this promise. So basically, await will stop the code execution at this point of the function until the promise is fulfilled. And so until the data has been fetched in this case. But now, after that explanation, you might think, isn't stopping the code blocking the execution? Well, that's a really good question. But the answer is actually no in this case. Because stopping execution in an async function, which is what we have here, is actually not a problem. Because this function is running asynchronously in the background. And so therefore, it is not blocking the main thread of execution. So it's not blocking the call stack. And in fact, that's what's so special about Async Await. So it's the fact that it makes our code look like regular synchronous code, while behind the scenes, everything is in fact asynchronous. All right? But anyway, as soon as this promise here is resolved, then the value of this whole await expression that we have here is going to be the resolved value of the promise. And so we can simply store that into a variable. So let's call it res for response. And then here we can take a look at that response. And just to show you that this function here is actually asynchronous, let's log something to the console before we call it. So just first, because this should be printed first, right? And then, or actually we should call the function first. So where am I with Portugal? But even by doing this, this console.log first will be displayed first. Because again, this is an async function, and so once the function is called, it is then loaded off to the background, and so this fetch here will be running in the background without blocking our main thread. And so the code will move on to the next line, which is then this console.log first. All right. And so, indeed, we got the first printed first, and then here we got the response. But this time we got this response in this really nice and elegant way. So you see here that by using async await, our asynchronous code here really looks and feels like synchronous code. So we can simply await until the value of the promise is returned, basically, and then just assign that value to a variable. And that is something that was impossible before. So before we had to mess with callback functions, and that was true in callback but also by consuming promises with the then method. But now with async await, that is just completely gone, right? So again, this looks now like normal synchronous code, where we simply assign values to a variable. And that makes it so much easier and more clean, in my opinion. Now, before you start using async await all over the place, you need to first understand that async await is in fact simply syntactic sugar over the then method in promises. So of course, behind the scenes, we are still using promises. We are simply using a different way of consuming them, here in this case. But what we have here, so this, is essentially exactly the same as doing it the old way, basically. So using then, and then res, and then console.log res, like we did here. So this is exactly the same. So let's put that here and comment it out, of course, because what we are interested in is indeed async await right now. So now that we know how async await works, it's time to actually recreate the whereami function. So first off, we need to get the JSON out of this response, right? And so remember, on the response, we need to call JSON. And remember that this itself returns a new promise. And so previously, we would have to return this promise and then chain another then handler. But now this becomes so much easier. All we have to do is to again await this, and then we can store the result directly into the data variable that we have been using before. Right? And so here it is. So here is the same data as before, and so now all we need to do is to render it. So render country and data at position 0. And in case you skipped any of the previous videos and don't have this render country function for some reason, you can simply get it from the final files of this section from the GitHub repository. So from where you also got the starter files. Okay, and yeah, there is our data, so rendered to the page here. Great, and all without the chaining of promises like we had before. So this is really elegant, one more time, simply being able to essentially store the fulfilled promise value immediately into a variable without having to mess with callback functions. Okay, but now let's actually finish the function here with all the other functionality as well. So with geolocation and also reverse geocoding. So for that, we need to get our promise that we built before for geolocation. So this is the one here. So let's get it. And so again, async await is only about consuming promises. The way that we build them is not influenced in any way. All right. So this here is going to work the exact same way. And so let's do that here before. And so get position, remember, doesn't need any arguments. And so, as you know, all we have to do is to now await this and then store the result into a variable. And just like before, let's simply destructure this. And in fact, let me get the code from before so we don't have to repeat everything. So that was this code. And we also need the reverse geocoding, right? So let's paste all of that here. So what we want here is to get the latitude and longitude from position.coords. So probably we should just call this here first the position, and then from position.coordinates we get the lat and longitude just like before. And then now the next one. So now we can use these latitude and longitude and one more time plug them into this reverse geocoding API. And so now again, it becomes a lot easier to basically chain promises because we don't have to return anything, we don't have to create new then methods, and we don't have to create new callback functions. So all we have to do is to await this and store the result into some variable. So res for response, but we already have that, so let's call it geo for geocoding. And so let's take a look at that. Or actually, not yet, because remember that this is going to be just a response, and so we need to get the JSON from there. And yet another promise, but this is now so easy and so beautiful to handle. So again, data geo. Let's give it a save just to format it a little bit. And I will add some comments here. So geolocation, then reverse geocoding, and then country data. So just to make sure that it worked, let's take a look at data geo. And yes, this is it, right? And so again, here at the country property, we got Portugal. And so now we can plug that into this URL. So that's going to be data geo.country. And so now we can eliminate the country from here. And we also don't need to pass it in anymore. And so let's reload. And we still get the same data about Portugal because that is simply where I am right now located. But in case you're somewhere else, then you will now get the data about your own country. So let's just take a minute and appreciate how beautiful this data flow here is. Let me just put this comment out here so we don't clutter our async function. Okay. And so we now have all of this in one nice async function that runs behind the scenes until everything here is finished. So we are awaiting here 1, 2, 3, 4, 5 promises in a very easy way in code that now actually looks and feels like normal synchronous code. So to me personally, this async await feature was really a huge addition to the JavaScript language. Now again, just keep in mind that async await is just synthetic sugar over consuming promises. So it's a bit like classes in JavaScript, which also hide the true nature of how things work behind the scenes. But I think that's no problem, at least if you already know exactly how promises and asynchronous JavaScript actually do work behind the scenes. And we spent a lot of time in this section learning all that, and so I'm sure that you will be fine. Also, async await is actually used a lot together with the more traditional then method of consuming promises, as we will see in the next video. Now let me just show you something, which is when we reload too fast here, then we should get that same error as before from the a reverse geocoding where we can only do 3 requests per second or something like that. Well, I guess I'm not fast enough here. Okay, but here we go. So here we have that 403 error. And so with this error, our whole example here falls apart. So we get this cascade of errors here and nothing works anymore. And the reason for all of these errors here is because right now we actually don't have any error handling here. And so let's fix that in the next video. In this lecture, we're going to learn how error handling works with async await. So with async await, we can't use the catch method that we used before because we can't really attach it anywhere, right? So instead, we use something called a try-catch statement. And the try-catch statement is actually used in regular JavaScript as well. So it's been in the language probably since the beginning. So try-catch has nothing to do with async await, but we can still use it to catch errors in async functions. But before we do that, let's look at a more simple example just to see how try-catch works. So we can basically wrap all our code in a try block. And so JavaScript will then basically try to execute this code. So just as normal code. So let's just create a variable here, set it to 1, create another one. So this one is a constant. And now my goal was to reassign y, but I will accidentally, let's say, reassign x. And so that should then give us an error because, of course, that is not legal. So we can't reassign a constant. And so for now, if we reload at this point, first we get this error that we are missing the catch block. So let's actually first do this here without any block. And so here, of course, we get the error assignment to constant variable, right? But let's go back. And so now here we can add the catch block. So we have a catch block, and this catch block will have access to whatever error occurred here in the try block. And so now we can do something with this error. So let's say we simply want to alert the error, or just the error message. So as we know, any error has the message property, and so we can simply alert that one. So let's see. And indeed, now we get assignment to constant variable here in this alert, and you see that the error now no longer appears down here in the console. So the script does no longer die in this case, and instead we can simply catch the error right here and then handle it accordingly. Okay? And of course, if there is no error at all, so if I was assigning y correctly, then we would get no error. Well, at least not coming from the try catch block. So now we're good. But anyway, this here is just a stupid syntax error. And of course, we're not going to use try catch to find mistakes that we make in our code. And so let's now use try catch for something more useful, which is to actually handle real errors in async functions. Okay, so just like in the small example that we saw, let's wrap our entire code of this function into a try block. All right, so curly braces and then try, like this. All right, and then down here, after that, the catch block, which remember has access to whatever error occurs in the try block. And so here in this catch block, we can now handle any errors just like we did before in the catch method. So let's log the error to the console, give it a save here just to format it a little bit better. All right. And so you see that the code still works the same, but that's because we didn't cause any error yet. But let's also now log the error message. But let's now also render the error. And so instead of going search that, I will simply write some new error message. So something went wrong. Then we had this emoji here. And then again, the error dot message. Okay. And so now let's try again to force an error here by reloading really fast. Maybe the easiest way is to simply call this function multiple times. And now you see we get some nice errors here. Well, they're not really so nice. So let's see where they actually start. Well, for some reason, everything looks the same as before. But that's, of course, here it's render error. And here let's actually also add an emoji, just so we can see that it's our own error. So basically, that we are logging the error ourselves. Okay. So let's do this. Here we go. Whoa. So we get a lot of different errors here. So that's a couple of times. And so the reason for that is that we are calling this function here multiple times, and therefore we get multiple errors. But the error that gets logged here to the console, remember, is the one that is coming because of this 404 error that the country cannot be found. Okay. So at this point, we do have some error handling. So we are able to add the error here to the user interface. But just like before, this error is not really meaningful because the fetch promise does not reject on a 404 error or on a 403 error, which was actually the original error which caused everything here to collapse, right? So again, the 403 is because we are doing too many requests to the reverse geocoding API. But the solution is simple because it's exactly the same as before. So all we have to do is to manually create an error, and so that error will then be caught here in the catch block, right? So let's do that. So right here, so basically immediately after this fetch, and so just like before, we can test for the OK property, remember. So I'm not going to show that again here because we already saw it before. So this response here will have the OK property, and if that is not set to true, well, then we want to throw a new error. So that's problem getting, let's say, location data. Okay. And so this one basically handles any error in this fetch. And so now the same here. So let's say that we come back with a real weird country from this fetch. And so then the second API cannot find any country for that name. And so here, let's just say problem getting country. Now, for this first promise here, this one, we do not need to throw an error manually. Because in the case that something goes wrong with the geolocation, we already built our promise so that it automatically rejects in that case. And so in this case, we will then immediately get an error, which will get caught in the catch block. But as we already know, the same is not true for the promise coming from fetch. So that promise only gets rejected when the user has no internet connection. But in case of a 403 error or a 404 error, the fetch promise does not reject. And so, again, we do that manually right here and also right here. And so here we already see that it worked. So here indeed we got something went wrong, problem getting a location, and then again here the same error. So here maybe we don't want all of this error message. Let's just take this one out so that we just have the emoji and then the error message itself. So the one that we defined here and here. All right. So let's see if this triggers an error. And yeah, for one of them, we now have problem getting location data. So an error triggered by this one. All right. So that is the complete version now of this async function, complete with a pretty robust error handling strategy. So again, please never ignore handling errors, especially when it comes to asynchronous code like this one. Because here, there's always a lot of stuff that can go wrong, and so our application needs to be ready to handle that. All right, but with that being said, in the next lecture, we're gonna dive even deeper into how async functions really work. And so let's go there right away. At this point, we have a pretty good idea of how to work with async await, right? However, there is one important thing missing. So right now, it might still be a little bit unclear what an async function actually is and how it works. And so let's now fix that. So to understand a bit better what's actually happening here, let's start by adding some more console.logs here. So let's say we'll get location, and then in the second one here, we will say finished getting location. And if we check the result here now, I hope that you already know what the order of the logs here will be. So let's see. And so indeed, immediately we get the first log, then the second one, and of course, only after that, we get all the logs coming from the async function. So again, that's because this is an async function that runs in the background. And so JavaScript immediately moves on to the next line here. Now, if this was indeed a regular function, and there would be a console.log in that regular function, then of course that would appear here between 1 and 2, right? Well, let's call this 3 here actually. So it would then appear between 1 and 3. But in this case, it's an async function, and so therefore it runs in the background until the results are there. All right, but now let's say that we wanted to return some data from this function. All right. So let's first get rid of all these console.logs here. Put this all a bit better together. And so here at the end, let's now say we wanted to return a string like we had previously based on the geocoding data. So that data is in data geo. And so let's say you are in datageo.city, and then just quickly the country here as well. So we return this string here, and so let's say we now want to get, of course, that data out here. And so for now, let's pretend that this is simply a regular function, and then we would do this, right? We would simply define a variable, then there we would store that returned value, and then here we could take a look at that. But what do you think is going to happen here in this case? Well, let's see. And so the second thing that is locked to the console here is this promise. And remember that back then, when we first started to work with async await, I told you that an async function always returns a promise. And so here is the proof for that. And if we think about this, then it actually makes sense that here we get a promise and not the value that we would like to get. So this string here, right? So the reason for that is that at this point of the code, JavaScript has simply no way of knowing yet this string here that we want, because the function is still running. but it is also not blocking the code out here. And so therefore, again, at this point, JavaScript has no way of knowing what will be returned from this function. And so therefore, all that this function does return is a promise. Now, the value that we return from an async function, so again, that's this string here, will become the fulfilled value of the promise that is returned by the function. And so that's important to understand. So again, this promise that we see down here, the fulfilled value of that promise is going to be this string here, because that is the value that we return from the async function. Well, at least if there is no error here happening in the function. But for now, let's assume the success here again. So, since we know that this here will return a promise, we also know how we can actually get the data that we want. So all we need to do instead of this here is simply where am I? So let's comment out these two. And so this will be our promise. And so then, just like before, we can use the then method to get the fulfilled value of the promise. And so let's call that one city now. All right. So we're using the exact same variable name like we did here. But of course, this one here didn't work. But here it is going to work. Because again, in the then handler, this argument that will be passed into the callback function is going to be the resolved value of the promise. And so one more time, that is this string here that is returned from the async function. And so now let's see what happens. So let's wait for it. And so now we get our result. You are in Olhão, Portugal. Okay. And so with this, we essentially successfully returned a value from the function. Now, we will be able to do a little bit better, but for now, let's think about errors. So if any error occurs here in this try block, then this return here will never be reached because the code will immediately jump here to the catch block, right? So let's just try to create some error here. So I will just change this one here. And so now nothing will work. So let's wait for it. And so indeed, now we have an error. And so now here we get undefined from line 543. And so that's this one. And so indeed, now nothing was returned from the function. And so we get undefined. Now, what's interesting here is that the log still worked. So this console.log here, which is now logging undefined here, is still running, which means that this callback function is still running, which means that the then method was called, which in turn means that this promise here was actually fulfilled and not rejected. So even though there was an error in the async function, the promise that the async function returns is still fulfilled and not rejected, right? And in fact, if we add a catch handler here, then let's see what happens. So console.error, so error.message, then our emoji here, and actually let's add a 2 here. So the sequence is kind of 1, 2, 3. And let's do the same here. All right. And so we should still get the error from here. And indeed we do. But still, it is this callback here that is executed. So that's why we get 2 undefined and not the catch block. And so again, what that means is that even though there was an error in the async function, the promise that it returns is still fulfilled. Now, if we wanted to fix that, so if we want to be able to catch that error here as well, then we would have to rethrow that error right here. So rethrowing the error means to basically throw the error again so that we can then propagate it down. And so with that, we will manually reject the promise that's returned from the async function. So let's say reject promise returned from async function. So here we can now take the error and throw it again. So throw error. And so now we get the same error here as we had here. So again, it's cannot read property flag of undefined, and here the same, and with this too. So it is coming from here. And so sometimes it's important to do this, and so rethrowing an error is then the correct solution to that problem. All right. And now, finally, if we wanted to fix not the error, but the fact that the 3 is printed before the 2, well, then how would we do that? Well, we can simply add a finally here, right? Because the finally, as you already know, is always going to be executed. So no matter what. All right. And so now we only get the 1, then we should get the 2 with the error, and then the number 3. And indeed, if we remove now the error from here, then 1, 2, 3, just as expected. All right. So I admit that this might have been a little bit confusing, but I hope that you understood how all the pieces fit together here. Now, this of course works just fine, but in my opinion, there's still a problem here. And that problem is the fact that doing this here kind of mixes the philosophy of async await with handling promises using then and catch, right? So we are mixing the old and the new way of working with promises here all in the same code. And that's something that I personally don't like. So I prefer to always just use async functions instead of having to mix them. And so let's now go ahead and convert this to async await as well. And we can do that because, of course, we can treat the promise here that is returned just like any other promise. And so, of course, we are able to handle it using async await. So that's what we're going to do next. Now, it would be great if we could simply use await without the async function, but that doesn't really work. At least for now, because there is actually a proposal in the works to make this happen. But for now, await can only be used inside an async function. However, we don't really want a new complete function here. And so instead, we can use an iffy. So remember iffies from way back. They are immediately invoked function expressions. And remember that this is how we create one. So we write function, then here the function body, and then in the end, we simply call it. And so, of course, we can also easily create an async iffy as well. All right. And actually, this pattern here is one of the last remaining cases for iffies. All right. And now I actually want to leave the conversion of this to the async function for you as a small challenge. So please pause the video now and take a minute or two and write the code yourself here. All right. So let's start with the try catch block. So try catch. Here we get access to the error. And then let's actually immediately do this part. And then here we can simply await the where am I promise. Okay, and then all we have to do is to store that result into the city variable and then log that to the console. So that's just this. And now finally, this last part here, we can simply put it outside of the try catch block. And so then it is always going to be executed no matter what. Okay, so let's comment this one out. and we should get the exact same result. And let's wait for it. And here we go. So great, we managed to do the conversion, and now everything is using async await. And so that's much nicer. And now we know how to basically return data from an async function and how to properly receive and handle that returned data, right? And actually in the real life, this is something that happens all the time. So it's pretty common that we have async functions calling other async functions and returning values between them. And so that's the reason why I'm showing you all this. So to make sure that you really correctly understand how async functions work behind the scenes. Let's now imagine that we wanted to get some data about 3 countries at the same time, but in which the order that the data arrives does not matter at all. So let's now implement an async function using everything that we know at this point. And this function will simply take in 3 countries, and it will log the capital cities of these 3 countries as an array. So let's say get 3 countries. And again, it's an async function. So country 1, 2, and 3. And then in an async function, we really always need to wrap our code into a try catch block. Okay. So never work an async function without this. And again, in a real world scenario, you would do real error handling and not just log it to the console. Okay, so await, and then let's use our getJSON function that we coded at some point at the beginning of this section. So here at the top of my file, I have this getJSON function, which remember encapsulates the fetch request, the error handling also. So basically, when there is an error in this fetch, it will throw a new error, and it also immediately converts the response to JSON. So again, if you skipped one of the previous lectures, then make sure to get this function from the final code of this section. So get JSON, and then here again, we're using our REST countries API. So let me get the URL. So here we now will use C1. And so then we store that data into a variable just like this. So this is the magic of async await, right? Now we already know that the result of this is going to be an array with one object. So let's use the structuring to take the first element there. And now let's simply duplicate this code here twice and do this 3 times. So creating 3 variables for these 3 countries. And then what we want to get is the capital. So now let's say data1 dot capital, because there is such a property in each of these objects. And so remember that we want to return an array here. And so that's what we're doing. And data3 dot capital as well. And so this should actually already work. All right, so let's call this function get 3 countries. Let's use Portugal again, and Canada, and maybe Tanzania, which is a very beautiful country. Oh, and here we get something went wrong. So Portugal, so missing the G. And yeah, so here we get the 3 capital cities of the 3 countries. So great, this works just fine. And also at a first sight, this seems to make sense. But if we think about what we did here, then maybe it actually doesn't make so much sense. Because what we did here basically was to run all these AJAX calls one after another, even though the result of the second one here does not depend on the first one. And the result of the third one does also not depend on any of the other ones. And so actually this doesn't make much sense. Why should the second AJAX call wait for the first one? And actually let's take a look at this in our network tab here as well. So let's again maybe set this to slow 3G now. And then I will have to make it a little bit smaller so that we can actually see something down here. Okay, so down here we actually have the 3 AJAX calls. So let's use fast 3G here actually. And so let's see what happens. And so basically these bars that you see here is JavaScript downloading something. So here, of course, the first one is the HTML, CSS, and JavaScript. So nothing strange there. But then here we load the data for Portugal, right? So that's the first AJAX call. And then after that is finished, we load the data for Canada. And then after that is finished, we load the data for Tanzania. So just as we have it here in the code, and so as I explained, that doesn't make a lot of sense. So instead of running these promises in sequence, we can actually run them in parallel, so all at the same time. And so then we can save valuable loading time, making these 3 here basically load at the same time. And each of them takes half a second. And so with that, we will basically save 1 second, which is actually a lot of time when loading a website. So let's do that. And for doing that, we use the promise.all combinator function. So promise.all. And so this is once again kind of a helper function on this promise constructor. So it's a static method, right? Now this function here takes in an array of promises and it will return a new promise, which will then run all the promises in the array at the same time. So let's simply grab these 3 promises from here. So 1, then here the second one, and this is the third one. Okay, so here we again have these 3 running, but you immediately saw the Portugal, Canada, and Tanzania already running another time, but at the same time, right? So I only wanted to show you this later, but now here it is already. But for now, let's keep focusing on making this work. So as I said, this here will return a new promise. So a promise that runs all of these promises at the same time. And so then we can handle that promise in the exact same way as before. So let's call the result data and then await it here. And then log the data to the console. So this one we also don't need anymore. So we want to log the data. And so, yeah, you see once again that these 3 now loaded exactly at the same time. So they are running in parallel and no longer in sequence now. So that's all I wanted to show you. So let's go back here. Okay. And so indeed, here we get the result. So an array, which in this case returns 3 arrays, and each of them is of course the object we're looking for. And so promise.all receives an array and it also returns an array. And so to create the same output as before, now all we have to do is to loop over this data and take out the data that we want. So console.log, then data.map, because remember that we want to actually return an array, but not this array, but simply an array with all the capital cities. So in this array of data, each element, let's call it D, which stands for data. So D is now this single array. So from D, we want to take element 0, and then on there, we want the capital city. And so this should be it. And yeah, here we get the exact same result as before. Now, just one thing that's also very important to mention here is that if one of the promises rejects, then the whole promise.all actually rejects as well. So we say that promise.all short circuits when one promise rejects. So again, because one rejected promise is enough for the entire thing to reject as well. Great. So whenever you have a situation in which you need to do multiple asynchronous operations at the same time, and operations that don't depend on one another, then you should always run them in parallel, just like we did here, using promise.all. And this is actually more common than you might think, and so please keep this technique in mind, because your users will thank you. And of course, just in case you're not using async await, you can of course also take this result here and then handle it with the then method. So that's going to work just exactly the same as here with async await. Okay, and that's the promise.all combinator. So it's called a combinator function because it allows us to combine multiple promises. And there are actually other combinator functions, and so let's take a look at them right in the next video. Let's now quickly talk about the 3 other promise combinators, which are raise, allSettled, and any. And the first one we're going to talk about is promise.raise. So like this. And promise.raise, just like all other combinators, receives an array of promises, and it also returns a promise. Now this promise returned by promise.raise is settled as soon as one of the input promises settles. And remember that settled simply means that a value is available, but it doesn't matter if the promise got rejected or fulfilled. And so in promise.raise, basically the first settled promise wins the race. But let's now actually see this in action. And I will create a quick iffy here so that I can use async await without like creating a whole new function with a name. And so, as always, then we use await, promise, and in this case, .raise. And let's also store it here as a response. And now here let's define an array of promises. And let's just get this JSON here, so this get JSON function, and try it with 3 countries. Let's say Italy, and do this 3 times. Let's say Egypt, and then also Mexico. And so now these 3 promises will basically race against each other like in a real race. Now, if the winning promise is then a fulfilled promise, then the fulfillment value of this whole race promise is going to be the fulfillment value of the winning promise. So that's more obvious than it maybe sounds. So let's just see the result here in the console. And so we got Italy. But if we try this again, then maybe we get another result, because then maybe another call is going to be faster. But well, it seems to be always Italy. But now it's Mexico. And let's actually see this in the network tab. So making it smaller again. And so you see that indeed Mexico is the one who took the least time. So it has the smallest bar here, and it also was the fastest of the 3. Right? This time the fastest was Egypt here by far, and so that's what we should see in the console. Okay? So again, just keep in mind that here in promise.raise, we only get one result and not an array of the results of all the 3. Now a promise that gets rejected can actually also win the race. And so we say that promise.race short circuits whenever one of the promises gets settled. And so again, that means no matter if fulfilled or rejected. So let's try some weird name here. And so now it is the rejected promise that won, basically. But let's go back here to as it was and see another example, because in the real world, promise.race is actually very useful to prevent against never-ending promises or also very long running promises. For example, if your user has a very bad internet connection, then a fetch request in your application might take way too long to actually be useful. And so we can create a special timeout promise which automatically rejects after a certain time has passed. So let's do that. And it's going to be similar to the wait function that we created earlier, but the difference is that this one is actually going to reject and not going to resolve. So this time let's actually pass in milliseconds. Or, well, let's just pass in seconds, just to make it consistent with the other one. So return new promise and the executor function. And again, in this case, we will not resolve, but reject. And so here for the resolve function, which is always the first one, we can once again use this throwaway variable. So using this convention. And then here reject and set timeout. And here we specify a callback function. And so we say that after a certain amount of seconds, let's call it sec, like this actually. So after this time has passed, we reject the promise. So we create a new error saying request took too long. And so now we can simply have the AJAX call that we were talking about earlier race against this timeout. All right. So let me show you what that means. So promise.race. And then here, the first promise, let's use again or get JSON. So this is basically what we are interested in here. And let's use another country, Tanzania again. And the second promise is then going to be or timeout. So let's say that we only want to wait like 1 second. And so we will have these two then race against each other. And if the timeout happens first, then all of this here will be rejected, right? And so basically that will then abort the fetch that is happening here in getJSON. So I could have used, again, async await, but why not use the then method also here? So in this case, let's just log the response, or we could have called it data, but that's not really important here. And here the error, and let's just also log it to the console in case there is any. And so now we have request took too long, but that was very fast. Oh, and here we have to multiply it by 1,000. So again, this one takes milliseconds and not just seconds. Okay, so we got Tanzania pretty fast, and so it was faster than 1 second. And so therefore, it did not time out. But let's now try 0.1 seconds. And so now we see that the request took too long. So 0.1 seconds was not enough for this request here to get finished. And you will have to experiment with different values here because this is going to depend on your internet connection. So let's see 0.2 seconds. And so now the request was actually fast enough so that it didn't time out. So with 0.15 seconds, again, it takes too long. And so then this promise here is the result of promise.raise. So that's pretty useful. And in the real world, of course, you will use a larger number, let's say like 5 seconds. Okay, so that's promise.raise. And in fact, promise.raise and promise.all are by far the two most important promise combinators. But let me show you also the other two that we have. So the next one is promise.allSettled. And this one is a pretty new one. It is from ES 2020. And it is actually a very simple one. So it takes in an array of promises again, and it will simply return an array of all the settled promises. And so again, no matter if the promises got rejected or not. So it's similar to promise.all in regard that it also returns an array of all the results, but the difference is that promise.all will short circuit as soon as one promise rejects, but promise.allSettled simply never short circuits. So it will simply return all the results of all the promises. So promise.allSettled. And so now here I will create actually the most basic example ever. So I will simply fake promises by saying promise.resolve success. All right. And so you already know that this here automatically creates a promise that is resolved. And so we don't have to wait for anything to finish like this here. Okay. So then we can have a couple of more. Here we have a rejected one. So let's say error, and here another one. Let's say another success. Okay. And then here we can just call then, and let's see. All right. Now here we want actually all of the results. All right. And so indeed, here we get 3 results, even though one of them rejected. Okay. So this is the result of the 3 promises. And yeah, so this is how they look like when we do them manually with resolve, reject, and resolve. Just contrast that with promise.all. So that would then look different. So here we would get an error. Okay. So of course we can also catch the error then. And so here we would simply get error. And that's again because the .all promise combinator will short circuit if there is one error, if there is one rejected promise. So that's the difference between these two. But now let's go to the last one, which is promise.any. So like this. Now promise.any is even more modern. It is ES 2021. And actually at the time of recording, this one doesn't work in my browser, but probably by the time I'm releasing this course, it will work in the latest version of Google Chrome. And so let me simply do this here as well. So all I'm going to do is to just copy this example here and then do any. And this is not going to work. Let me show you. So we get promise.any is not a function, but again, in your case, it might already work. So let me simply explain what it does. So as always, promise.any takes in an array of multiple promises, and this one will then return the first fulfilled promise. And it will simply ignore rejected promises. So basically, promise.any is very similar to promise.raise, with the difference that rejected promises are ignored. And so therefore, the result of promise.any is always going to be a fulfilled promise, unless of course all of them reject. Okay, but at the time you're watching this video, again, this should already work, and then maybe you can experiment a little bit with this to see the difference between all the 4 promise combinators. And again, the most important ones are definitely promise.all and promise.raise. So keep at least these two in mind for your own projects. Welcome back to the last lecture of this section. And so in this one, we're going to apply everything that we learned in the last few videos to coding challenge number 3. And this coding challenge basically has two parts. So in the first part, I want you to write an async function called load and pause, which will basically recreate coding challenge number 2, but this time using async await. And so of course, that is only about the part where we actually consume the promise. Then you can compare the two versions that you have and think about the big differences and also see which one you like more. Now, in order to do this, don't forget to set your network tab to fast 3G. All right. So that's part number 1, basically converting what we did before. But then comes part number 2, which is again a more difficult one. And actually in this one, you will do something that we didn't do before, but I'm sure that with the instructions here, you can make it. So what I want you to do is to create an async function load all, and this one receives an array of image path. And so that's this one. So it's an array which contains the path of all 3 images in the image folder. Okay, so you receive that array in the function, and then I want you to use the map method to loop over the array in order to load all the images that are here in this array with the create image function. So this one here where we promisify loading an image. Okay. Of course, the map method will then result in a new array, and you should call this one images like this. Now keep in mind that create image here will return a promise. And so the callback function of the map method needs to be special. So you need to consume the promise that comes from create image. And so therefore, as I said, the callback function in the map method should be a special type of function. So I'm not spoiling which function it is, but hopefully you can guess what I'm talking about. All right. But anyway, next, I want you to check out this images array in the console. And is it what you expected? So again, here I want you to think about the result that you get. So this images array, and think if you expected it to be like this, and also if it makes sense. Okay, and what I just said will make sense once you get there. Then, in the next step, you should use a promise combinator function to actually get the images from the array. So this is a very important hint right there. Then finally, you should also add the parallel class to all the images. And so once again, you should probably loop over the images and then to each of them add this class. So again, this part 2 here actually contains some new parts that you will have to figure out on your own and experiment a little bit with that. But at this point of the course, so already pretty deep into it, it's probably a good idea that you start experimenting with some stuff on your own. And so that's why I created this challenge like this. So good luck with this, take all the time that you need, and then I see you back here. Welcome back here to my solution now. So as you see, I already have all the code here from challenge 2. And so what we're going to change now is basically this part here. So we will recreate this big then chain using now async await. So the function is called load and pause, and it is an async function which doesn't have any arguments. We're missing the function keyword. So it doesn't have any arguments. And so as always, we need to wrap everything into a try block. And then here the error. And actually right now it is already allowed to use catch without the error. So that's new in JavaScript. Previously that wasn't allowed. But just to make it consistent, I always use the error here, even if I then don't need it. But here, let's just log it to the console as always. All right. So here is the first promise. So this one. So let's put that here. And since we're using async await, I will now await that promise and store the result into image. So that's basically the variable that we have here as the parameter in the then method. And so that's the same name that makes sense here. So image, and let's use 1 here because we're going to have multiple. Or actually, that's not even necessary because this time we won't need the current image variable. Okay, but more about that once we reach that point. So again, the image is of course the result of this successful promise. All right, and so with that, we already translated this here. Now what we need is to simply log this to the console. And so here we have load image 1 already. Then next up, we have this wait. And so here we can just await for wait 2. And just like before, since the wait promise does not have any resolved value, we actually don't need to save anything to any variable. So here we basically just pause the execution for 2 seconds, and then what we want to do is this. But not exactly this, because now instead of current image, we can use simply image. And that's because now we are still here in the same function, or actually in the same block, and so in the same scope. While here, we defined the image in one function, and then we set the style in another function. And so then we needed to use this global variable. So like this, it is a lot better, of course. And so now we just need to do the same for image 2. So again, we don't need the external variable. We can now simply reassign image. So image 2, then image 2 loaded, and the rest works simply exactly the same. Here, let's just change to error, and with that, we should already be good to go. So load and pause, and here let me comment this out so that the same logic doesn't happen twice. And so this is already part 1. Let's set our network here to slow, or actually fast 3G. And let's actually inspect the images arriving here. So I think that this part here is really helpful. So seeing everything arrive, it's just a bit difficult. But anyway, let's just try it. And so here you see the image loading. And so then here was the waiting time of 2 seconds, and then the next image loaded and finished. So again, image 1 loaded during all this time. Then we had our 2-second waiting time right here. And then during this time, the second image loaded. And here we can actually get all this detail about that. So this is really interesting stuff if you want to dig deep into this. All right, but anyway, that's part 1. And so now let's go to part 2 to create this async function called loadAll, which receives image array. And then we loop over the array and create an array images. So just keeping these names in mind. So part 2 will be loadAll is an async function which takes in img r. Then as always, this block, so try catch. And now here we have to create that images array, which is the result of image r dot map. But now we need to think about the callback function here. right? So in each iteration of the array, we have one image, and we want to use the createImage function to load that image. Now, this function here returns a promise, right? And so we should await that promise. Otherwise, nothing is going to happen. And so here we need to make this function an async function, so that then in there we can use await. All right. So let's actually pause this one here just as instructed. And instead we will call loadAll with this test array. All right. And then the instruction was also to check out this images array. So images. Okay. And so now let's take a look at the console. Let's make it a bit bigger again here. And so what we got here are actually 3 promises. So we have an array of promises and not the images themselves. And this is actually a big source of confusion for most async await beginners. And I actually remember really well when I first stumbled upon this problem and didn't really understand why this was happening. However, with all the knowledge that you just learned in this section, if we really think about this, then it might actually make sense. So here we have an async function, right? And this is an arrow function. So we have an implicit return. So this is like returning something from this callback function in each iteration, right? However, as we already know, an async function will always return a promise and not really the value that we're interested in, right? Instead, the value that we want to return is going to be the fulfilled value of the promise that the async function returns. Remember that? And so that is exactly what is happening here, but it is happening simply 3 times. So we are returning something 3 times from an async function here, and so therefore the result will be 3 promises. Okay? So just like it happened in that lecture where we attempted to return a string from one of the functions. Remember that? So here it is indeed the exact same situation. So again, we end up with this array of promises. Okay? But of course, behind the scenes, the images are already being loaded, and so we're basically fine. So all we need to do now is to get these image elements themselves out of the promise. So how can we do that? Well, we could take each promise out of the array and then manually await it, but that wouldn't make much sense. First, because we would have additional work, and second, because then that work would not be happening in parallel, right? But we want it to be happening in parallel, and therefore we can use promise.all. So promise.all is perfect for this because it already expects an array of images. And so this images array is already perfect to handle by this function, right? And so now we simply need to store the image elements here. So let's call it that into this array. So let's then take a look at that. And so now this is, of course, going to take some time. So this can only happen once the images are actually loaded. And so now, indeed, here we go. All right. So here are the 3 image elements, and they're now hidden. And so that's why we need to add the parallel class later. So again, this worked because here in this loop, of course, the await keyword did its job of pausing the execution of the function, right? And so therefore, only after that, we did then promise.all to actually get the image elements out of the promises array. So this was a bit tricky, but maybe you did figure out that this is how you solve this problem. So once you need to use AsyncAwait in a map method like this, which believe me is pretty common, then you end up with an array of promises that you can then, as a next step, handle like this. So with the promise.all combinator function. And so now the next step is actually pretty easy. All we have to do is to loop over this array and add the parallel class to it. So image element. And so now we don't want a new array. We simply want to do something on each of the elements. And so image.classList.add parallel like this. And let's get rid of this console.log here. And in our network tab, oh, this is pretty big. So you see the images are all loading there now, right? And here we go. So now we have the images nicely displayed and set side by side. Let's make it a bit smaller so we can actually see something. And indeed, there we go. Let's just see it one more time. Also here, the resources actually loading. To see it, we need to make it even smaller. And so you see that down here, the three images basically started loading all at the same time, which is because of this loop here, which will of course execute these three callback functions all one after another. Okay. All right. And with this, we are actually finished with this challenge and also with this whole section. So make sure that you understood what we did here in this part 2, because this is pretty important. But besides that, your job is now done for this section. So really happy to still see you here and still learning JavaScript and still making progress. So well done. You can be really proud of yourself. And I really mean that. And now I see you back here next time in the next section. Welcome back to the final project of this course. And in this one, we take everything that we learned throughout the course and put it all into one beautiful, modern, and really advanced application. So we're going to use things like classes, modules, promises, AsyncAwait, parcel, and so much more. Also, we're going to dive even deeper into flowcharts and project architecture in this project so that you become more and more confident and prepared to actually write applications by yourself. So this will be a ton of work, but also a lot of fun. And so I can't wait to finally show you this project now. Hello and welcome to the biggest and most complete project of the course. And this is kind of the final project of this course, which brings everything that we have learned up until this point into one big and beautiful project. And so just like with the Mapty project before, let's actually start by taking a look at this project. And this is it. So this is the Forkify application that we will build together over the next couple of hours. So this application is all about searching for recipes and displaying them here in our user interface. And in order to get a good idea of how this application actually works, you should probably follow along this demonstration by going to this URL. So Forkify v2.netlify.app. And so let's start for pizza here. And so you see that right away here on this left sidebar, we get all of these results. And when we have more than 10 results, they actually get divided up on multiple pages. So we have this nice pagination here, which is a very common feature of web applications, right? So you've seen this all the time probably. And so now in this project, you will learn how to implement this yourself. Okay, and now let's actually click on one of these recipes, and you see that then it shows up here on the right side. So we have the cooking time, the servings, all the ingredients, and then also a link to the page where the recipe actually comes from. Now here in the servings, we can actually decrease or also increase the number of servings. And as you see down here, the ingredients will then automatically get updated, right? Then another cool thing that we can do is to bookmark recipes. So as we click here, then that button changes, and we also got that recipe bookmark here in this nice panel now. And here you see I already had a bookmark before, and as we click that, it will then of course move to that one. Now, if we click here again, then that will basically unbookmark the recipe. And so you see that now it's gone. And let's do the same here. And so now it's empty. And we get this kind of warning message instead. All right. Now, finally, we can actually also add recipes. So just click on this button. And then here we can just fill in this form. Now in this demo version, that's actually not going to work because that would very quickly clutter this entire application here. Now, what's special about this recipe upload is that all the recipes that you upload yourself will only be visible for yourself. So here, for example, I have this JS pizza, which was done by me. And so therefore it has this icon here and also this icon here. So it means that it was the user itself. Now, when you open up this page and search for pizza, then this recipe here should probably also appear for yourself, but that's only because this version has like a fixed developer API key. And so each recipe is associated to a certain developer key. And we will see what that means by the end of this section when we actually implement this. All right. But I think that's actually it. So that's the whole functionality of the Forkify application, which seems pretty simple, but it will actually be a lot of work to implement all of this. And so hopefully it's going to be a great learning experience for you. And once again, I tried to design this application like as modern and beautiful as possible so that you end up with a real nice application in your portfolio in the end. Okay. But with all that being said, let's now actually go plan this application. So now that we know what the project looks like and also how it works, we need to go through the same planning steps that we did in the MapT project. Now in this case, we will actually leave the architecture for a bit later and only talk about the user stories, features, and also about the flowchart for now. And to start, remember that a user story is a description of the application's functionality from a user's perspective. So basically, when we write user stories, we need to put ourselves in the shoes of our users. Now, all the user stories put together will then provide a clear picture of how the whole application is going to work. And so based on these stories, we will then be able to implement all our application's features. All right, so let's say that we are now kind of the project manager for Forkify, and let's also pretend that we didn't see the final version of the project yet, because of course we have to write user stories usually before we implement the project, right? But in this case, since we're kind of doing it together here in this video, of course it's better when we already know what the application looks like. But in the real world, this is basically going to be your starting point. So for this project, the first user story could be, as a user, I want to search for recipes so that I can find new ideas for meals. And so you see, again, we are using the format of as a type of user, I want to, and then an action, so that, and then a benefit. So here the user wants to search for recipes so that they can find new ideas for meals. Then next up, the next user story is, as a user, I want to be able to update the number of servings so that I can cook a meal for different number of people. And that, of course, makes a lot of sense in any application of this kind. Then next, as a user, I want to bookmark recipes so that I can review them later. And again, this really makes sense in any kind of real-world application like this. Then, as a user, I want to be able to create my own recipes so that I can have all my recipes organized in the same application. And finally, as a user, I want to be able to see my bookmarks and my own recipes when I leave the application and come back later. And so this way I can close the application safely after cooking. All right, and once again, let's kind of pretend that we came up with all these user stories while kind of brainstorming for this application. And so now we can use all these user stories for our next step and come up with the features that we need in the application. So first, the user wants to search for recipes. And so therefore, our application should have a search functionality, which is basically an input field which will send requests to an API with the searched keywords. Then the application should of course display these results, and also with pagination to make it more user-friendly in case that there are many results. And then of course the application needs to display the selected recipe with relevant data such as cooking time, servings, and ingredients. Now the next user story is pretty simple, so all we need is a functionality to change the servings. So basically updating all ingredients according to the current number of servings. Then in order to bookmark recipes, we simply need a functionality for that. So basically allowing users to bookmark the recipe and then display a list of all of them somewhere on the page. Then for the next user story, what we need is basically a feature that allows users to upload their own recipes, which should then automatically get bookmarked so that the user can easily find all of their own recipes. Now, what's important here is that each user can only see their own recipes, but not the recipes from other users. And we could go ahead and implement this in a very complex way, like, for example, creating user accounts, but we will keep it very simple and basically simply associate uploaded recipes to an API key. And again, we will see by the end of the section how that is going to work. Now, finally, we are going to need a feature that will store bookmark data in the browser using local storage. And that we already did before, and so this part is going to be fairly simple. Then to finish, whenever the page loads, we need to then read all the saved bookmarks and display them somewhere on the page. Great. And with this, we now know exactly what we need to implement. But now let's take this list of unstructured features and actually put it into a nice structured flowchart, which will allow us to plan how exactly the application is actually going to work. So we're going to start only with these first 3 features in order to keep it simple now and not overwhelm you right from the start. So we're going to build this flowchart in 3 parts, and now starting with these 3 features. And as always, we're going to focus on events, and the first event in our web application should probably be the user searching for a recipe. And so that's our feature number 1, basically. So when a user searches for a certain recipe, then we need to asynchronously load the search results from our API. And so, of course, that happens asynchronously. And then once the results are in, we will simply render them in our application. However, we will not render all the search results right away because that would be overwhelming. And so instead, we also render some pagination buttons in order to hide basically part of the search results on different pages. So that makes sense, right? And then as the user clicks one of the pagination buttons, it will then render the search results for the new page that was selected, basically. And it will also render new pagination buttons. So for example, when we're on page 2, then there will be a button to go back to page 1 and a button to go to page 3. But when we're on page 3, then the button to go back will point to page 2 and the button to go forward will point to page 4. And so we need to re-render these buttons basically every time that the user clicks on one of them, right? Then finally, we also need the logic to actually display the recipe. So when the user selects a recipe, then we need to asynchronously load all the recipe data from the API. And then once the data arrived, we render the recipe to the user interface. And we will actually also do the same whenever the page loads with a recipe ID in the URL. So I think I showed you that in the beginning of this video. So whenever we click on a recipe, then the URL will change with the recipe ID. Remember that? And so it's important that, for example, if we take that URL and copy it and paste it, for example, to another browser, that then the recipe corresponding to that ID should also load right away. And so that's why here in this flowchart, I have the load recipe on both events. So when the user selects a recipe from the user interface, or also when the page loads with a recipe ID already in the URL. All right, and that's actually it for part 1 of the flowchart. And in fact, these are basically already our core features. So the most important features of the application. So searching for recipes, rendering search results, and then also rendering the individual recipe that was selected. And so all this will probably take us half of the section to implement. So there really is a lot to do. Now we will start implementing the project only with the recipe displaying. So only feature number 3, which is basically this right part of the flowchart. And this will allow us to start implementing some functionality and also play around with the application a little bit, but still without thinking about the architecture. And so without the rigid structure that might be imposed by the architecture. Great. So with this, we basically have this part of the application planned. And so let's now finally get to work. All right, so let's set up our project and also start to load some recipe data from the Forkify API. And here, as always, I already have the starter files loaded. Now this time we have a bit of a different structure here. So I have index.html out here, but then all the rest of our assets for this project are here in this source folder. So in the source, we have images, JavaScript, and Sass. So for JavaScript, right now we have controller.js, which contains this little starter code here. And then I have this Sass folder. And in case you don't know, Sass is basically a better way of writing CSS, which has some nice additional features, which makes writing CSS in a large-scale application a lot easier. Now, browsers actually don't understand Sass, and so it has to be converted to CSS. And so Parcel is going to do that for us. And so I left these Sass files here so that you can see that Parcel is actually also capable of doing that. All right, and then here, just some images. And of course, down here, we have our flowcharts and also a small diagram about the architecture. Okay, but now let's open up a new terminal here. And then just like before, we need to initialize a new project by writing npm init. And so this command will then create our package.json file. So this project should be called simply Forkify. Then the version might be version 1. here let's just say recipe application, or really whatever you want. Then this one doesn't matter, neither this one. And now you can just add your own name here if you'd like. And so that's it. And so again, this now created this package.json file right here. Let's get rid of this one here actually. Or actually, let's just change it to .html. So this is kind of our entry point. So let's specify that here, even though it's not really important. And here I will start by setting up the npm scripts now. So just as we did in the last section. So this one is going to be npm start instead. And here we will want to start parcel on index.html. So index.html is again going to be our entry point. And then since we are here, let's also already add our build script. So basically the command that we are going to run in the end once we're ready building the application. And again, index.html. Now, sometimes in projects, we don't even have an HTML. And so, of course, the entry point can also be a JavaScript file. And also, this could be in a different folder. And we can specify all that here in the parcel command. But once again, we are just keeping it very simple here. Now, in order to actually run parcel, of course, we need to install it. Now, in the last section, we simply installed parcel by writing npm install parcel, and then as a def dependency like this. And so this would then basically install simply the latest version that is available on npm for parcel. And at the time I'm recording this, that is version 1 point something. However, parcel 2 is almost ready at this point, and so I want to use a beta version of parcel 2 so that you can use parcel 2 in the future. All right. So if parcel 2 was already out, then we would simply write @2 like this. However, right now it's just a beta version, and so I have to type @next and then add it as a def dependency. So again, I'm writing @next here to install a beta version. So let me run this, and in case that you get any error, then please go ahead and simply install parcel @2. So you see here that this is going to install @200 beta 1. Okay, and here we go. So again, you see that we are at version 2 beta 1. And if you got some error here, again, then please try parcel @2. So it's really important for the rest of this section that we are actually all on parcel 2 dot something. So here it doesn't matter if you have 2.1 or 2 or 3, but it should be 2. So that's what matters from this part. And so now let's actually start parcel by running our npm script, npm run start. And actually the start script is a special one in npm, for which one you don't even need the run. So you can just write npm start, and that will then call your start script. All right, so it's installing Sass, and now we get this error here for the module Sass. And so let's quit this here with Control-C, and then I just say npm install, and so this will then install Sass here for us. But if you're still running into some kind of error with Sass here, then please just try to install Sass using the exact same version number. So npm install Sass and then add 1.26.10. And so that should then fix any remaining problem. And if it didn't, so if even after that you still run into some problems, either with Sass or with installing parcel or running parcel, then please take a look at the frequently asked questions in the GitHub repo. Okay? And only in the last case, you can of course also ask in the course Q&A section. But Anyway, if we now try to run npm start again, then it will work. And indeed, here it is. So we now have the node modules folder, which contains, well, tons of modules. And then we also have our distribution folder, right? And you see that here everything is in one folder. So our index.html, and then also the controller script, which is this one. Well, not really this one, but the compiled one. And also you see that now we have an actual CSS file, and you also see all the images. So a real CSS file. Let's take a look at index as well. And so you see that now it replaced the controller.js here in the source. And also here I was referencing the SCSS file, so the SAS file. And it is because of this that Parcel actually knows that it needs to compile the SAS file to CSS. So basically I referenced this SAS file here, and therefore Parcel knew that it had to include that file in the distribution as well, and to also replace then the link to the actual final CSS file. And the same is true for all the images. So it basically copied all the images to the distribution folder and gave them a new name and replaced their source here in the HTML. Okay? And this is very important to keep in mind as we go building this project. But of course, this folder here is not really important for us in development. So everything we will develop will be here in the source folder, and only what we then see in the browser is actually coming from this distribution. So again, that's the whole logic of having a module bundler. So it takes our basically raw source code and compiles it into this nice package here, let's say. So this folder that is ready to ship to browsers. Okay? So for now, we no longer need this HTML file. And so we can now think about our controller here and actually think about making our first API call. And we can actually also open the page here by clicking Option and then here. Well, that opened in another tab for me. So let me just copy it right here. Okay, let's open up the developer tools as well. But for now, of course, we have nothing here because we don't have any code yet. But let's just log something to the console just to see that our parcel setup is working. And you see that it already built a new version. And indeed, we have test now in our console. Great. So everything is working. And so, yeah, let's now make our first API call. Now, for this project, I actually developed my own API so that we are not dependent on any third-party services. And the API is at this page. So let's copy it and let's go there to check out the documentation. So any good API needs some sort of documentation. And so this is the documentation that I wrote for our Forkify API version 2. So version 1 was for the old version of this course. So some details about this API is that search terms are limited. All you can search for is the terms that are in this list here. But to test this application, that should be enough. And you can only make 100 API requests per hour in order not to overload our servers. Because again, this is here my own API that I'm running on my own server. Then the API key is what we will need to upload our own recipes. But again, more about that later. And then here we have basically our main URLs or routes of this API. So the first one is used to get all the recipes or to create a recipe. But for now, let's focus on this one, which is simple to get one single recipe. So the path of this part of the API is this here. So this URL then /recipes / the ID of a recipe. And down here is an example of that. So for example, this one here might be the ID, and then here the key, but again, the key doesn't matter for now. And we can click on this and then see exactly the kind of result that we will get. And so actually, this is the URL that for now we will use in our code to basically get exactly this recipe here in our application. So let's copy this and go back to our code. And so now, as always, to make an AJAX request to an API, we use the fetch function. All right. And now that we have this, let's actually create some function around this. So an async function so that we can use async await. So let's call it show recipe. So an async function. And then here, as always, we use a try catch. And if there is an error, we want to alert that error. So very simple error handling for now. And now let's take this here and await it and store the result into the res variable, which stands for response. And I hope that all of this here is nothing new for you at this point after the last couple of sections, right? So just keep in mind that using the fetch function here will return a promise. And so since we are in an async function, we can then await that promise. So basically we will stop the code execution here at this point, but that's not a problem because this is an async function anyway, which only runs in the background. So we are not blocking our main thread of execution here. But anyway, once we have that result, we then need to convert that to JSON. So as always, let's create a data variable and then await the response.json. So the JSON method is, again, a method that is available on all the response objects. And a response object is exactly what the fetch function here returns. And so, yeah, we can then call JSON on that response, which returns another promise, which we then have to await again. And in the end, we will then get our data stored to that variable. Okay. And then let's actually console.log both the response and also the data. So give it a save. And we also should call this here right at the beginning, because otherwise nothing is going to happen. And so, which one is ours? Here we are. Okay, and you see that we already have a result here. So first is the response. And so again, as I mentioned, this returns a response object, but then the data itself is here. And so we get this status here, and then the data itself. Make it a bit bigger here. Okay, and so then here, inside of data, we get the recipe itself. Okay, so it contains all of this data here, cooking time, the ID itself, then the ingredients, publisher, servings, and so on and so forth. So that works beautifully. And as always, we started here assuming that there will be success. But now let's try to create a wrong ID here, which doesn't exist on the server. So just something like this. And let's see what happens then. And so you see, we get the bad request. Here then in the response, we can see that OK is set to false. And so this is what we're going to use. Remember that? So when OK is set to false means that there was some kind of error in the fetch. And so we can then use that to create our own errors. So again, just like we learned in the asynchronous JavaScript section. Okay. But then we still get a response here. And this response says fail. And then also this message of invalid ID. And then the ID that we provided. So also the API itself returns a nice error message. And so let's actually use that error message now. Okay, because simply bad request is not a very informative error message. It's way better to actually use the one that the API returned to us. And so that's at dot message of this object. So we need to do that after this one here. And so we can say if response.ok is false, so basically if response is not okay, then we want to throw a new error. And then in there, we can use the .message property that I just mentioned. And again, that one is already coming from the data. So from the response of the server, while the OK property is stored in the response itself. Okay, and then let's also provide the status code. So that is at response.status. Okay, and you see that somehow we already get the error here, even though we're not at Chrome. But anyway, that alert window appeared, of course, because down here in the catch error, we are alerting exactly that error that we throw here in the try block, right? And so as we go here, let's just try to reload. And so indeed, here we get our error as an alert window. Okay. But now let's take it back actually. And so when we're back, then our data here is also back here. Okay. Now just to finish, let's actually format that data a little bit nicer. So basically I want to create a new object based on this object, which has some better variable names. So here we have, for example, these underscores, and these are very unusual in JavaScript. And so many times what we do is to basically kind of reformat this object that we get here. So basically I want to get rid of these underscores. And so let's create a new recipe variable, which should be data. And then remember that it is again data. And then .recipe. So let's see that again just to make sure. So this here is the data variable, and then in there we have data again, and then in there is .recipe, right? And so here we have recipes on both sides, and so we can use destructuring. So let's take that back. And I called this one a recipe with let, so that we can now basically create a new recipe object based on that. So the ID is recipe.id. The title is going to be recipe.title. The publisher will be recipe.publisher. And there would have been other ways of doing this, but this is kind of the quick and dirty way. So source URL is going to be recipe.source and then underscore URL. So this is one of the ones I wanted to change. Then there's also an image URL property, and this one I want to simply call image URL. Then the servings might be just recipe.servings. And we're almost done here. So cooking time is recipe.cooking time with an underscore. And finally, ingredients is recipe.ingredients. Okay. Now let's actually get rid of this and simply log to the console the recipe object that we just created. And here, ingredients looks wrong. Ingredients like this, and here the same. Everything else looks correct. And yeah. So here is our nicely formatted recipe that we just got from the server. And of course, that would work for other recipes as well. So let's go back to our documentation page and get some other ID. And so that ID we can basically get from this search URL. So this path here will take us to all the recipes there are for a certain search query. So let's try this one here, which is for pizza. So you see, it is the route, so the URL that I just told you, /recipes. And then we have this query search set to pizza. So after this question mark. And this is a very common format of basically sending variables over URLs. So search is like a variable, and then pizza is that value. And so in this case, this is the query string. And in this case, what we want to search for is pizza. And so let's now just take any random ID of these. So just copying it. Let's go back here. And then I will just duplicate this line and comment it, and then replace this part here of the URL with this other ID. So you see it's slightly different. And so now we should get a different recipe. So let's see. And yeah, this time it is called pepperoni pizza burgers. And so of course, later in the real world, we will then get these different IDs from our search results here in the sidebar. Okay, so we successfully started up our project and already did our first API call to the Forkify API that I created just for this project. So this was a nice start of the project, and now in the next video we will then actually already render this data to the user interface in order to create something like this here. And I hope you're excited for that, and so let's quickly move on. So after loading the recipe data from our API, let's now render that data in our application. And for that, let's go to our HTML file to basically get the template from there. Let's close down this terminal, which will keep working in the background. And so here is the results part, the pagination, and then here we have the recipe class. So the recipe class is basically this whole container. So here in this case, it's this whole gray container, which is the one that will contain the rendered recipe. Okay, then right now it has that message. So again, it is this message here that is already rendered there at this point. Then here is the code for a loading spinner, for an error, and then here actually for the recipe itself. So here we have that image, and then all of the information about the recipe itself. And so it's all of this code that we need now. So let's grab all of this commented out code and copy it and paste it here into this function. So let's add a comment here. So loading recipe, and then afterwards, as step number 2, rendering the recipe. And for now here we are doing this like really big function. But of course, once we start thinking about the architecture, we will then break this up into functions and modules and classes and so on and so forth. And so, as always, doing a big template literal here, just as always, so that we can then replace all the data here that we need. Just fixing the indentation here now. And so now let's take all the data that we need. And the first one here is the image. So let's replace this string here with recipe.image. So just like we specified here. And so this image property is basically a URL which points to the location of the image on the Forkify API server. Then here we have the recipe title. So this one here, dot title, and actually we also have that title here as an alt text of the image. Okay, then here we have the clock. So this 45 here is the cooking time. So recipe, and missing the block here, dot cooking time. Then down here we have servings, and so that's this number here. So number 4 will now be replaced with the data coming from the recipe object. So recipe.servings. And let's keep going. So down here we have the ingredients. So for each ingredient, there will be one list element of this. So in this example, right now we have 2 list elements and 1 for each ingredient. But let's actually keep that for later. And for now, keep filling the rest of the data here. So this is the next piece of data, which is the publisher. So here it says recipe publisher. And so let's change that to recipe.publisher. Then here we have the source URL. So let's take a look at that, maybe here to make more sense of this. So we used most of this data here already. So here is the URL to the recipe itself, where it actually comes from. And then about the ingredients, as you see, it is one array, and each position of the array contains one object, which contains the quantity, the unit, and the description of each ingredient. And so we will have to basically loop over this array and then use all of this data to create one list element for each of them. Okay, but for now, let's go back and finish the data here. And in this case, replacing this URL by the one coming from the object. So that's recipe.source URL. And so except for the ingredients, that's actually it. So yeah, before we can check out the result, of course, now we need to actually insert this HTML into our DOM. So for that, we can use the insert adjacent HTML method. And we need to do that on the parent element, remember. And I already selected that up here. So remember, that's the element with the class of recipe. So just to remember, it is this div element. So that is called recipe container. And so that's where we want to attach this HTML markup. So recipe container dot insert adjacent HTML. Then let's do after begin. So basically as a first child, and then the markup variable that we just created. And that should be it. So this should now render the recipe in the user interface, except for the ingredients. And indeed, that's looking really nice already, right? So the ingredients are still the old ones, but the rest is really nice, except for that we have still this message here from the beginning, and also that we are missing all the icons. So you see, there are no icons to be found here. In the real one, of course, there are icons all over the place. So we have 3 problems here. We have this message showing, we have the ingredients, and we have the icons. And let's start with this message and then the ingredients. So before we insert any new markup, we need to get rid of the markup that is already there. So let's simply do recipe container dot inner HTML and set it to nothing. So emptying it out. And so you see, now it is gone. All right. So let's now worry about the ingredients. And again, we will need to loop over the ingredients array. And for each of them, we should then create this kind of markup here. So how should we do that? Well, basically exactly what I just said. So we take recipe.ingredients, and then we loop over that using some array method. But what array method should we actually use? Well, remember that in the end, the expression that we need here needs to return a string of HTML. And so that means that our array method needs to return something. So for each is not the way to go here. So not for each, right? But instead, we are going to use map. So map returns a new array with the same length. And so that array we will then in the end be able to simply join. And so now we can loop over the array by specifying a callback function. So each element is going to be called ingredient, and then here we can do something. So let's simply replace a string here, right? So taking this and put it right here. And then of course we don't need this one anymore. Okay. Then here we have some kind of error. But never mind. Let's think about the data here first. So let's take a look at the data actually again. So at the array, so each array element is an object which has quantity, unit, and description. Okay. So this ingredient is now that object. And so here we can say ingredient dot quantity, then here the unit, so ingredient dot unit, and then finally here instead of pasta we want the ingredient dot description. And so now here we will have an array in which each element will contain this markup corresponding to the ingredient. And so now all we need to do is to transform that array of strings into one big string. So we can take the result of this map, which is that array, and call join on it like this. And so now the result of this entire expression is going to be a big string containing all the ingredients. So if we give it a save now, then indeed, here we have our 8 ingredients. Okay, so that's pepperoni pizza burgers. And now, remember we have a second one here, so let's switch them out again. Give it a save, and now we get, well, this pizza here. And so indeed, it now has different ingredients, different publisher, and everything is different. Great. But now there is one thing missing, which is the icons. So let's see why that is. Well, remember that the page that is displayed here in the browser is this HTML here from the dist folder, right? And so remember that all the images and really all the assets are now coming from this folder. And that includes the icons. So our icons are always coming from this icons.svg file. But now the icons are actually coming from icons.all of this here. And you can see that, for example, right here in the search bar. So icon search is coming from icons.96 and so on and so forth. However, in our template literal, we are still writing basically the old path to the icons. So this one here. And so right now, JavaScript will not be able to find this. So in the dist folder, this one here, there is no source / image folder in which there is icons.svg, because that exists only in our source folder. So only right here where we are developing the application. But again, right now, we are basically shipping the application already. And so it's using the data from this dist folder. And so now we need a way of telling our JavaScript that the icons file is no longer this one, but instead it is this one. And we can actually do that with Parcel by basically simply importing the icons file. So let's go to the top of our file, because I like to keep all the imports always at the top. And so again, in Parcel, we can import more than just JavaScript files. We can import all kinds of assets, and that includes images. So let's import, and let's call it simply icons, but this name can be anything that we want. From, and now the path to the original icons file, basically from the view of this controller file, right? So here we are in controller.js, and so now we need to find the path to the images. So to this original icons file. So we need to go one way up. So exactly the way we browse the file tree in the terminal. So ... always means the parent folder. And so right now we are back in the source folder, which is the parent of JS. And then from there, we can go into images and then icons.svg. All right. Now this is the way it used to work in Parcel 1. So if for some reason you are running Parcel 1, then this is the way to go. But in Parcel 2, it works almost the same way. But then for any static assets that are not programming files, so for any like images or videos or sound files, we need to write URL, then colon, and then the path to the file. Okay, so let's take this out. And then let's log this icons to the console so that you see what this icons really is. Because in fact, it is nothing more than simply the path to the new icons file. So the localhost 1234 is in this case basically our dist folder. And then in there, the file that we need is icon.96f and so on and so forth. And so that is exactly this file here. Okay? And so now let's use that. So everywhere it says icon, so everywhere we have this old path, we now want to replace it simply with the icons. So let's select all of them using Command or Control D. Or if that doesn't work for you, you can always probably use Command F or something like that. But anyway, now we have all of them selected at the same time. And then I can delete them all and then insert the icons variable here everywhere. And so now, if we give this a save, then our icons are back, right? So starting here, then in all ingredients, and here also all over the place, we now have our icons back. And now just to finish this lecture, I want to give this one more touch, which is this here. So watch what happens here in the recipe when I load the page. Well, that was pretty fast. Let's see again. So maybe for half a second or so, you saw a loading spinner there. And so that's what I want to have here as well. So before the recipe arrives, I want like a loading spinner there, because that's a very common pattern that you see in all kinds of applications, right? And it's actually very simple. So we have the code already here in our HTML. So it is this spinner here. So let's grab this code. And then here I will simply create an external function called render a spinner. And let's make this a very generic function that we can reuse. And so let's pass in the parent element. And so then we can simply attach this to any parent element that is passed in here. So as always, creating a markup variable. And then our code here. And just like before, we need to now replace this old path with the new path. So icons. And then, of course, we need to add this HTML to the DOM as a child of the parent element in this case. So parent element dot insert adjacent HTML after begin and markup. Okay. And now let me just quickly show you why this is going to work. So here in the CSS, let's look for spinner. And here you see that the icon inside of the spinner class has this rotation animation that keeps going forever. So that's this infinite attribute here in the animation property. And this rotation animation I created here manually using keyframes. And basically what it does is to rotate the element to 360 degrees. And so if you ever need a spinner like this, you can simply basically copy this code here. All right. Let's close what we don't need here. And probably before we insert this, we should also clear the parent element. So just like before, setting the inner HTML to nothing. And now let's actually render the spinner. So let's do that here as we load the recipe. So right here. So render spinner, and then the parent element in this case is going to be the recipe container. All right, let's go back and reload. And there it was. You saw it. Let's make this a little bit slower by changing our network speed here. And so it took a little bit longer, maybe slow 3G is going to be even better. And so now it's going to take a lot more time. But indeed, here it is. So that spinner is a nice touch, I think. And it definitely makes this application feel more real world. Now, just to finish this video, something that I should have done in the last video already is to add polyfills for ES6 features to our code base. So just like we did in the previous section as well. So remember to do that. We installed some special packages. So the packages are called npm core.js, and we can actually install multiple packages at the same time. I think I never did this before. So this is how it works. Regenerator runtime, and then hit enter, and then let's wait for these packages to download. And here they are. So they should be, yeah, so right here. And now all we have to do is to import them here at the top of our file. And so with this, we make sure that most real old browsers are still being supported by our application. So actually, we don't even need to save it anywhere. We can just say core.js and then stable. So VS Code, one more time, is really smart and can really help us with package imports like this. So again, this one here is for polyfilling async await, and this one here is for polyfilling everything else. And we could just cherry pick some features and only import those, but let's simply polyfill everything. Okay, don't need this terminal anymore. This one here already reloaded. And you see, everything keeps working the same. All right. So we have this working. Now in the next video, let's quickly add some event handlers so that after that, we can start talking about the architecture. Let's now add some event listeners to our application and kind of simulate that we already have some search results in place. And let's start by taking a quick look at our flowchart here. So we already implemented this part here of loading a recipe and also of rendering it. But now in this lecture, we want to also hook up these two event listeners here so that the recipe is actually loaded on one of these two events here. So when the user selects a recipe from the results list, or when the page loads with a certain recipe ID. Okay, so let's do that. And let's also take a quick look here at the demo version. So searching for pizza again. And let's click on any recipe here. And so again, here you see that we have this hash. So everything that comes after this hash symbol here is called the hash. So this is the ID of the recipe, and all of this together is called the hash. And the way this is going to work is that whenever this hash here changes, a new recipe is going to be loaded. So if we click here now, watch what happens there in the hash. So you see that it changed. And that changing of the hash is actually an event that we can listen for. So again, the hash here now changed, you see. And so we can then listen for that event, take the hash, and from there take the ID, and then load the recipe with that ID. Okay? Did you follow that? And if not, that's not a big deal. So let's just see in code what I mean by that. And to start, we actually need a way of triggering a change of the hash. All right. And we can do that by adding a fake link here in the search results. So let's simply add a link here with the href of hash. And then here as the hash, let's actually copy this one. And you can copy any other ID. This doesn't really matter. This is just to show you how we can listen for the event of that hash changing. So give it a save. And so here now is that very small link. And watch what happens when I click here. So you see that the hash changed, right? And actually, let's add another one here. So 1 and 2. And now here from the controller, I can get one of these IDs. So let's say this one and put that one here. So these are two IDs of two different recipes. And now as we click each of them, you see that the hash up there in the URL bar keeps changing. And so again, we can listen for that event. And so let's do that now. So let's come down here. And then window.add event listener. And the name of the event is called hashchange. Okay? And the function that we want to run then is show recipe. So let's remove it from here and only run the show recipe function whenever that hash changes. However, that is not really helpful yet, because the next step is that we actually need to get the recipe ID from the hash, right? So let's go up here. And so let me just show you what I mean. So right now, when we click here, then some recipe will get shown. So you see that it loaded this spicy chicken. But now if I click here, then it will load the same one, because we are still hard coding this ID here. But instead, here we want to show the recipe with this ID and here with this other ID, right? So we want to dynamically get the ID here from the hash. And that's pretty easy to do, actually. So we can actually do that out here of the try, or we can also do it inside. So that's not really important. So let's say the ID is window.location, which is basically the entire URL. And then from there, we can take the hash. Now that's not yet everything, but let me show you what the ID looks like right now. So let's see. And here it is. So it's basically the ID plus this hash symbol. And so we want to basically remove this first character. Or in other words, we only want to start reading from the string basically at the first position. So we can do that easily using the slice method starting at 1 all the way to the end. And so now, instead of having the ID hard-coded here, like we have right now, we can simply insert the ID right there. So, ID. And so let's now check. Okay. And now it's Jay's signature pizza crust. And if you go here, then it's the spicy chicken. And as we click here, then again it changes. And you see that the ID that we get here of this recipe object is indeed exactly this one here that is coming from the URL bar. Great. So this was actually already a pretty important part of our application's functionality. But now what happens if we take this entire URL and copy it and want to open it in another tab? Well, then no recipe at all shows up. And so that's because this time the hash did not really change, right? We simply opened this page here, but we never changed the hash. And so we also want to listen for the load event. So basically for the event of the entire page loading. Okay, and that's easy enough. So all we would have to do is duplicate this and listen for the load event. So this event here is fired off immediately after the page has completed loading. But here we have some duplicate code. And so I actually wanted to show you a nice way in which we can do all of this at the same time. And imagine you had like 10 events for which you wanted to run the same event handler function. So then it wouldn't be good to have this same code here 10 times, right? And so instead, what we can do is a nice array which contains these two events. So hashchange and load. And then we can simply loop over this array and do something. And so for that, we use for each. And in this array, each element is an event. So E for event. And then here, all we have to do is window.addEventListener. And then the event, let's call it EV, because usually the E is the actual event object. So let's not get confused here. So the event, and then the handler function. Okay, so this is now exactly the same as having these two lines here. So in the first iteration, this EV will be hashchange, and in the second, it will be load. Right? Let's just comment this part out. And, well, let's copy this again, close it, and open. And indeed, now it loaded the recipe right at the beginning. Okay. And now just one more scenario. Let's say we didn't have any hash. Well, then we get an error, right? So something went wrong, and then our spinner here keeps loading forever. And so the problem is that right now we don't have any ID, right? So right here, we are trying to read the ID, but then the location doesn't have any hash. And so therefore, maybe you saw it here, we have an empty string, basically. And so then we are trying to find a recipe for the empty string. And so, of course, then we get an error. And that error will then trigger the alert window that we saw. And so let's put a simple guard clause right here, saying that if there is no ID, then return. And that's it. And again, using guard clauses like this is really the modern way of performing this test. So the old way would have been to write if ID, and then we would have to wrap all of this code here into the if block. And so that would then create unnecessary nesting and make our code harder to read. So if we save it now, and reload it now, well, then we don't get any error and everything works fine. And so we can now safely click here, and then each of these different links will load these different recipes. All right. And that's actually it for the very core functionality here that we have in our flowchart. So at least of this right side of the flowchart. So this is now basically implemented at this point. However, it is not implemented in a very clean way. And so in the next lecture, it is finally time to talk a little bit about the architecture that we're going to implement in this project. So we already implemented a part of the Forkify application, but at this point, it has no structure whatsoever. And so now it's time to talk about the project's architecture, but also about software architecture more in general. Now, we touched on this already in the Mapty application a little bit earlier, but in this lecture, let's now go a little bit deeper. And first of all, why do we even need an architecture when we build software? Well, there are actually multiple reasons. First, the architecture will give our project the structure in which we can then write the code. So just like a house, software also needs a structure. Now in software, structure basically means how we organize and divide the code into different modules, classes, and functions. So all these will basically hold our code together and give it structure. The next reason is maintainability. So when we build a project, we always need to think about the future and keep in mind that the project is never really done. It is never finished. We will always need to change things in the future, and we will need to maintain the project. And that only works if the project is nicely structured. Plus, we might even want to add new features to the project, which brings us to expandability. So expandability is basically the ability to easily add new features in the future. And once again, that is only possible with a good structure and a good overall architecture. So the perfect architecture is basically one that allows for all these three aspects of structure, maintainability, and expandability. Now, in order to achieve that perfect architecture, we can of course create our own architecture from scratch. And that's exactly what we did in the Mapty project. However, that only works with a really small project like that one. But when the project grows more complex, then it's going to be very hard to achieve a good architecture completely on our own. And so instead, we can opt for a well-established architecture pattern that developers have been using for years or even for decades. And examples of that are Model View Controller, Model View Presenter, Flux, and many other architectures. And so that is actually what we're going to do in the Forkify project, because it's a bit more complex than the Mapty project. Now, these days, in modern web development, many developers actually use a framework like React, Angular, Vue, or Svelte to take care of the architecture for them. And so in this case, developers don't have to think a lot about architectures on their own. And probably this is actually a good idea at a certain point, especially for large-scale applications. However, and this is key, as I said many times before, it is very important that you really know JavaScript before switching to some of these frameworks. And in my opinion, that includes knowing how to implement an architecture by yourself. And so that's what I will teach you with this project, among many other things, of course. And so this will make it then so much easier for you to learn React or Vue or whatever framework that you choose later down the road. Now, no matter where the architecture comes from and who develops it, there are some components that any architecture must have. And that is business logic, state, an HTTP library, application logic, and presentation logic. So business logic is basically all the code that solves the actual business problem. So that's code that is directly related to what the business does and to what it needs. So if your business is what's up, then your business logic will include sending messages. Now, if your business is a bank, then one of the many parts of business logic will be to store transactions. But if your business is a budget manager, then your business logic will certainly include calculating taxes. So you get the point, right? So essentially, business logic is the logic that is really related to solve the problem that the business set out to solve in the first place. Okay, next is the state, which is one of the most important aspects of any web application. So the application state is essentially what stores all the data about the application that is running in the browser. So the data about the application's front end, basically. So the state should store any data that you might fetch from an API, or data that the user inputs, or what page the user is currently viewing, and so on. And this data should be the so-called single source of truth, which should be kept in sync with the user interface. So that means that if some data changes in the state, then the user interface should reflect that. And the same is true the other way around. So if something changes in the UI, then the state should also change. Now, storing and displaying data and keeping everything in sync is one of the most difficult tasks when building web applications. And that's why there are actually many state management libraries like Redux or MobX. But in this project, we will keep things very simple and use a simple object to store our entire state. Next, the HTTP library is simply responsible for making and receiving AJAX requests. And we have been doing that using the fetch function, and so that's what we will keep doing here. And most real-world applications, of course, need some interaction with the web, and so that's why this is an aspect to keep in mind. Now, about the presentation logic, this is the code that is only concerned about the implementation of the application itself. So it's more the technical aspects of the application which are not directly related to the underlying business problem. So, for example, application logic includes handling of UI events and navigation on the page. That's the reason why this component is many times also called a router. So basically mapping actions to the user's navigation. Finally, the presentation logic, which is also called the UI layer, is of course all about the visible part of the application. So essentially, we can say that the presentation logic is responsible for displaying the application state on the user interface in order to keep everything in sync. All right, now any good architecture has a way of separating all these components. So instead of mixing everything together in one big file and in one big mess. And so let's now take a look at a well-established architecture pattern that we're going to use in this project. And that is the model view controller architecture. So basically, this architecture contains three big parts, which are the model, the view, and the controller. Now, the view is, of course, for the presentation logic, so it's the part of the application interacting with the user. The model is all about the application's data, and so that's why it usually contains the state and also the business logic that manipulates the state. So these two should be kept closely together. Now, the model is also what contains the HTTP library that might get some data from the web. so like from some API or some backend. And so this is of course also about the data, and so it also goes into the model. Finally, the controller is what contains the application logic, and it kind of sits between the model and the view. So it basically creates a bridge between the model and the view, which in fact should know nothing about each other. So again, the model and the view will exist completely independent from one another, and not even knowing that the other one exists, basically. And in fact, one of the big goals of the MVC pattern, so of this model view controller architecture, is to actually separate business logic from application logic, which makes developing the application so much easier. But as a consequence, we then need something to connect these two parts. And so that is the controller. All right. And now let's actually take a look at a typical flow of actions and of data as soon as some event happens on the user interface, for example, like a click. So to start, it's going to be the controller who will handle that event, because handling an event is doing something in the application, and that is clearly part of the application logic. Now, this handling might involve updating the user interface and also ask the model for some data. So we can say that the controller dispatches tasks to model and to the view. Or in other words, it controls and orchestrates this entire action, and in fact, the whole application itself. Now, asking the model for some data might of course involve doing an AJAX request to the web. And so that's exactly what the model does. Then, when the data arrives, the controller takes the data and sends it to the view. And so finally, to finish, the view will render that data to the user interface and finish this whole cycle. Now, in this diagram, you see two types of arrows, right? So the dotted arrows represent data flow between the different parts, while the solid arrows represent actual function calls and module imports. So analyzing this, we can see that it's only the controller who imports and calls functions from the model and from the view, but never the other way around. And so, as I mentioned before, the model and the view are in fact completely standalone and completely isolated. All right? So again, they don't import each other, and they don't even import the controller. And in fact, they don't even know that the controller exists. All they do is to basically just sit there waiting to get some instructions from the controller. Okay? And this part is pretty important to understand, so take some time to really analyze this. Now, there are actually different ways of implementing the MVC pattern, where some are more complex than others, but this one is my favorite way of doing it, because I think it makes the most sense. But anyway, let's now see this MVC architecture applied to the part of the Forkify application that we already implemented. And so this is a flowchart of loading and rendering a recipe that we already implemented. And then down there, there's also a reminder of the MVC diagram that we just analyzed. So in this flowchart, handling these events is associated to the controller, right? Then loading the recipe happens in the model. So the controller basically calls some function that is in the model, and then the model asynchronously gets the recipe data from the API. And once that data has arrived, the controller asks for that data, receives it, sends it to the view, which will then ultimately render the recipe on the screen. And that's it. So that's what every step of the flowchart is associated to in the MVC architecture. But this is still quite abstract, because remember, the flowchart is simply what we will implement, not how we will do that. And so let's go even deeper and actually take a look at a detailed implementation diagram of our MVC architecture. And again, this is only about loading and rendering a recipe. And let's start by noticing how both the model and the controller are implemented in a module, while the recipe view is actually a class. And we will explore the reasons for this when we actually write the code. But now, once again, let's analyze the same data and actions flow, but this time in this real implementation. So when the user clicks on a search result, there is a control recipes function in the controller, and this is the one that will handle this event. And how exactly that happens doesn't matter for now, so we will come back to this later. What matters is that this controller will instruct the recipe view to render a loading spinner while the user interface waits for the data to arrive. In the meantime, the controller also calls the load recipes function in the model to fetch the recipe data from the Forkify API. Now the model also contains a big state object that we export from the model. And this state will contain all sorts of data, like the current recipe, search results, bookmarks, etc. But anyway, as the data arrives, it will be stored in this state object. And the controller then reaches into the state object, grabs the recipe data, and finally calls the render method on the recipe view with that data. So in order to finally render the recipe to the user interface. So basically the exact same steps as before, but this time actually implemented in our code. Well, at least in theory. And so next up, let's actually go from theory to practice and implement this architecture in our code. Welcome back. So now that you know everything about the model view controller architecture and also how it's going to be implemented in our project, let's now actually go do that in practice. And this is going to be a long lecture, so let's get started. And let's start by creating the necessary new files so that we can then split up our code between them. So let's start by closing all of the folders here. And then inside of stores and JavaScript, let's create a new file, which will be called model.js. And so this is basically going to be the module in which we write our entire model. Then we also need the view, or actually the views, because we will have multiple views, basically one for each feature. So now we're working on displaying the recipe, and so this one is going to be called recipe view. But actually, let's create a new folder here for the views in order not to clutter our JavaScript folder. All right, and so then in here, let's create recipe view.js. So we will have one big module here for all the controllers, then one big file for the entire model, so for all the models basically, so for the recipe, for search, for bookmarks, and all of that. But for the views, we will have one module for each of the different views. And you'll understand why that makes sense as we keep developing our application. And probably the first reason that comes to mind is that the views are simply much bigger. And so we don't want a file with like 500 lines of code. We could, of course, also split up the model and the controller, and probably many people would do that, but I don't want to have to mess with a lot of files here in this project. That would just make it very confusing for you to follow. So let's actually take a look again here at this architecture that I showed you in the last video. And here we will actually start with the model. So again, we're going to have a big state object, which then inside will contain an object for recipe, search, and bookmarks. And now we will just start with the recipe, and then there will be a function for loading the recipe, right? So that function will then be called by control recipes, which kind of sits between loading the recipe and then rendering it using the view. So remember that the controller kind of sits between model and the view, so it acts like a bridge. All right, and let's actually keep it open here and close all of these others. And so here in our model, let's simply create that state object. And then in there, we have the recipe, which in turn is also an empty object, at least at the beginning. And then we will export this state so that we can then use it in the controller. And let's put them here just like in the diagram, model, controller, and view. Okay, so we're exporting the state from here. And now let's also create that load recipe function. And of course, we also export it so that we can use it in the controller. So load recipe. And this function will be the one responsible for actually fetching the recipe data from our Forkify API. And so this is going to be an async function. All right. And so now we can actually start grabbing some of the code from here. Okay. So as I said, basically the goal of this lecture is to refactor all the code here into the different parts of the architecture. Okay. So what here exactly is concerned with basically getting the data? So it starts here when we fetch the recipe from the API, and then basically it's all of this here. So all of this. So let's copy it. So rendering the spinner, of course, has nothing to do with the business logic, but really it is only presentation logic. And so this one will eventually go into the view. And then here getting the ID, this is also not business logic. This is actually more about the application logic itself. So about making the application work. And so let's keep that part here. And so again, I will just copy this, or actually cut, and put it here. Now we start getting these errors, but never mind. Probably we should actually terminate our process here with Control-C so that we don't get errors all the time. Okay. Now we need to, of course, adjust this here a little bit. So this first part here makes sense, right? Now we just need to get this ID from anywhere. So right now we have no idea which ID we should actually fetch. And so it's probably a good idea to pass that ID into this function. So the controller is the one that will actually get that ID right here. And so then when it calls the model, so the load recipe function, it can pass that ID into it. Then this part here can all stay the same, and this as well. And this actually should now not be the recipe, but state.recipe. And here we can just create a const from this. And here let's then also log state.recipe. All right. So this function here is not going to return anything. All it will do is to change our state object. So this big state object, which will then contain the recipe, and into which the controller will then grab and take the recipe out of there. And this is going to work because there is a live connection between the exports and the imports. Remember that? So when this state object here is going to get updated by load recipe, then that state is also updated in the controller, which imports the state. So let's now actually import all of that into here. So doing it here at the very top. So import, and then from the model, we simply want to import everything. So we have a couple of named exports here. So Again, there are named exports and default exports, and these ones are named exports because we explicitly gave them a name. And so here we can simply import everything and then call it the model. And so here in the controller, we will then end up with model.state and model.loadRecipe. Remember that? And then here, the current folder model.js. Okay. So let's go back here to loading the recipe, and the spinner should probably be outside of here. And so here, now let's actually call the function. So let's call model.loadRecipe and then pass in the ID. And this loadRecipe function is an async function. And so therefore, it is going to return a promise. Remember? And so therefore, here we have to await that promise before we can move on in the next step here in the execution of this async function. And so you see, this is exactly the situation of one async function calling another async function that we already studied in one of the previous sections. Remember that? And so again, it is really, really important to keep in mind that an async function will return a promise that we then need to handle whenever we call that async function. At least if we want to get some result out of it, or if we kind of want to stop the execution in the function that is calling the other async function. All right. So again, really important to understand the mechanics of what is happening here. Now here we should probably also have some error handling. So I forgot that part. So try on all the way down here and then catch the error and then alert the error as well. All right. So remember that this loadRecipe function here does not return anything. And so therefore, we are not storing any result into any new variable. Instead, here we will get access to state.recipe. So to that state.recipe that is going to be manipulated right here. So you see that this loadRecipe function here clearly is not a pure function. So it has the side effect of manipulating this variable that is outside of it. And there would be different ways of avoiding that, but that is just a lot of work, and it's just not worth it here in this case. We are still trying to learn here, remember. But anyway, we now here have access to model.state.recipe. And so just in order to see if everything still works, let's store that recipe into the recipe variable so that we can then render it using this code that we already have here. So just temporarily recipe and then destructure it. So let's give it a save and let's restart our application here. All right. Let's reload here. And you see that it's working. Right? So everything we implemented so far was correct. And that's pretty important to keep checking when we are refactoring code like this. Okay. So that was actually the easy part. Now comes the recipe view, which will then contain basically all the rest of the code that we have here. So let's go here and set the view up. So the view is going to be a class, and in this case called recipe view. And we do this because later we will also have a parent class called view, which will contain a couple of methods that all the views should inherit. And so using classes makes all of this very simple to implement. Also, we want each view to have a couple of private methods and properties. And so classes makes this really easy to implement again. And just in general, I feel that classes are really the right way to go here. And again, it will make even more sense once we start to add the parent class of Vue. But anyway, I mentioned that I want each of these classes to have a couple of private properties. And one of them is going to be the parent element. So parent element, and let's right away set the parent element to the recipe container. So basically to this element, all right? Because this will then make it really easy to render the spinner and to render success or error messages, or to render, of course, the recipe itself. So if each of the views has this parent element property, then it will be really easy to do all of those tasks. And again, that will become really clear once we start adding more and more views. But now the next thing I want to do is to actually export something from this module. So of course, we have to export something from this view so that the controller can then use it. Now, what are we going to export from this view? So we might export, of course, the entire class like this. And so then here in the controller, we would have to import that class and create a new object out of that class. So basically create a new recipe view object, right? However, in that situation, it might be possible to create more than one view, and we would never want that. Also, that would add unnecessary work to the controller, which we basically want to keep as simple as possible. And so in order to avoid all that, we will already create the object here and then export that object. And so like this, no one from the outside of this class here will have access to anything except for the object. So what we will do is to export default and then a new recipe view. All right, and that's actually it. So we don't pass any data in, and so therefore we don't need any constructor even. Okay, and then here all we do is import, and here we then can give it any name. So I'm calling it recipe view because I think that's what makes most sense. And then views, and then recipe view.js. Now, how do we then actually pass any data into the recipe view? Because if we're not creating the new object ourselves, then we cannot pass any data in, like for the constructor, right? So we cannot pass any data into this recipe view, well, because we're creating that object right here in the recipe view module already. But actually, I did that on purpose so that we can create a very nice method called render. So what I will want to do here, and let me already write it here, even before having the method. So what I will want to do is to call recipe view.render. And then here, all we do is to pass in the data, which will be model.state.recipe. And this method here called render is a very common name for methods. For example, in React, it is also called render. And so I think this is a nice name. It's really descriptive of what is going to happen. All right. So if we did export the entire class, then here we would have to do like const recipe view equal new recipe view or something like that. And then here we would have to pass in the data like this when we create the new recipe. And of course, this would also be possible, but honestly, I like it better like this. So having this nice render method is a lot more descriptive and a lot cleaner, and also for the reasons that I explained previously already. Now, anyway, this render method here will now accept this data and will then store it into the object. So let's add the public render method. So this is, of course, part of the public API. So this receives data and will then set this dot data to the data it just received. So we need to declare that up here. And so this render method here and these two properties are something that all the views are going to have in common. And this will be really beautiful to work with, as you will see. But now let's actually do something with this data, which is to actually render it. So basically what we want now is to take all of this code and cut it from here and put it into our view. Okay. Now we will actually not put it into the render method because again, this method will later be common to all the views. So to all the classes. However, each view will of course render a different HTML. And so we will simply have a method that generates that HTML so that the render method can then render that HTML. So if that sounds confusing, let me write it in code. So generate markup. And so this is going to be a private method. And since we're using Babel here, I can already use this syntax here. So pasting the code here. And so this is going to generate this markup variable, and we can actually immediately return that from here. Okay. Now, this is not going to do anything yet, because what is recipe here in this case? It's nothing, right? It's not defined at all. Now, in this case, where is this data actually? Well, it is in this .data, right? So why is that? So let's take a look at our controller, and let's start from the beginning. So the recipe is loaded here, and then that will store it into the state object, right? Here we don't need that anymore. Then here we take model.state.recipe, which is that data that we just received here in step 1, and then that data is passed into the render method, right? And so render method then takes that data and stores it inside of this .data. And so this is so that we can then use that data all over the place inside of this object. And by the way, this is exactly what we have here in this architecture diagram. So inside of control recipes, the load recipe function is called, then the recipe data goes into the state, and then that data passes right through the controller basically and goes into the render method, which then in turn calls generate markup. So you see, we already have many things here implemented already, like data and parent element. We're just missing some small parts, but we are going to get there. But now what we were doing here is to discuss where this recipe data is actually located right now. And we came to the conclusion that it is in this .data. So I will copy it, and then we need to replace all the recipe dot here with that. So I'm hitting Command D. So for you that should be Control D. And then let me paste that dot, and then that's it. All right. Then down here we have this code, which is not supposed to be here, because all this function does is to return an HTML string. And it's going to be the render method that will be responsible for then actually putting that HTML onto the page. Okay. So here, let's say that the markup is this dot, so generate markup. Well, this is probably something that's coming from Babel here. Not really sure why. But apparently VS Code doesn't like this yet. We're still missing the dot here, of course. And now it appears to be working. And of course, we still get some errors here, but never mind about that. We are still refactoring. So we have our markup. Now we need to put it on the page. So again, we need to start by clearing the parent element. And actually, let's create another small method for that. So just to get in the habit of abstracting some code. And so now this is where our parent element will come into play. Because now we can say this dot parent element dot inner HTML and set it to empty, right? And so this method here will be usable for all the views as long as all the views have a parent element property like this one, right? So all of this will become really reusable, as you will see in one of the future lectures. So here we now can then call that. And then to finish, we can finally render that HTML to the page. And so here, once again, we can now use this dot parent element and then insert that HTML there. Okay, so this might already be working, actually. So all of this here looks good to me. Let's take a look at the controller. And you see that this is now a really nice and small function here already, right? Now this one, we actually want to call it control recipes. So let's replace it everywhere. Control recipes. So that's the name that I have here in the diagram. Okay. And so now what we're missing is only to export the render spinner also into the view. So this one, of course, also has nothing to do with the controller, and so it belongs in the view. So of course not a function, but a method. And this one will also be a public method, so that the controller can then call this method here as it starts fetching the data. Okay? And now here again, we have the beauty of the parent element already being inside of the object. So this one we can simply delete, and here we can replace it with this dot parent element. All right. Next up, I'm seeing that this icons variable is not going to be defined anywhere in this module. So we will need to grab that from here. So you see that here we have the icons, and we don't need them here anymore, at least. So now we need them right here. And now what we need to do is to then call this render spinner method right here. So that's going to be recipe view dot render spinner. And here again, we no longer need to pass in the parent element. And just watch how beautiful this is. So we have recipe view and then render spinner. And we already know that this will then automatically render the spinner on the recipe view. And the same is later going to happen with other views. For example, with the bookmarks view. We will also have a render spinner on the bookmarks view, and it's going to work the exact same way. And the same with render. So all we have to do is to call these same methods then on all the views, and they will then simply act on whatever view that we are calling them. Right? And that works so nice because we have this parent element here and also this data property. So I think that this is a really nice architecture. And so let's now actually see if this works. So let's reload this here. And here we have some errors. So apparently if there is a really big error, then Parcel will let us know about that. And in this case, the problem is that it failed to resolve this URL. And that actually makes sense because this view here is in a different folder, right? So here we are only going one folder up, and going up one folder from here will end up in the JavaScript folder. However, we want to go into images. So we need to go up one more level. So like this. Okay. So here we have apparently some bug. Let's just see if anything happens still on this event. And it does. There's still some problem here. Maybe that has to do with the fact that we are using these private methods here. So let me change this here to this one. So right here, yeah. And let's also comment out this one. And then we're not using any private methods anymore. However, that is apparently still not working. All right, so let's take a look here at our this.data. So this.data, just to see what we get here. And so we see that apparently that method is not even being called. And I see the problem. I actually did not call it. So I didn't use the parentheses, right? So what a stupid mistake. So let's roll back on all the changes I did, except of course for this one. But here, probably all I need to do is to call these two methods. Beautiful. So we're back. It's working now again, and it's working really nice, including the spinner. Okay. And so I think with this, we successfully refactored our entire code to this new architecture. Well, not the entire code, actually. We're still missing this handler here and all of this part that is here, but don't worry about that for now. Okay, we will have a separate lecture which will talk about how we can handle events in this particular architecture. For now, what matters is that this works just nicely. There's just one thing that I actually want to change, but that has nothing to do with the architecture. So what I want to change is these numbers. So do you see here we have 0.5, but in the real world, you will see this more like this. So like 1/2 tablespoon of brown sugar instead of 0.5. So this looks a lot nicer, or this, for example, 1.5 is a lot nicer than 1.5. And so for that, we are actually going to use an external library which will very easily do this for us. Okay? And so I included this part so I could show you just how to do this. So let me just Google it here, npm fractional, just so we can see what this package looks like. So if you Google npm, then you will usually end up on npmjs.com, and this will then contain like one page for each package that is on npm. All right. And so here what you see is that you can basically create new fractions based on numbers, and then you can do all kinds of multiplications with them, like multiplying, dividing, and in the end converting them to a string. And so that's what we will do now. So we will convert each number to a fraction and then immediately convert them to a string. So this is how we install it. Let's just grab that. And then we need our terminal back. Let's add another one. So that's the plus sign. And this should be pretty fast, hopefully. And so we need that here. So let's import fractional from, and then fractional. And so here again, you see that any libraries or any packages that we import from npm, we don't even have to specify any path. All we have to do is to write their names here. And then here we need also what they export. And let me see what they actually export. So it should be called fraction. Okay, so this library actually exports something called fraction. And we can see that because here it is importing the fractional library using require. And that is simply the old CommonJS way of importing, which I showed you earlier. And so that is one of the reasons why I showed that to you, because, yeah, again, you will see this all the time in the wild still, because so many packages on npm are still using CommonJS. So let's import fraction here, actually like this. Okay, let's just see if this actually does exist now. And yeah, it does. So actually that's even fraction inside of fraction. But anyway, let's now go ahead and use this actually. So that is in here. So here we now no longer simply want the quantity, but we want the quantity converted to a fraction string. So according to the documentation, we have to say new fraction, and in this case, it's actually fraction dot fraction. So again, that's because here inside of fraction is where the fraction function is actually located. Okay, and here you could see that we have to then use new. Now, actually, to make this a bit nicer, we can also use destructuring here right away. So we can do this. And if we now take a look, well, now we have this bug here, but never mind. So let's just do this and then call toString on that, just like it said in the documentation. So you see that now as I destructured that fraction, it became the actual function. And yeah, here you see beautifully that it is now in this size or in this format of the fraction. And if I take a look at the other one, then the same as well. Now, this one doesn't look very beautiful, but never mind. So we cannot fix all of it, but at least this looks really cool now, right? And so this is when we reach for packages on npm. So when we need some functionality that we don't want to implement ourselves. I'm just going back here because I noticed some problem here, which was this one. And that was because previously here we had null. So there was no value for this cilantro. And so here we should probably check if the number does exist. So we can say inc.quantity. If it exists, then do this. And if not, then simply put an empty string there. And of course not here. So that must be out here. Yep, now it's gone and it looks a lot nicer. All right. Now just to finish, I actually want to refactor this function here. So let me grab this and put it down here and call it generate markup ingredients, or just ingredient. Okay, and this will then receive the ingredient. Okay, and then here inside of the map, we can then simply call this dot, and let's copy it because these private methods, for some reason, VS Code doesn't really understand them yet. So right here. And so successfully refactored this part. And so we are now done in this lecture where we also successfully refactored the entire code that we already had to the model view controller architecture. All right, so we're not done 100%, but we've done a lot of work in this lecture, and I really hope that you understood everything that we did here. So this was a really, really, really important lecture, so make sure that you understand everything that we did. So make sure to review all the code and also compare it here with this diagram one more time so that you see which functions we call when, and then also how exactly the data flows between these different functions, and especially here in this view, because I know that this can get a little bit confusing. And so reviewing this is going to be a very good idea, especially because we will use this so many times also in the other features. And so by then you really must understand how all of this fits together, because otherwise it's going to be very hard to follow the rest of the project. Okay, so take your time and only then move on to the next video. Many real-world applications have two special modules that are completely independent of the rest of the architecture. And these are a module for the project configuration and also a module for some general helper functions that are going to be useful across the entire project. And so let's now implement these modules in our own project. And let's start with the configuration module. So let's maybe close this one here first. And then in our JS folder, we create a new file, config.js. Okay. And so here into this file, we will basically put all the variables that should be constants and should be reused across the project. And the goal of having this file with all these variables is that it will allow us to easily configure our project by simply changing some of the data that is here in this configuration file. So therefore the name of config. So of course, we will not want to put all the variables here in this file. The only variables that we do want here are the ones that are responsible for kind of defining some important data about the application itself. So one example of that is, for example, the API URL. All right, so this URL here, we will actually reuse in multiple places across this project. For example, for getting search data and also for uploading a recipe to the server. And so all of them will use this URL. But then imagine that at some point the URL needs to change. For example, because there might be a version 3 at some point. And so as always, we don't want to change that everywhere and simply have a variable which contains this, which we can then reuse. So let's cut this here. And you might argue that we can also simply create a variable here in the model, but then we would have all these configuration variables spread across multiple modules. But it's way easier to simply have all of those variables in one central place. And so that's what we're going to do here. So let's call this one API URL, and then paste that here. Okay, and now all we have to do is to export this constant from here. So I'm using uppercase here because this is basically a constant that will never change. And so using uppercase for that kind of variable is kind of a common practice, especially in a configuration file like this. So API URL is one of the variables that makes a lot of sense. And let's actually go to our documentation page, because indeed, as I mentioned before, we are going to use this URL for this and also for getting recipes. So then we will simply have to add the /id. Another great candidate for being a configuration variable is going to be this API key that we will generate a bit later. So let's leave that for now and go back here to this API URL and now actually import that here into the model. So import, and now remember that here we have a named import. And later we will actually also have more named imports. Okay, and so here I could go ahead and import all of them basically at the same time and then as config. But actually I prefer to import them one by one, basically with their actual name. And so remember, we do that by using curly braces and then the name of the variable like this. And then config is in the same folder. And so that should work. And here, all we have to do now is to replace, or to actually put, that API URL right here. So if we save this now, then our application, well, let's see. And yeah, it is back to working, right? And so we successfully basically exported this configuration value that we had here into this config file. Okay, next up, let's create a new file for some helper functions. So this one is usually called helpers.js, and the goal of this file or of this module is to contain a couple of functions that we reuse over and over in our project. And so here in this module, we then have a central place for all of them, basically. And to start, one great candidate is to actually create a function which will get JSON. So basically a function which encapsulates all of this and also some of the error handling. All right, so let's actually get all of this code and go here into the helpers. And so here let's create a function and export it called getJSON. And so this function is going to be very similar to what we did in the Async JavaScript section. So it's going to be an async function which will basically do the fetching and also converting to JSON all in one step. And so with this, we abstract all this functionality into one nice function that we can then use all over our project. And probably we will just use this actually in our model in this case, but it's still good to have this function in this kind of central place. Okay, so anyway, this getJSON function will take a URL, and so of course this is then what we fetch here. Right, and so with this we can then reuse this function here for all kinds of URLs. Now this here actually already makes sense, and this one here as well. So let's now put all of this into a try block and then catch the error here. Now, what are we going to do with the error here? Of course, we could log it or alert it as always to the console, but let's say we actually want to handle that error here in this function. So right here, where we will actually use the getJSON method. And actually, let's do that right away. So import that first, of course. So import, and again, we are using named imports, and I simply want to import the exact variable name. So that's getJSON from helpers, and it's not appearing here, and I just noticed that helpers is actually in the wrong folder. So I put it in the views folder, but it's supposed to be in the JS folder. Okay, and so let's now actually use getJSON here and then think about the error handling that we were just talking about previously. So here let's say const data will be await getJSON, and then with this same URL here. Okay, and so again, this is exactly what we had done before. There's just one thing missing here. Now we get these errors which is really annoying. But anyway, there's actually still something missing here, which is to then actually return the data from this function, right? So we didn't do that yet. And so of course we want to return the data. And now, just as we did also in the last video, we have one async function here. So the load recipe function calling another async function, which is this getJSON function. Now this function returns this data variable, and so therefore this data is going to be the resolved value of the promise that the getJSON function returns. And if that still sounds super confusing, then you might just revisit that lecture in the asynchronous JavaScript section. But anyway, what you need to keep in mind is that here this data will become the resolved value of this promise. And so here, that's why we then await that promise and store that resolved value into the data variable. And so then the rest here is going to work in the same way. But now back to error handling. And let's say here we want to actually not alert, but to log that error to the console. Let's say console.error. And then here the error. And let's say we want to do it in a special way, just so we see which errors are our own. So using some emoji here to make it really visible. So this is here our temporary error handling, which we will improve dramatically in one of the next lectures. But anyway, the point that I'm trying to make is that the error is actually occurring here, right? It is going to occur in the getJSON function and not here. Remember that? So when there's going to be an error here in this function, then the promise that the getJSON function returns is actually still being fulfilled. So it's still basically a successful promise, even if there happened an error here. And so let me show that to you actually. So now everything works just fine. But let's now use some invalid URL here. Then we get some error here, but that's not the one we are interested in. So the actual error is this one here, and it's coming now from helpers.js at line 5, or actually line 11. So this is the error that we're logging right here. So this one here, right? So we're logging it to the console here, right in the helpers function. However, this is actually not where we want to handle that error. We really would like to handle it right here in model.js. So basically, instead of this error message here, which is simply a consequence of this first error, we would like to get this error message inside of the model, right? So do you remember how we do that? Well, we have to rethrow the error. So we have to again use throw and then simply take the error object that we already have and simply throw this new error. And so now with this, the promise that's being returned from getJSON will actually reject. Okay, and so then we will be able to actually handle the error right here. So let's try that again. And indeed, now we get that same error message that we had before right here in the model as we wanted. Okay, so we basically propagated the error down from one async function to the other by rethrowing the error here in this catch block. And that's really important to do, and we will actually come back to this in one of the future lectures. Okay, and now to finish, let's make this function here a little bit more robust and more real world by adding some timeout. So basically setting a time after which we make the request fail. And so this is important in order to prevent for really bad internet connections where then this fetch here could be running forever. And we actually already did that previously in the async JavaScript section. And so here in the controller starter code, I had already this timeout function, so we don't have to code it all over again. And so let's put that here. And so basically what this function does is that it will return a new promise. So this promise here, which will reject after a certain number of seconds. And so in order to now use this function here, we will have a race between this timeout promise, which will take whatever seconds we pass into it, and this fetch function here, which is the one responsible for getting the data. And then whatever occurs first will win the race. So let me just put that in code actually. So remember that works by using promise.race, and this takes in two promises. So the first promise is this one, and then the second promise will be timeout with a certain number of seconds. And here for now, let's just say 10 seconds. Or actually, let's just say 0.5 seconds so that we can actually test this. So here we're still getting some errors from somewhere in our code because of this error. But never mind. Oh, and now Google Chrome crashed. And here we are back. So let's just again click somewhere here. Now we still get this weird error. So let's actually check out what's happening here with cannot read property JSON of undefined. Well, maybe it's already because of this timeout here. So let's try to put it to like 5 seconds. Let's try it again. But it's got to be something else. So it seems like there is some problem somewhere here. So here for some reason is this parenthesis, which doesn't make any sense. But it is VS Code which for some reason puts it there for us. But this parenthesis doesn't make any sense because now this looks like just one element of this array. So let's just create this promise outside. So fetch promise is going to be this. And so hopefully that will fix it. Well, it doesn't. Oh, but I see what's the problem. I'm actually not even calling promise.race. I only put the brackets there. So that was probably the reason. And so now it should work indeed. And so if we reload this, then yeah, it works. So now we can actually test what's happening here with the time. So setting it to half a second. And so that still works. And so let's make our network a little bit slower. So a slow 3G. And this should then take some time. And so let's see if we can now time out the request. So let's wait for it. And indeed, now the request took too long, timeout after half a second. Okay, so let's analyze what happened here. So we passed in half a second here, and so after that time has passed, this promise simply rejected with this error message. And so as soon as any of these promises here in the race rejects or fulfills, then that promise will become the winner. And so therefore, we now have a rejected promise here, which will then trigger the catch block here. And so that error will then be thrown again here, and then it will make its way here into the load recipe function, and eventually will be handled down here. And so that's why we get these 4 explosions down here in the error message. All right. Now, of course, then in the real world, we will want to do something with that error. But again, a bit more on actual error handling a bit later in the section. For now, let's set a more realistic value here. So of course, we don't want to time out after just half a second. Let's say like 10 seconds. Now, in fact, this is one of these so-called magic numbers or magic values, which is like a value that seems to appear out of nowhere. So if someone reads this code, they will find this number 10 and not really understand what it's doing. And so one more time, this is a perfect candidate for a configuration value. So this is really something that we might want to change about our application. And so then if we want to do that, all we have to do is to come to our config file and change that here. So let's call this one timeout seconds and set it to 10. Okay. Then here we can import that. So again is a named import. And so here we use the curly braces. So timeout seconds from helpers.js. And this import that is already here was probably put here by a parcel. So I don't remember doing this here. And so it must have been parcel who put this here in order to make the code work. Okay. And so now here we can use the timeout second constant. And so now whoever is going to read this code will see that this is one of the configuration values. So first, because it is in this uppercase, and so that helps already with understanding the code. And then also because now it is a variable. And so it's no longer like a magic number that we don't really understand where it's coming from. Okay. And so that's exactly what this configuration file here is all about. So these are two important files that are used in many applications in the real world. And so make sure to also include them in some way in your own applications in the future. Okay? And now in the next video, we will kind of finish this architecture and really implement the missing part here, which is kind of handling the events in a better way. And so let's go do that right now. So let's now learn how we can listen for events and also handle events in our MVC architecture by using something called the publisher-subscriber pattern. And let's start by analyzing the code that we already have here. So right now we are listening for the hash change and for the load events right here in the controller. However, that doesn't make a lot of sense, does it? Because everything that is related to the DOM, so to the view, should really be inside of a view. Now, maybe these two events here don't really look as if they have to do with the view, so with the user interface, but imagine that instead we would be handling a click event on some DOM element. And so listening for that event should for sure go into the view. And therefore we can say the same about these events here. So in the end, this has more to do with DOM manipulation or with the DOM itself than actually with the controller. And so therefore we need a way of putting this logic here into the recipe view. However, the handler function that we use to handle these events is actually this controller. So it's this function that we have up here that is sitting inside of this controller module. And so we have basically a problem here. We don't want this code to be here, so we want it to be in the view. But in this code, we need this controller function, which is here in this module. And of course, we don't want to put this function in the view. And so let's now think about how we could solve this problem. And recapping everything that I just said before, we can basically say that we want to handle events in the controller because otherwise we would have application logic in the view. And of course, we don't want that. But on the other hand, we want to listen for events in the view because otherwise we would need DOM elements in a controller. And we would basically have presentation logic in a controller, which would be wrong in our MVC implementation. So essentially, event listeners should be attached to DOM elements in the view, but the events should then be handled by controller functions that live in the controller module. And so if you take a look at this small diagram that is just a part of the architecture diagram that we already saw before, so here we have the control recipes function in the controller, and we have a special method in the view which is called addHandlerRender. Now we might think that it is very easy to connect these two functions, because why not simply call the control recipes function right from the view whenever an event occurs? Well, that's actually not possible because in the way we set up the architecture, the view does not know anything about the controller. So it doesn't import the controller, and so we can't call any of the functions that are in the controller from the view. So it only works the other way around, and therefore it's more complex than this. But fortunately, there is a good solution. And this solution is called the publisher-subscriber design pattern. And by the way, design patterns in programming are basically just standard solutions to certain kinds of problems. So in the publisher-subscriber pattern, we have a publisher, which is some code that knows when to react. And in this case, that's going to be the addHandlerRender function because it will contain the addEventListener method. And therefore, it will know when to react to the event. Now, on the other hand, we have a subscriber, which is code that actually wants to react. So this is the code that should actually be executed when the event happens. And in this case, that is the control recipes function that we already have in our controller. And remember that the publisher does not know yet that the subscriber even exists, because that subscriber is in the controller that the view cannot access. Okay, but now finally comes the solution to the problem. So the solution is that we can now subscribe to the publisher by passing in the subscriber function as an argument. Now in practice, that means that as soon as the program loads, the init function is called, which in turn immediately calls the addHandlerRender function from the view. And that is possible, remember, because the controller does in fact import both the view and the model, right? Now anyway, as we call addHandlerRender, we pass in our control recipes function as an argument. So essentially, we subscribe control recipes to addHandlerRender. And so at this point, the two functions are basically finally connected. And so now addHandlerRender listens for events using the addEventListener method as always. And then as soon as the event actually happens, the control recipes function will be called as the callback function of addEventListener. Or, in other words, as soon as the publisher publishes an event, the subscriber will get called. Alright, and this is how we implement event listeners and event handlers in the MVC architecture. So this will allow us to keep the handler in the controller and the listener in the view. And by that, keeping everything nicely separated. So in summary, the handler subscribes to the publisher, which is the listener in this case, and then as the publisher publishes an event, the subscriber is executed. And if you want to think even deeper about this and are really interested in this, then notice how there is actually a profound difference between a certain arbitrary, like function A, simply calling function B directly, and function A receiving function B as an input in order to then call that input function. So this is all about control. In the first scenario, function A is in control. However, in the second scenario, function A has no control. So it simply has to execute whatever function it receives. So if you want, reflect a little bit on that and see that this is exactly what the publisher-subscriber pattern is actually all about. But anyway, leaving that theory aside now, let's go back to our code and implement all of this. And so with everything we just learned about the publisher-subscriber pattern, actually now implementing it should be the easiest part, right? So let's simply grab this code, so cutting it actually, and then here we will create a new method, and let's just put it somewhere, let's say here. And so this will be our add handler render method that we just talked about. So add handler render, because this is going to be for rendering the recipe right at the beginning, right? And then this method, which remember is the publisher, basically needs to get access to the subscriber. And so that in this case is the handler function. All right. And so then we can simply paste that in here. And then here, of course, we don't know about control recipes, but we know about the handler. And so that's actually it for this function. So of course, it is not a private method because it needs to be part of the public API of this object so that we can then call it in the controller, right? And so let's actually do that now. So we can get rid of this now, and we will want to do this right in the beginning. So let's create an init function here, actually like this. And then we simply call it right at the beginning. So only once. And actually we could simply put all the code also here in the global scope, but I think it's a bit cleaner to have a separate function for this. That's recipe view dot add handler render. And so now we simply pass in control recipes. And that's actually it. With this, we just implemented the publisher-subscriber pattern. For some reason, we're still getting these errors here. Let's get rid of this alert here, actually, and simply do a console.log here. Okay, but now let's go and see if this actually works. We're still having our slow network. Oh, and here we have some problem, apparently, with the timeout. So let's go quickly fix that here in the helpers. So we saw that here it said undefined, like after undefined second. So maybe this variable here doesn't exist. So maybe it's kind of misspelled. So let's see in the config. Well, it looks right. Yeah, it is the same. Well, let's see again. And so this apparently happens immediately for some reason here. So what if we put it back to some normal number? Well, then it works, which is very weird because this is in fact also 10. So let's see what we get here as we log timeout seconds. Oh, but I'm actually right now seeing the problem. So this is not helpers, it is config. So we are importing ourselves here. So that was the problem. Let's put everything back. And you see that now it is working. Even with the hashchange event. And so that means that we did now successfully implement the publisher-subscriber pattern. Okay, and so let's quickly recap what exactly is happening here. So we can also take a look at our final diagram here. And here I actually have the event here in the controller, because that is actually where it is handled. And so I think that in this diagram, this makes it a little bit easier to actually understand the flow of the program. So anyway, as we start the program, so then the init function runs, and it will then immediately run add handler render, right? So it is this function here. And it's this function that is actually listening for events right here in the view where it actually makes sense. Now, as we call this method here, so in the controller, we pass in the controller function or the handler function that we want to get executed as soon as the event happens, right? And here we then receive that function as being called handler. And so that's what we then call as soon as the event happens, right? And so again, in our diagram, that's exactly what we have here. So that's why I have this dotted line here, which stands for data flow. So we are passing in the control recipe function as the handler here. And that is the whole reason why the method here is called addHandlerRender. So because we are using it to in fact add a handler function, and in this case, it is for rendering the recipe in the first place. And then later on, we will actually have other addHandler methods. Okay, and so it's crucial that you understand this logic here before you can move on any further in this project. But I hope that with all this explanation, this became all really clear and also obvious why we had to do it like this. I mean, of course, we don't really have to do it. So we are, of course, in charge of our own code. But in order to correctly implement the MVC architecture, this is the best way of doing it. And so again, then we can keep everything nicely separated into model, controller, and view without any overlapping responsibilities. All right, so we have all of this structure here now nicely set up. Everything is nicely separated. And so from now on, all we have to do is to basically use this structure to implement all of the missing features of our application. And so, again, really make sure that you understand everything that we did so far, especially regarding the implementation of our architecture. And then, once you are really done with understanding that, let's go straight to the next video. Let's now implement real-world error handling in our application instead of always simply logging errors to the console. And again, the error that we're going to work with is basically using a false ID that cannot be found on the server. So indeed, we get our error message invalid ID, and then the ID itself, plus the status code. Now, the real-world way of handling an error like this is to actually display some message here in the user interface so that the user can actually know what's going on. So basically, handling the error will mean to display an error message here in the view. So right now, we are handling the error actually in the model, right? So remember how I said that for now, handling the error is simply logging it here with these small emoji here. And so again, that's basically our current error handling strategy. However, it is not correct. And also, it doesn't happen in the correct place. Because if we want to display something in the view, then of course that code should also be in the view and not in the model. So let's go back to our code and to our view and implement a new method here, which is going to be responsible for displaying that error message. And actually, the HTML code is already here in this like template. So it's going to be this class here, or this element with the class of error. So let's copy this, go to the view, and then let's put it here after the spinner. So render error, and then like this. And for some reason here I declared like a normal function, which doesn't make a lot of sense. And now let's create a new markup variable as always when we create, well, some new markup, which is exactly what we're doing here. Then here, remember, we need to replace this with the icons variable. And then here, of course, we want to have like some custom message. So we don't simply want this hard-coded message, but instead we want to be able to pass a message into this method. So that's going to be message like this. And so let's add a parameter here for that. Okay. And then here, let's clear the parent element. So like this. And actually, we should do the same here. So this dot clear is a lot nicer than having to write all of this. And so we abstracted all that away into this method. And now we can basically simply get this code because it's going to be the same, right? The variable here is still called markup, and we still want to basically insert this HTML into the parent element. So that's, again, this element with the recipe class. Okay, and so that's actually it here for the view, at least. Okay, so let's now go to the model, because remember that right now we are actually handling the error right here, like this. But again, that's not what we want. So we want a way of getting this error into the view. Now, these two are only connected by the controller. And so, of course, it is going to be the controller who will call recipe view, right? So let's do that actually. So that's going to be right here in the catch block of the control recipes controller. So recipe view dot render error and then some message. But what is this message going to look like? Or in other words, where are we going to get it from? Because now we have the same problem as before. So remember, here in the helpers function, whenever we got this error, then that error was not automatically propagated down to this async function, which was actually calling the getJSON function. And so therefore, we had to rethrow the error here. So basically to mark this whole promise here as rejected, so that then here we would get into this catch block. But now, here again, we have the same problem, because now if we get an error here, then this promise, so this whole load recipe promise will also not get rejected. And so therefore, here we will never enter the catch block in this function. So it's a bit confusing, like the flow of the error and how we need to propagate it down. But essentially, we will have to do the same thing as before, which is to throw the error here again. And so with this, we will then have access to the exact same error object as we have here, and otherwise we wouldn't. So now we can use the same thing here. Let's actually get rid of this console.log. And so now here our error handling is basically finally complete. So instead of simply logging it to the console, we now have a way of rendering it to the user interface. And we will be able to access the exact same error that we also got access to here in the load recipe function. Okay, so let's try this. And indeed, here we get the error message, and it is exactly the same one that is logged down here from the model. Okay, however, this is actually not really that useful. So, well, this error is not really meaningful for anyone using this application. And so actually, this is not the message that we want. So let's create a more meaningful message. So something like, we couldn't find that recipe. Now, do you think that we should pass in that message here? So basically specifying we couldn't or we could not find that recipe. Please try another one. So again, do you think that this is the correct place of specifying this message, which will get eventually rendered to the view? Well, actually, I think that it is not. So I think that this error message should basically be an intrinsic property of the view itself. So basically, I'm going to cut this from here now. And now in the view, I will add just another private field. So it's going to be called error message, and then the message itself. And so now, basically, the view itself already knows the message that it wants to display. Okay? And then here, in render error, we will actually keep the ability of passing in a message. But if no message is passed in, then we will simply set a default. And so that default is going to be the error message that we just specified. Okay? So here we don't pass anything now. And so by doing this, we are back to having no code that is regarded to the view here in our controller. All right. And so instead, the error message is then by default set to the message, or actually the other way around. So the message argument is going to be set by default to this error message that we set for this entire object. So I think that is the best solution, which makes the most sense. And so indeed, here we now get exactly that message. And so with this, we now have a very robust and very nice error handling strategy that we will then be able to use for other errors also in the future. So for example, when there are no search results for some search term. Okay. Now, since we did an error message here, let's very quickly also implement a method here for success messages, even though we don't need it yet. But it's still good to already prepare for that in the future. And so since we are working on messages here, let's do that right away. So let's call this one simply render message. And this one here will have a different class. I think it should also be somewhere here. And actually it's this default. So this is actually the one that we will use. So it has the class of message, but then the rest of the code is actually the same. So message, and actually not the same. So the icon is also different. So here it's icon smile. So instead of the alert, it is a smile. And then here we will want some kind of message again. And so here let's now create simply yet another field called message. Could also call it like success message, but let's leave it like this. And for now, we don't have any success message because again, we're not actually going to use this for now. But message, and then the rest should essentially be the same. And then in the future, of course, we will be able to use the success message in some different places in our application. All right, and that's actually it. Let's put it back to some normal URL. We can just click here. And then, of course, everything is back to working. Great. And with this, we are actually finally ready to implement now the searching functionality starting in the next lecture. Let's now start implementing the next feature of our application, which is going to be the search functionality. And let's start by taking a look at our flowchart here. And so again, we already have this part here basically now implemented. And now we are going to work basically first on this part, so handling the event of a user searching for recipes, then loading the search results and rendering them. So that's going to be this lecture and the next one. And then afterwards, we are going to worry about the pagination. So again, we will now focus on these three parts. And so for that, we need to now implement the model, the view, and the controller that binds everything together. And usually I find it easiest to start with the data. So basically with the model, which means in this case, starting to make some API calls in order to load some search results. And then once we have that part working, we can then render them on the screen and also care about the actual event. Okay, so let's actually leave that open here at the end and go to our model here and start implementing the search functionality. So, just like before, we are going to create a function that will be exported so that it can be used by the controller. And this one, I'm going to call it load search results. And so since this one will be performing AJAX calls, it's going to be an async function. Now, again, this function here is going to be called by the controller. And so it's going to be the controller who will tell this function what it should actually search for. So basically, it will pass in a query like string, which we can then plug into our API call. All right. And here we are going to need a try catch block. And here in the catch block, all we will do is to basically do the same as here. So all we're really interested in here is to throw the error again so that eventually we will be able to use it in the controller. So just like before in the last lecture where we threw the error here again. So that part is easy, but now let's actually implement the functionality. And to do that, let's go back to our documentations page. And so this is how we get all recipes. So making a get request to this path, and then with the search parameter. And the way we add a parameter, and I think I explained this before, is with the question mark, and then search equal, and then pizza here in our case is actually the search query. And again, for now, don't worry about the key. And we can actually already see what the results will look like here for pizza. And so basically, this is the URL that we need to call in our AJAX request. So let me actually copy it. And let's go back. And so now we can, just like before, use the getJSON method. And so that will then fetch the data and also convert it to JSON and create an error if something went wrong. So getJSON returns a promise, and so we await that here and store it into data, just like always. So getJSON, and then the URL, and we need a template literal. And so, yeah, now we just have to replace everything to make this work. And the first thing is to actually take this here again out and replace it with this API URL that we already have in our configuration file, right? So API URL, and I think that actually already includes the recipes. Yep, so it's everything. And usually, actually a URL ends with a slash. So it should be like this. And so here, let's take that out, actually, and then here as well. Then here, question mark search, and then this one is going to be our query. All right, and so we can then already log that data to the console to take a look at it before we then manipulate it a little bit. And so right now, this should already be working. And so let's before we actually write any controller or any view, we can already call that function here. So load search results. And then let's try it, as always, with pizza and see what we get. So that's right here. And indeed, this is the result that we get here. So it's coming from model at line 35. So that's where we were. And so here is the data that we get back. So we have an object which has a data property, which then has a recipes property, which is this array. And then each array contains all of this data about each of the recipes. So again, this object here is called data. Then in there is data again. And then in there is recipes, which is then the array itself, where each of the elements is an object with only some of the data about the recipe. So you see, it's not the complete recipe object. It's only some of the data so that we can actually display it then here in the search results. So without the unnecessary data like ingredients and all that. All right, so let's now take this data and store it into our state. And also we will want to change again this one here, so to image only. And so we will basically create some new objects based on this data that we receive here. All right, so we get data.data.recipes. So this is the array. So this is the array of all the objects. And now we want to create a new array which contains the new objects where the property names are different. So let's map over this. And each element is going to be a recipe. And then here we will simply return a new object. Let's actually copy the code from here because they are the same, at least some of them. So taking all this, and here now this is only called a rec. Okay, and also we don't have the source URL. We only have ID, title, publisher, and image URL. Okay, so this will return a new array with the new objects. And so now where should we store that? Well, as you can guess, we will put it also in our state. So again, the state contains all the data that we need in order to build our application. So let's call this one search. And all the data about the application that I just mentioned might as well also include the search query itself. So let's create a new object here and then specify the query, which we start as an empty string, and then the results, let's say. Results will start as an empty array. So basically the state should contain all the data really about the application. Now in this case, we might not even need the query for now, but it's still a good idea to already store it here in the state. Because maybe one day we will need it, and then the data is already there for us. For example, we might want to add some analytics in the future to know which queries are made the most. And so by then, yeah, as I said, that would become useful. Okay. But anyway, let's now store this data in state.search.results, right? And here at the beginning, the very first thing that we're going to do is to state.search.query equal to query. All right. And now let's quickly, just to see if everything worked, log that to the console. So state.search.results. And here we are. So that is exactly the kind of array that we had before. And now the image URL we had before is indeed called image. and so everything has the same format as before. So we needed to do that because here the image is also called image, and of course we want everything to have the same names throughout the entire application. All right, so let's get rid of this, because of course we want to call this function in the controller. And so let's go there to the controller and basically create a new function, which is going to be like the new controller. So const control search results. And so this one will call the asynchronous function load search results. And so this one, of course, then also need to be an asynchronous function itself. And so, as always, try catch. And here for now, let's simply log the error, and we will then fix that later. So here is where we actually will want to call the load search results that we just built. So that is in model.load search results. And here we then will need to pass in the query, but for now let's just do that again manually. And of course we need to await this, but we do not store any result anywhere, because just like the load recipe function, this one also doesn't return anything. All it does is to manipulate the state. And so then we should be able to do this console.log in the controller and still get access to the results, right? So let's see. Now, of course, we first have to also call this function. And again, later we will, of course, hook this up to an event listener. But here, let's just call it right away. And now we get state is not defined. All right. And that is because, of course, it needs to be model.state.search.results. So you see that this is becoming a pretty long chain here. But never mind, that's not a problem at all, because we know exactly what all of this is. And so now indeed we get back our 59 search results for pizza. But now, instead of only searching for pizza, we actually want to get the query right here from this input field, right? And we also want to start this whole process of loading the search results. So we only want that to happen when this button here is clicked. And so now let's basically create a view only for this search part here. So right here, we will have a view for this here, so for the search field and for the button, and then a different view which will actually render the results. So it's a good idea to keep every view really focused. And so it's best to just do one for this part and then one for displaying the results. Also because in the user interface, they're actually in kind of different places also. So it makes sense to have a different view. Now this view here is of course not going to render anything, but what it will do is to basically give us the content of this input field. So getting that input data is of course something that has to do with a DOM. And so it should be in a view and not in a controller, right? So of course, if we wanted to be lazy, we could go ahead and select the element that we want. So it doesn't matter. And then from there, we would simply get the value and then use that as our query. So again, we could do that here, but this is clearly about the DOM. And so in order to follow our architecture, we will create a new view right now. And this one is going to be called the search view.js. And just like before, here we will create a class called search view. And we will then not export that class, but export an instance, so an object that was created by this class. So export default new search view, and without passing in any data. Then, just like before, we will have a parent element. So just like in the recipe view, so a parent element, and then we will set that to something, query selector. And now let's see what we get here in the DOM, so in the HTML. So the search, it's this one. So we have this entire form, which is called search, and which has this input field here, and also the button. And so I think that this is the element that makes sense to select. So the one with the class of search. So dot search. So this is our parent element here in this case. Now, again, this class is not going to render anything. All we want is to get the query and eventually to also listen for the click event on the button. But let's start with the query here. And so let's create a method that we will then call from the controller called getQuery. And all this will do is to return this dot parent element. And so again, that's going to be the search. And then from there, we want to select this input field. So this one with this class. And so let's select this child element using query selector. And then simply get the value of that. Okay, and that's actually it. And again, of course, we could have written this exact same code in a controller, but that wouldn't make any sense because this is not concerned about the DOM at all. So we don't want to have any DOM elements in here. We don't even want to know what the DOM looks like. So actually here we have this, but we don't want this here. Let's get rid of all this clutter here actually. And now I want to get the search view here. And then here we can get that query by saying search view dot get query. And of course, there might be no query. And so let's add another guard clause here. So if there is no query, then return immediately. And so here we will now no longer look for pizza, but for query. Now, if we run this, then of course there will be no result because, well, right now there is nothing here to be found. So that controller function runs right in the beginning when the application actually loads. And so by then, of course, there is no value here. And so in order to actually make this work, we now need to listen for the event of basically clicking this button or submitting this form. And then only on that event, we want to actually call this controller function here. So not in the beginning when the script loads. So in order to do that, we will once again use the publisher subscriber pattern. So basically exactly what we did here, right? So we will listen for the event in the view right here, and then pass the controller function, so the handler function, into the method that we will build here. So this add handler search method here is basically going to be the publisher, and the control search results function is going to be the subscriber. Okay, so hopefully you really understood that pattern that we used before, and so this now should be obvious. So let's take our parent element, so this dot parent element of course, and then this is where we will actually add the event listener. So not to the button, but really to the entire form, because there we can listen for the submit event. And so then this will work no matter if the user clicks the submit button or if the user hits enter while typing the query. Now here we cannot simply call the handler immediately, because remember as we did many times before, when we submit a form, we need to first prevent the default action, because otherwise the page is going to reload. So prevent default, and only after that we can call the handler function. And as you already know, this handler function should be the control search results function. And so all we have to do now is to call this method and pass in that function. So let's do that here right at the beginning. So search view dot add handler search. So you see that I'm always going to use this name here of add handler. And then we pass in the controller function. And that's it. So now it should actually already work. So let's see, and actually let's clear up all this clutter here a little bit. Okay, so this console.log, and there's also some here in the recipe view. So that's this one. Okay, so let's again try pizza. And yeah, beautiful, it worked. So we get this data first here coming from the model, and then also in the controller we also logged it. And so here we have the exact same 59 data that we had before. Let's try something else now. Avocado, let's say. So I hit enter, and so this time we got 39 search results. And you see all of them basically have avocado right there in the title. It's really beautiful that it already works this great. Now just one small detail is that after we search, we should probably clear out this field. So let's add another small method for that in the view. So in this one here, so clear input, and once again, having it nicely encapsulated inside of the search view. So again, this could simply be also in a controller because it's really just one line of code, but we want to keep everything separated. This will make it so much easier to add features in the future, and it's really so much better. So all we do is to set this to empty, and that's it. All right, let's try it one more time. Let's say pasta this time. Of course, we never called the method here anywhere. So we need to do that in the controller. And let's actually add some more comments here. So get search query. And the code itself is actually pretty self-explanatory. And so many developers will tell you you should not comment it. But I think that this is actually very helpful when you read the code in like 1 or 2 years from now. So I would advise you to always write comments like this, even if your code seems pretty obvious, especially when it's like a bigger list of instructions like this. So render results. So right now our rendering is only a console.log. But here, when we get the search query, we can actually then immediately also clear it afterwards. Or in fact, in order to keep this controller even simpler, we can do that right in the getQuery method. So let's go back here. And now we can make this private, so we're not going to use it outside. And then let's actually call it here. So this dot clear input. And then, of course, we first need to store this somewhere here. So we get the query, then we clear the field, and then we return the query. All right, so that should now work. So pasta, it clears the field and gives us our 45 results down here about pasta. Great. So that works just fine. And so all there's left to do is to now implement actually the view. So the second view basically, so the one that is responsible for then rendering all the results here in this sidebar. And so that's going to be a little bit of work. So let's leave that for the next video. Let's now render the search results by creating a new view. So we already have the search view, but now we also want to create like a results view. So a results view which will contain a render so that we can then call that render here with these search results. So similar to what we have here, so to the recipe view, which also has a render method which takes in some data. And so now, again, we want the same for a results view. So we also wanted to have a render method which takes in data and which is then rendered to our user interface. So let's create the results view.js. So results view. And so now this view will actually be pretty similar to the recipe view. So we don't need that one anymore. But now, again, this one is going to be very similar. So we will have a parent element, data, these messages. We will basically also need the same render method, the same render spinner. So we will need to display the spinner while the data is being fetched. So in this case, the search results. We might need to also render an error. And so now it's time to basically refactor this code and create a parent class. So I had mentioned that before, but now it's actually time to do it. Because by creating a parent class, we will then be able to reuse all of these methods on all the views. So basically on all the objects that are created through all the view classes. So let's create yet another file here. And I'm calling it view.js. And so let's create a new class here called view. And so we will then export immediately this class. And actually, let's make it a default export. So this time we are actually exporting the class itself because, of course, we are not going to create any instance of this view. We will only use it as a parent class of these other child views. All right. Here in the recipe view, let's now import that parent class. So import view as, or actually not as, but from view. And actually we don't even need the JS, but I like to keep it there for consistency. And so now all we need to do is to basically copy everything that should be common to all the views to that parent class. However, there is one thing that we still need to change here. And that is that right now, with Parcel and Babel, inheritance between these truly private fields and methods doesn't really work yet. So here it was nice to actually use the native way of JavaScript of protected methods and properties, but now we cannot really use it anymore. So maybe that might be possible at some point in the future, but for now, we will have to go back to protected fields and protected methods. So let's basically select all of these hash symbols. And actually, I will select them like this. So with the dot, because otherwise that will also select these ones. So hitting Command D here a couple of times. And then replace it with dot underscore. And now we just have to change these method names. So changing from truly private to only protected using the underscore convention, and then the same right here. Okay. So now our code should still be working. It says here connection lost, but indeed, our code keeps working here. Okay, let's just check out the search view. And so let's use the same convention here as well. Okay, just here as well. And now here we also converted everything successfully. But anyway, let's now basically extract the view class from this recipe view. So what we need in all the views is this render method, then this one as well, this one, and basically everything except for generating the markup, because that of course is going to be unique to every single view, right? And also adding the handler. But everything else we want to be the same on all the views. For example, rendering the spinner will be really easy. So all the views will simply have this method, and we will then be able to call it on that method. And thanks to the parent element property here, it will then know exactly to which element it should attach the spinner. Because again, the parent element, of course, will be unique to each single view. So the parent element will be unique, the message, so these two messages, but this data can actually also be on the parent. So let's copy all of this here, or actually cut. So everything except for adding the handlers and generating the markup. So let's put that here. And here we of course then need to extend this one. So extends view, right? And so let's see if we have everything still in place. Yeah, so I'm confident that this will work now. So let's see. Oh, and icons is not defined. So let's go back here to our view where we will have to copy this one. Because here, of course, we are also using the icons. Okay, but here it is. All right, so we successfully extracted the view class from the recipe view. And now all that's left here is really what is unique to this view. And so this makes this even easier to work with, in my opinion. Because now let's see what we can do here. So even without any code yet in the results view, we will already be able to add a spinner to the search results. All right, well, we cannot really leave it empty. We still need actually the parent element here. All right, and we also need to import the view. So import view, and then this is just another child class of view. Then here we need to say that parent element should be, well, something, and let's check out what it actually should be. So here in index, let's see. So it's this here. So this result element, so this unordered list. All right, and then basically each of the search results will be one of these preview elements. But more about that later. So for now, let's just set the parent element to this results elements here in result view. So document.query selector results, and then we have to export default just like before, and then a new instance of this view. And so this way there can only be one results view, and then here in the controller we can immediately import that without having to create the instance here manually. So that's results view like this. And so now here we should already be able to load the spinner, or actually to display the spinner. So let's do that at the very beginning. So results view dot render spinner, and let's see what happens. So pizza, and here is a small error. And so let's once again do some debugging here. And I hope that you can appreciate that I'm actually not cutting out all these like small debugging sessions so that you can actually see what I'm doing here. But anyway, apparently the problem appears here in Vue.js at line 14. So right here, so it seems like it cannot find the parent element. So let's simply log that to the console. So this here is the result of doing that for the view. And now let's see. So now that is undefined. So to me, it seems like here we selected the wrong element here, maybe. So results. So that should actually be correct. And so should the name. So I think parent element is correctly spelled. Oh, but it's actually called parent element all written out. Okay. So you see it's actually called parent element like this. For some reason I thought it was called just like the abbreviation. Ah, and you see here is the nice loading spinner spinning away here in our search results, right? And again, all without writing any new code for displaying that spinner here in the results view, because it is now simply inheriting that method, so that render spinner method from its parent class. So let's get rid of this. And just for the sake of curiosity, let's actually take a look at this results view. So just so we can see the whole prototype chain here in the console. So for that, we need that controller to run. And so here it is. So you see that we have still some undefined data. Then we have the parent element, so the one we selected. And then we get, well, right now we don't have any methods in the class already, but we do have methods in the parent class. And so these are the ones, right? So the render one that we're gonna use next, then render error and spinner and message. So it's always good to remember these things so that we still know how everything actually works behind the scenes. But now it's actually time to create basically this generate markup method also in the results view. Okay, so all the child views should have this method here, because in the view, the render method then actually relies on that. Okay, so this dot generate markup needs to exist in order for the render method then being able to create the markup and render it, or to insert that HTML into the DOM. And so let's take that, just that name, and create that right here. So as always, add template, literal, and then now it's time to actually get this code here. Okay, and this here is called a preview because we will actually use the same thing later here to render the bookmarks. So that's going to be a nice trick, but we will save that for the future. Okay, some more indentation here on all of this to make it look great. And so now we need to take our data and actually put that right here. Now, where actually is that search results data? So with all of this structure, it might be a little bit hard to follow where that data is. So let me actually start by calling the render method here. So here, besides of simply logging the search results, we now also want results view dot render, because of course, just like render spinner, the results view also inherits render, and then into that we pass whatever we want to be rendered. And so that is all of this. Okay, and then in the render, here we see that it takes this data and puts it into this .data. And so here, if we then take a look at the results view, let's simply log that then to the console. So this .data. And so this .data here should basically be exactly this search results. So let's see. And it is. So you see that twice we now get this array. And you also see that it already printed something here to the results. So that is that pre-formatted HTML that we already created here. So it's already basically this HTML, right? Because this method here is already returning that. And so then the view takes that data and renders it on the user interface. Okay. And so let's now actually create this method. Now, this is actually an array now. And so here we need to loop over that array. So in fact, we don't want to return simply this, but instead we want to return a whole string which contains like one of these elements for each of the search results in the array. So we will return basically this .data, and then we map over it. Remember? So we did that before with the ingredients. And then at the end, we join everything together. And so then that will be the string that we return here. Now, we could now go ahead and put this code here into the map function, but instead I will create just another method down here to make this a little bit cleaner. Let me copy this name, preview. And I'm simply calling it this because that's also the class name. So let's put this one here. And so then here we can call the method. Oh, what was that? So we can call it right here then. And so now this should like print 50 or 60 of the same. So just to see if it works. And indeed, here it is. So 59 results, and so it prints this 59 times right here now. Right? Now all we need to do is to fill it with the real data. So with the ID, image, publisher, and title. Okay? So to start, we need the ID here in order to build the link. And so then when we click the link, that will change the hash in the URL, which in turn will trigger loading a recipe. So that's what we did by the beginning of this section. Now here we need to pass in the result then. And so here that is result.id. Then here it's the image. So .image, here it's the title. And then here the publisher. Okay. Now here we also need to replace the icons. So we will need, again, the icons right here. We will probably need them in all of them. So but that should be it. And it works. Beautiful. So we get all of these search results here. We just have to fix some small details. But you see that it's already working. And now let's click on one of them And it works. Minimizing this a little bit. And so you see that now we get exactly the recipe that we are clicking on here. So watch what happens with the ID when I click here on pizza casserole or casseroli or whatever. So it changed the ID up there and changed the recipe here also in the view. Great. Now let's just fix this icon here, and actually also here. And then also all of these should not be highlighted. We will take care of that a little bit later. So we need to take away this class here of active. And here we also need to take away this. Okay, and we will come back to this later again when we actually start to implement uploading our own recipes. And here in the alt text, we should just put that title as well. Okay, now you see that actually the state that we had here before in the page is gone. And so let's activate that hot module reloading that I mentioned in the last section. So remember that with parcel, we can do this. So if module.hot, then module.hot.accept. All right. And again, this is not real JavaScript, at least this module.hot. This is simply coming from parcel. All right. And now finally, let's also delete these fake links that we had before. Let's reload. And that looks a lot better. Okay, so let me now change something in the code. For example, getting rid of this console.log here. And so previously, that would then reload the entire page. But now, as we go back, you see that the state here actually remains. All right. All it says is the console was cleared, but that's it. So the rest remains the same. And we can now also delete this user icon from the recipe view. So let's see where that is. It is simply this div here. And so once again, it will now not re-render everything. Well, maybe we should re-render. And yeah, now it's gone. Well, it also messed up our button here for some reason. So maybe that was not intended. Maybe I should just remove this here. So basically keeping an empty div. Okay, so for the time being, let's just leave it like this. Okay, now let's just see what happens when we search something that for sure does not exist. So you see that here we still get a success. You see? So we still get that data, but the only difference is that the recipes array is now empty. And here we also see that the array is empty coming from the state. So in this case, we actually want to render like an error message here saying that there was no results for that query. So let's start by creating also the error message property here. So let's copy these two actually to our results view. And here let's say no recipes found for your query. Please try again. But now, how exactly will we actually display this error message on the parent element? So we could do that right here in generate markup and basically check if the array is empty, and if it is so, then render the error message. So that would work. However, we can also do that directly in the render method. So automatically, right as we receive the data. And I believe that is what makes more sense. So right in the beginning, when the render method is first called and receives the data for the first time, we can immediately check if that data actually exists. So right now, we only simply assumed that there always is data and that we can then generate some markup with that data. But as always, it's a good idea to check if the data actually exists. And that is true no matter if we receive a simple object or if we receive an entire array of objects, which is the case of the results. So let's add a guard clause here. So if there is no data, then we want to return immediately, and we also want to render the error. So we can do that all in one line, and this will then still work. So this dot render error, and we actually don't even have to pass in any message because we already automatically get the message from this dot error message. And so in this case, that is going to be this one that we just specified before, right? Now, however, in this case, this check is actually not enough because in fact, we do get data. It's just an empty array. And so in this case, we also want to treat the empty array as though we had no data. So this here basically only works for undefined or for null. But now we also want to check if the received data is an array and if it is empty. So we can do that by saying, so if there is no data or, and then basically if the data is an array and if it's empty. And we can do that by using a helper function that is on the array constructor, which is array. So we can check that. And so if it's an array and the length of the array is 0, basically, data.length 0, well, then in this case, exit this function immediately and also render the error. Okay? So again, if there is no data, or if there is data, but that data is an array and it is empty. So in both these cases, we want the error to be shown. So let's check that. So with pizza, it all works the same because there are results. But now with this, there are no results. And then we get our error message. So great, that works. And so I think we are done actually with this part. So just one more look at our flowchart. So we implemented the event that the user searches, we asynchronously loaded the search results, and then we also rendered them to our user interface. And so with that, we are done, right? Just a final look here at the controller, but everything looks good. So in the next lecture, we will actually take care of the problem that we have these 59 results all one after another here. So that's not good. And so we will implement pagination in the next 2 lectures. Welcome back to the next feature of the Forkify application. And this one is going to be pagination. So let's take a look at our current implementation of the search to get an idea what the problem is. So you see we have 59 results for pizza, but now all of these results are displayed here basically at once, right? And so this is not user-friendly at all. So in the final demo application, we only have 10 results on this page, and then we can go to the next page and basically get the next 10 results. And so that's what we want to do right now in our application as well. Now this problem is actually harder to solve than it might seem like. But I'm sure that together we can do it. So let's think about what we have to do here. So remember that it is the control search results function that is responsible for rendering the search results right here. And currently we are simply rendering all the search results like this. However, in the first page, we only want to render 10 results and not all of the results, right? And then if we're on page 1, we want to render the second 10 results. So from result 11 to result 20. And so let's basically create a function in our model which will take in the page that we want to render and which will then only return the results that we actually want to render for that page. Okay? And that's actually not so difficult. So let's create a new function here and also export it. And let's call it get search results page. So a function. And this one is of course not going to be an async function because we already have the search results loaded at this point. So at the point when we will call this function. All we want to do in this function is basically reach into the state and then get the data for the page that is being requested. So what we will return here is basically a part of the results. So let's write that here because that will be helpful to understand the logic we need to write here. So we will return state.search.results, which remember is this array here, right? And then we only want to return part of it. And so that's a slice. So again, for the first page, we would like to return from result 1 to result 10. And so that would be 0 to 9, actually, because the array is 0 based. Now, of course, we're not going to hard code these values here, but we can basically calculate them based on the page. So let me try that. So we will basically create a start variable. So let's set that to 0 for now. So basically having the same values as here. And also an end variable. So we want to start at a certain point and then also end at a certain point, right? But again, we don't want to hard code these values, of course, but instead we want to calculate them dynamically. So here we will want a 9 and here a 0. And so how can we calculate that? Well, the easiest way that everyone does it, or at least I think that's the way that everyone does it, is to take the page and then -1, and then simply multiply it by the amount of results that we want on the page. So let's say 10 here for now. And then here we do the same simply with page. So page times 10. Okay. So let's say that we requested page 1. So 1 minus 1 is 0, and 0 times 10 is then 0. So just as we wanted. And for the end parameter, then page is 1 times 10 is 10. And actually the slice method here does not include the last value that we pass in. And so actually 10 is perfect here. So that will then extract all the way to 9. Now, one page is 2. So for page 2, then here we will have 2 minus 1 is 1 times 10, 10. So it will start at 10 and then go to 2 times 10, which is 20. And the same for all the other pages that we pass in. And so this is actually already it. Now let's just refactor this code because, of course, this here is an important data about our application. And so it should go into the state. Okay. So let's call that results per page. And so let's set it to 10. So here instead of 10, we have state.search.results per page. So that's a lot better. But actually we can do even better because this here now looks kind of like a magic number, right? So a number that comes out of nowhere. And so I think you can see where I'm going with this. So I will create another constant in our configuration file, and then if at some point in the future we want to change the configuration, in this case of the results we want per page, we can simply come here to the configuration file and change that. So let's import that. So that's right here. Replace that here. And so that should work just fine now. Okay, and now let's go back to our controller. And so again, this is the way we did it previously. So all the results, but now we only want some results. And so we can now call that function that we just created. So model.getSearchResults. And then let's say we want to start with page 1. And of course, we will then later on get this value here dynamically. But for now, we just want to see if this actually works. So let's see. And let's search here again for pizza. So again, 59 results. But we still get all the results here for some reason. So let's only log this here to the console. So just to see what our function here is doing. Well, apparently it doesn't really do anything. So get search results per page. I think that is the correct name. So that should actually work. Well, let's just log something here just so we see if this function is actually being executed. So start and end. Well, nothing is happening here for some reason. Maybe we need to stop parcel. Sometimes that is necessary. And then run it again. So let's build it all again. Let's also try it again. And now it seems to work. And indeed, now we only get 10 results. So sometimes you actually have to stop and restart parcel. This isn't the first time that this has happened to me. And probably I should have warned you about this problem also earlier. But anyway, now we see that this actually worked. So great. Then we can get rid of this and also of this console.log right here. Okay, now let's try something else, like page 2. But apparently it didn't change anything. Maybe we just have to turn off the hot module reload. Let's try that. Now I think that these 10 here are different. Or are they? Well, I'm not sure. Let's try page number 3. So we started with pizza dip. So let's see what we get this time at first. Yeah, so these actually look new to me. So it looks like currently we are indeed on page number 3. Okay, and now just to finish this part, here in our model, we should also store this page number that is coming in this state. And that's going to be important because later when we will display the page number here, then we kind of need to know at which page we actually are. Okay, and so this really makes sense because again, this is a very important piece of data about our application. And so it's good that in any point of time, we can know in our application on which page we currently are in the search results. So let's simply say state.search.page is equal to page. And then let's actually also set it up here. So the page, we can set it to 1 by default. Okay. And then finally, we can make this even better and say that by default, the page should be that default. So state.search.page. And so now if we don't pass anything into the page, then the page will simply become the default of 1 that we just set before. So we can remove that 1 from there, and it should then still be working in our own version. So pasta this time. And yeah, so here we get our 10 results. And so we are done with this part, but this was actually the easy part, because now we need to render the pagination buttons here. And so let's leave that for the next video. So let's now finish building the pagination feature. And for that, let's actually think about some different scenarios. And to do that, I will actually come here to the demo. So the buttons that we want to render down here are not always the same. So in this first scenario, we are on page 1. And so therefore, only this next button here is showing, right? But there is, of course, no button to go back. Now, if we had actually less than 10 results, so basically only 1 search page, then there would be no buttons at all. Then, if we are on some other page, which is not the first page, well, then we have a button to go back and one to go forward. So that is basically the third scenario. And then if we go all the way to the last page, then we only have a button to go back. And so we have to account for all of these different scenarios. Okay, so let's go back and basically implement a new view for this pagination. So here in the views, we create a new file called paginationview.js. And here let's actually copy some code from here so you don't have the same work over and over again. Then of course this one here is called pagination view, and the parent element is not this one. So let's go check out our markup. And so here we already are at the right element. So you see that after this unordered list of results, we have this div element with the class of pagination. And so then this one here already contains the template for a button to go back, so to the previous page, and one button to go to the next page. So we're going to need this soon, but for now let's just complete this setup here. Okay. And so now, just as all the other classes, we will have a generate markup method here. Generate markup. Because remember, that is the method that the render method is going to call in order to generate the markup for the view that we're working on. Right? So again, every view, at least every view that renders something to the user interface, needs a generate markup method. So that's this one here. And so now let's account for these different scenarios that we just saw. So let's say the first one is we are at page 1 and there are other pages. Then the next one is we are on page 1 and there are no other pages. Then there is the scenario that we are on the last page, and also the scenario that we are on some other page, basically. So other page like this. Okay, so what data do we need in order to figure out if we are on page 1 and if there are other pages? Well, for that we are going to need basically this entire search object here. So this contains all the search results, also the current page and the results per page. And so we will need all of this data in order to compute which buttons should be displayed. All right. And so let's actually go to our controller and already call the render function so that we can pass in the data that we need and so that we can then use it. And well, when do we actually want to display the pagination? Well, it is actually right at the moment when we are also displaying the search results. So we will actually do that right here after displaying the results. So we get the search query, load the search results, render the results, and then also render the initial pagination buttons. And so now here we actually need to export this view so that we can then import it into the controller. So just like we have been doing in all the other views, we say export default and then a new pagination view object. And so then we come here and import that. So results becomes pagination. And now, of course, that view has a render method on it. So pagination view dot render. And here we need to pass in basically the entire search object. So state dot search. And actually that's model dot state dot search. And so now through the magic of this view class here, we now get access to this data that we just passed in this dot underscore data. Right? So right here, this dot underscore data is now the entire search results object, basically. So in order to figure out if we are on page 1 and there are other pages, we need to know how many pages there are. So let's compute that. So const num pages. And how do we actually know the number of pages? Well, basically we need the number of results divided by the number of results per page, right? So for example, if we had 60 results and 10 results per page, then we had 6 pages. So the number of results comes from this dot data dot results. So let's check that in the model here again. So results, again, is the entire array which contains all the search results. And then we also have results per page, which is this configuration constant that we set to 10. Remember? So let me copy this. And then here we will divide that. So this dot data dot results per page. And this is a very important variable. So let's start by logging it to the console. And with this, we will then also know if we correctly hooked everything up here. So basically, if this render here of the pagination view is already doing its work. So let's see. Searching for pizza. Well, here we get some, not a number. And of course, well, here actually we already have something rendered. And so that's undefined because right now we are not returning anything from this function. And so if we don't return anything, by default, undefined is returned. And so that's 10 basically rendered here to the page. But anyway, what matters here is that for some reason we got not a number. So that means, and I know why here. So here, this is the entire array, right? So we are dividing this array by the number. But of course, what we want is the length of the array. So let's try that again. Yeah, now we get 5.9 pages. And of course, we now need to round that to the next highest integer. And so for that, we simply use math.ceil. Remember? And so this will now become 6. Okay, so let's do some check here. So if we're currently on page 1, which is this dot data dot page equals 1. And so now it is very important that we actually have the current page in the state, right? So that's why we put it right here. So whenever the get search results page method is being called with some value. So just to illustrate this, let's actually render the results at page 2, just to then test if what we have here works. But anyway, here we are testing if we're on page 1. And so that's this.data.page equals 1, and there are other pages. And so basically that means that the current page needs to be less than the number of pages. And so that basically means that number of pages here is greater than 1. So num pages greater than 1. So this is our first if check. Let's actually log that to the console. Page 1 and others. Or actually, let's even return that string, because we already know that this will then get printed. Even though, of course, this is not at all what we want. Now this one here we will leave to the end. So let's continue with this one. So being on the last page basically means that the current page is the same as the number of pages, right? So data.page is equal the number of pages. So in the current example, we have 6 pages. And so if the current page is number 6, well, then that means we are on the last page. So here let's return last page. Then here some other page basically simply means that the current page is less than the number of pages. And if any of what I'm saying doesn't make sense, then probably the best thing to do is to pause the video and think about this on your own. So that's always my advice. So basically reflecting on what I'm saying is usually the best solution to really figuring out what exactly it is what I'm doing here. So of course I'm trying my best to explain everything, but at a certain point you also have to take a look at the code and think about it on your own a bit. But anyway, this actually already covers all of the scenarios. So if none of these scenarios here is met, then that basically means that we are on page 1 and there are no other pages. And so in this case, we can return only one page. And actually that is not really true, because let's say that we only had 1, so that num page would be 1, then actually this here would also be true. So here we have to add the same as before. So num pages needs to be also greater than 1. So then we are really on the last page and need to render some other buttons. So, but to test this, let's keep in mind that we are currently on page 2. And so therefore we want to now see other page rendered. So let's see. And indeed, there we have other page. Now let's try page number 6. So here we see we have 6 pages. And so now it says last page. Great. And now page number 1. And so one more time. And so page 1, but there are other pages. Great. So this was, I think, the hardest part. So figuring out these different scenarios. And now all we need to do is to create the markup. So let's come here to the HTML and grab this code. So this is the code for going to the previous page. So when do we want to go to the previous page? Well, for example, right here on the last page, right? So here, in fact, we only want exactly that one button. Now, what is the page here that we want to go to? So we need this number here. Well, that page is basically the current one minus 1, right? So we are using this data.page a lot of times. So let's store that in a variable. So yeah, const current page is this. And so now let's replace that everywhere here with current page. So here we will then want the current page minus 1. And here we need to replace the icons. Okay. Then here on page 1, we basically need the opposite. So again, we only want just one button, but the one to go to the next page. So let's grab it. And actually, it's almost the same markup. So another nice template literal. And now here it says page 3. And so, of course, here we will now want to go to the current page plus 1. Right? And then here again, we need to replace the icons. Okay. And then here for the other page, we want basically both of them. So let's return this, or actually this one here. So first the button to go back. And then also add the button to go forward. All right. And then when we're on page 1, then we simply return nothing, because here we don't want to render any button. So if there are no other pages, there's nowhere to go, of course. All right. So let's see what page we are currently on. So page 1. And so that should render. And so that should render then this button here. So saying page 2. So let's see. And indeed, page 2. Now, of course, if we click here, then nothing's going to happen. But for now, that is not the point. Let's try page number 4 now. So go back to page 3 or forward to page 5. So beautiful. So it looks like it's working. Let's just try the last page here now. Oh, what's going on here? And indeed, it says to go back to page 5, but no page to go forward. So that's awesome. Now the next thing that we need to do here is to then add an event listener to these buttons so that we can then actually go back and display another page. So right now, this is not useful at all, but at least we already have our buttons here showing up right in the beginning when the search results are loaded. Okay. Now, this code here could, of course, be refactored because we are repeating a lot of code here. So this button is the same as this next button, and the previous button is also the same here. Okay, so we could refactor that, but I will actually not do it here and instead leave it for you as a challenge. So you might create a method called, for example, generate markup button, and then refactor that code in that method. But here, I'm not going to waste any more time, and instead I will go immediately to adding the event listener. Now, just like before, we need to use the publisher subscriber pattern, just like we did, for example, here in the recipe view. remember? So again, that works by creating a publisher, which is basically a function which is the one listening for the event, which receives a handler function, which in our case is going to be a controller that lives here in the controller. And so with this, we will then be able to listen for the event here in the view where it makes sense, while at the same time being able to handle that event from the controller, basically. Okay? So let's add that method here. So add handler, and I'm just calling it click. So for click on one of the buttons. Okay. Now here we are going to use event delegation because there are going to be two buttons, but of course we don't want to listen to each of them individually. So instead we will add the event listener to the common parent element, which is indeed this dot parent element. So dot add event listener, and this time finally listening for a click. And then here we have a function, because we cannot immediately call the handler that comes in here, because first we will need to figure out which button was actually clicked based on the event. So that's event delegation, and I hope you remember how it works. So in this case, we can simply create a button element and select the closest button element to the clicked element. So the clicked element is e.target, and then closest, which is really an amazing method. And so here we can now basically look for this button. So for the element with this class. All right. So remember that the closest method is a little bit like query selector, but instead for searching down in the tree, so for children, it basically searches up in the tree. So it looks for parents. And this is important because here in the button, we might actually click on this span element or on this SVG or this use instead of clicking on the button itself. So we cannot simply set the button to e.target, but we actually need to search for the closest button element itself. And just to see that this works, let's actually now create our controller. So here we will then log that button to the console only for now. All right. And so now let's go to the controller, and as always, create a new controller here. So basically, this is the controller that will be executed whenever a click on one of the buttons happens. So control pagination is a function which for now doesn't really do anything. Let's just call it pag controller. So simply logging this to the console. But what matters here is that now we call the pagination view and add handler click. And so this will then, of course, call this function here, which in turn will call add event listener so that we can start listening for the click event on this pagination element. Okay. Now here we also pass in the handler. So that's control pagination. And so just again to check if everything is working, let's simply also call that handler right here. So once we click on the button now, we should see this button logged to the console, and then also the handler function should run, which is of course this one. And so that should then log pag controller. So let's see. So looks like we're still on the last page. Let's click, and yeah, so everything works as expected. We have the button correctly selected, and it also says pagination controller. Great. So now we have the click on the button, so it is correctly selected. But why did we actually select the button? Well, we need a way of knowing which is the page where we need to go now. So it says here page 5, but how will JavaScript know that it should now actually display the results of page number 5 here? Well, this is where we one more time need to basically establish a connection between the DOM and our code. And so remember that we can do that using the custom data attributes. So what we will do here is to create a data attribute on each of the buttons, which will contain the page that we want to go to. And so then in our code, we can read that data and make JavaScript or make our application go to that exact page. And so this is basically the final piece of the puzzle. Okay, so here in our button, let's now add that data attribute. So data, and I'm going to call it go to. And so the page we want to go to is exactly the same as this one. So basically exactly the same that it says in the button text itself. So now let's copy that everywhere. Here it is page number -1. Here again -1. And then here on this, it is page +1, right? And so then here we can actually get that number, of course, from the button. So let's call it go to page, and it is button dot data set dot go to. And then let's log that to the console. All right. And actually, let's go to some other page. So basically start this here on page 4, just so we have 2 buttons. Very weird what's happening here with the scroll. But anyway, here we have now the buttons for page 3 and 5. So let's click. And indeed, here we have the 5, and we also successfully read the 5 here. Now you see that this is here like kind of in this white, while this here is purple. So remember that purple here means a number, and so this is still a string, and so we will need to convert that. But another thing that I wanted to show you is that, of course, we can also click outside of one of the buttons, right? And so then here the button is, of course, null, and we get an error by trying to read the data set. So let's first convert that value we get from the user interface, but all of this should only happen if there actually is a button. So yet another guard clause here saying if there is no button, then return immediately. Okay. So let's try another one now, pasta. And if we click now, then here we get the number 3, and here the number 5, right? So what are we going to do now with this number? Well, we can simply pass that number back to the controller, basically. And then in the controller, we can finally use that number to actually render the results on the page that we want by using, again, this method here. All right. So these pagination and results controllers are kind of intertwined. So I think that this is a little bit confusing because of that. But if you analyze all of this here, maybe afterwards, you'll see that it makes sense. So we already see that here in the controller, we are rendering the pagination in the beginning. And so here in the pagination, we will later render the new results. But let's not get ahead of ourselves. And so what I want to do now here is to actually pass that page into the handler. Okay. And so, of course, our handler now needs to accept this value. So let's call it again, go to page. And just to see again if this works, log that value to the console. Okay. And indeed, we get page number 5, which is the button that we clicked on, coming from the controller this time. And now, finally, what should actually happen here on the user interface once we click this button? Well, we should get the search results for page number 5, and they should be rendered here, right? And then also new buttons should be rendered too. So this should then change to page 4 and this to page 6. Because when we go forward, then these two values here are of course going to increase. Okay, and so let's simply do that. And we already know how to do it because we already did it before. So remember I said we want to render the results and we want to render the pagination buttons. And so that is exactly what we already have here. And so let's simply copy and paste it right here. So let me change this here to render new results. And then here, render new pagination buttons. And then here, of course, we want not number 4, but we want go to page. And then here, rendering the new pagination buttons is actually going to stay exactly the same, right? So when we do this here, so get search results with this new page, let's say 4, then here in the model, state.search.page gets updated to that new value, right? So the state.search object is then different. And so that is the object that we then pass into rendering the new pagination. And so therefore, it will then render new buttons because the page before has been changed. Okay. And so this should now actually work. Just keep in mind that we will again start at page number 4. Well, let's actually make that page 3. Oh, and before actually checking out the results, I just wanted to say that this actually works because renderer will basically overwrite the markup that was there previously. And the reason for that is that we here have the clear method. And so before any new HTML is inserted into the page, the parent element is first cleared. So it's first emptied, right? And so then that means that render here basically overwrites everything that was there and puts the new content in the same place. But anyway, let's make sure to reload pizza, and we are at page number 3. And now let's see the magic happen. And I hope we don't have any bug here. And it works. So beautiful, beautiful. And congratulations also for you to following up until this point. So this is, I think, up until this point, the most impressive work that we have done. So you see, everything updates here just as expected. We get new content. And now page 6, you see here, will be the last page. So let's see. And yeah, so now we don't have the last button and we can only go back to page 5. So now let's go to the first page. And indeed, we can only now move forward and get the first 10 results here. So really great work here. I'm really happy about this progress here. Now, just to make sure, one more thing, let's try this here with results per page of a different value. So let's say that we actually wanted like only 5 results per page. So then we should get a lot more pages. And so it's important that we check that that actually works. So you see that it does actually work already. So we only have 5 results here now. And we can also already see that we will have 12 pages. Oh, and we are still on page number 3. But now we will be able to go back, or actually to go forward to page number 12. And so each of these pages only has 5 recipes. And now let's just try to search for something that is not very common, like dip, for example. And, well, we still have a couple of pages here, actually. But before we go any further, let's put this here actually to 0, or actually to 1. And remember that passing nothing is basically the same as setting it to 1. So let's try dip here again. But it seems like we have still 6 pages. So I just wanted to find some search term that only has 1 page. Let's try hummus maybe. But we again have 4 pages. Well, we can fake that by having 50 results on 1 page. And so with this, we should already only have 1 page with pasta. So pasta has 45 results, but here we want 50 on 1 page. So we only have 1 page, you see, and indeed, no buttons. Great. Let's put it back to a meaningful value, so 10. And so with this, we are actually done. Let's just clean up our code here a little bit more. But I think that with this, we are now good to call this finished. And actually, we finished now the entire part 1 of our flowchart. Right? So this was already done, this here as well. And now, here what we did was to listen to this event, then render the pagination buttons, and of course, render the corresponding search results. So all of this is now in place. But I ask you to really analyze again the code that we have here in control pagination, as well as here in control search results. Because again, these two controllers, they're kind of intertwined. So they both are doing similar things, at least when it comes to displaying the pagination and the results themselves. So it's very important that you understand the flow of this data here, especially of this go-to page. Okay, and then maybe also analyze again how all of this here works, but then you are good to go to the next video. And so there we will discuss basically our next step, what we should do next. So that next video is going to be a lot shorter so that we can finally take a break from this application. So again, analyze this like I told you to, and then after you're ready, let's go move on to our next part of the flowchart. So we have been making a lot of progress in building our application. And we can actually say already that the core functionality of the app is in fact already working. So now let's take a breath and think a little bit about our next step in this short lecture. So again, the core functionality is what we see here in this flowchart. And so that is basically the search functionality, then also displaying the pagination, and then displaying any recipe that was selected. And so that we already have working at this point. And so that is really great progress. But now let's take it to the next level and think a little bit about how we will implement our next features here. So based on the user stories that we outlined in the beginning of this project, our next feature was a functionality for changing the servings of the displayed recipe. And that's going to be quite easy. All we will have to do is to listen and to handle events on the change servings buttons, and then basically update the recipe and render it again. Then the next feature is the bookmarking functionality. And this is going to be yet another one that will be a little bit complex to implement. So let's see what we have here. So starting with the event here more on the left side, whenever the user bookmarks a certain recipe, then we want to render that bookmarks in the special bookmarks panel. And we also want to update the button in the recipe. And so basically, we will then re-render the recipe. Now then, whenever the user clicks one of the bookmarks, and so that's the other event down there, then we want to render exactly that recipe that was clicked. Okay, so here we will need 2 events, and by the time we reach this functionality, we will of course see in more detail how it's going to work. Then next up, we want to be able to store this personalized bookmark data in the browser and also read it back when the page is loaded for the next time. And so that's exactly what is here on this diagram. So whenever there is a new bookmark, we basically store all the bookmarks to local storage, and then when the page loads, then we load all the bookmarks back from the local storage and render them. All right, and so that's actually it. So this is what we will do over the next couple of lectures, and once we're done with that, the application will actually almost be finished. Okay, so that is our plan for the next couple of lectures, and so let's now go back to code and implement the functionality of changing the servings right in the next lecture.